Hey, what's up everyone and welcome to Spring Boot Masterclass or Spring Boot Complete Boot Camp by Daily Code Buffer. So in this particular video, we are going to have a lot of fun and we are going to learn a lot of things. So let's see what we are going to learn today. So what we are going to cover in this particular entire Spring Boot Masterclass is, these are the topics that will be what's and whys of Spring Framework. We will be going through the all of Spring Boot, how to start with the Spring Boot and how to go ahead with all the Spring Boot components and how to create all the different REST APIs, all the different methods, how to create the entire application with the help of Spring Boot. We are going to also learn about the JUnit and Mockito, how to create the unit testings, how to write the unit testings for all the different components that we are going to build. So we are going to build controller layers, service layer, repository layers. For all those type of components, we are going to learn how to create the test cases, and also we are going to learn how to write a integrated test as well using JUnit and Mockito. We are also going to learn Spring Data JPA, and with that, we are going to use the MySQL database, and we are also going to use the H2 in-memory database. We will see how both can be used, and we are going to see how the Spring Data JPA gives us the ease to create different queries and how to interact with the database from your Spring Boot application. And we are also going to learn about the Spring Security. We will be implementing the entire Spring Security within our Spring Boot application, and we are going to also implement the authorization server, authorization client, resources with Auth2 and OpenID Connect. So this is going to be a jam-packed course. Let's also see what are the different topics that we are going to cover for each and every topics that we have mentioned. So for what's and whys of Spring, we are going to learn about what is Spring Framework. You need to understand the foundation of Spring Framework. And we are also going to see what are the advantages of the Spring Framework and what is the life cycle of a bean, how your beans are created, how you define the dependency injection in the Spring Framework, and what is the Spring AOP, that is the aspect oriented programming. So these are the very core concepts of a Spring Framework which will help you to learn more on the Spring Boot. So these are all the concepts that are being used in the Spring Boot. So once you grab all these concepts, it will be very easy for you to grab the Spring Boot framework, because once you understand all these concepts and then you switch to Spring Boot to start learning Spring Boot, you will get the aha moment. Okay, these are the lot of things that I don't have to do. Okay, because these are already done by the auto configuration of Spring Boot. So you will be able to understand a lot of things in detail. Now within the Spring Boot module, what we are going to learn is what is Spring Boot, why Spring Boot came into existence, what are the advantages it gives to a developer, how developer friendly the Spring Boot framework is, and we are going to see how to build our REST APIs using Spring Boot framework. So we will be creating all the different APIs to create the data, update the data, to get the data, to get all the data. Seems like a complete CRUD application where these are the general operations you will do in your day-to-day work. So we will be seeing all those things in detail, and we are going to write the unit test cases for each and everything that we develop. So we are going to write a unit test case using JUnit and Mockito for our controller layer, for our service layer, for our repository layer, everything. And we are also going to write the integration test as well to test out each and every component together. So in the Spring Data module, we are going to learn about the JPA, that is the Java Persistence API, and we are going to learn about how Spring Data JPA uses that JPA and how it uses the Hibernate and give us the lot of different functionalities to directly interact with the database. So there are a lot of features that are directly built into the API which we can directly use, and if you want to enhance, we can also enhance all those APIs. We can write our own custom queries and everything. So that's when we are going to also learn about the Hibernate as well. And we are also going to learn about the different entity relationships in the Hibernate. We are going to learn about the one-to-one relationship. We are going to learn about the one-to-many relationship, many-to-many relationships, unidirectional relationships, bidirectional relationships, and all of those things. Then we are going to learn about the Spring Security, which is a very important part. And this is where every developer feels little bit hesitated to learn, because at the starting it feels little bit complex, but once you understand the concepts, once you understand the all the jargons that are being used, it is very easy to implement. So we are going to learn about the Spring Security, how to implement Spring Security in your Spring Boot project. And we are also going to learn about the Auth 2.0 and OpenID Connect. What is Auth 2.0 and how we can implement that in our project. And we are going to see a complete flow in which we will include registering a user with a verification code, resend a verification code, forgot password, reset password, and a complete login flow with the help of Auth 2.0. And This will all be implemented using a token based authentication, which will allow us to create the different resource servers. These are the concepts available in your Auth 2.0. So we'll be creating resource servers, we'll be creating clients, we will be creating authorization servers. So all this will connect together and you can create your application. So these are the things that we are going to learn in our entire Spring Boot masterclass. Now to get the most out of this course, these are the prerequisites that you should know. That is the Java. You should be familiar with the Java programming because we'll be coding everything in Java. I will be teaching you each and everything about the Spring and Spring Boot, but the basic syntax of Java, how to create a Java program, all you should know. These are the basic things. And if you know the basics of Servlet, that's the advantage. But we will be going through each and everything in this tutorial. And the main important thing, you should be having the enthusiasm to learn all these things because this is going to be a very long masterclass. You should be going through each and every topics in detail. And while we are doing the coding, you should also practice alongside. It should not be like you just go through the tutorial and you don't practice it. You have to practice it and then only you will be able to understand each and every concepts. Then what are the software requirements? So you should be having Java installed. I'll be using Java 11 in the entire course. So if you use that, it will be very easy for you to follow, but you can use any Java version. Make sure that you are using Java compatible with your IDE that you are using. I'll be using the IntelliJ IDEA ID. You can use IntelliJ IDEA if you want. That's a community edition which is free of cost that you can use for learning purposes. There is Eclipse as well, Spring Tool Suite as well. You can use anything. You can use VS Code as well, and you can install all the different plugins available to support the Java project. And I'll be using Maven 3 Plus. So Maven 3 Plus you can install and you can configure in your variables. And I'll be using the MySQL database. So you can install MySQL Server and Workbench. So I'll be showing you all those things. So you can install directly, go to Google and you can install all those stuffs and it will be easy for you to follow. And by any means you're not able to install it, then you can let me know in the comment section below, or you can use the H2 in memory database as well. I'll be showing you all those things in the tutorial. So that's all about the course. And if you have any queries, any issues, then you can reach me out to my Twitter handle or Instagram. These are the handles. You can reach me out at Daily Code Buffer on Twitter and Daily Code Buffer on Instagram. You can follow me there. I will be posting a lot of contents there and you can DM me as well. I'll try to help you out. I will try to answer your questions. If not, there is a comment section always. If you have any queries, comment it down and I will try to help you out as soon as possible. So that's it. Grab a cup of your coffee and let's start our masterclass. If you're new around here, welcome to Daily Code Buffer and this is Shabir. I will try to teach you whatever I know and whatever I have learned using this all tutorials. Now first let's see why frameworks first of all, right? So if you're working with any of the programming languages, or in this particular video, let's take the example of Java. Java gives us a lot of features and advantages to build the application. But when we are trying to build the enterprise applications, when you are trying to build the business applications, right, at the time we have to concentrate more on the business logics. At that time we don't have to work around, or we don't want to work with the basic boilerplate codes or the basic necessities or basic cross-cutting concerns, we can say, right? So we'll be doing many things like security, like logging, like configurations, like batch processing, scheduling, many things, right? So these all things directly doing with Java without any frameworks, it will take a lot of time. So frameworks comes into picture at that time. Like frameworks are the way that will provide a lot of basic structure, basic functionalities that we can work upon, and we can mainly concentrate on our business implementation. So Spring is not the first framework. There are a lot of frameworks available for Java, but why Spring is more popular, that we can understand using the advantages of the Spring framework. So Spring is just the another framework like other frameworks available for Java or the other frameworks available for the other programming languages. It gives us a lot of features so we can work upon. It gives us like logging, security, it gives us dependency injections, it gives us scheduling, batch processing, and a lot of things. There are a lot of modules available within the Spring framework. It's a suite of framework, right? It's also called as framework of frameworks. We'll get to that part later, why it's called frameworks of frameworks. But Spring started as a small project and now it's really huge. So let's see the different features of Spring framework first. So the first thing Spring allows us is to inversion of control. What is inversion of control? Inversion of control is nothing but to give the control to the framework itself. You don't have to take the control yourself. You don't have to create every objects or whatever you want to do in your application by yourself, because consider there are thousands of classes that you have created, and for each and every time you are creating the objects and you are destroying the objects for the garbage collection, it's a tedious job. We have to work on the business logic. What we are doing is we are giving the control to the framework itself. Okay, so that is responsible for doing everything. To do that, Spring allows the dependency injection. So we need to understand what is dependency injection. That will cover in detail later on. In a nutshell, dependency injection is nothing but to give the dependencies of different classes into the different classes. Suppose one class needs the object of the other class, then we will give the control to Spring to add those particular dependencies. We won't be adding those dependencies. We will see later how we can do that as well. The other thing Spring provides us is the aspect oriented programming, that is Spring AOP. Now, what is aspect oriented programming? Aspect oriented programming is nothing but to tackle down the cross cutting concerns, because when you are building the application, there are a lot of things that we might do repeatedly, like logging the user data, whatever the logs we generate, right? Doing logging in, doing securities. So this type of things that we have to do for each and every request that's coming from the server. So to do those things every time, it's a tedious job. So what we do is we separate out all those cross-cutting concerns and we separate out using the Spring AOP, and we define like whenever this particular things are called or whatever the particular methods are invoked, we have to invoke these particular methods or we have to do this particular operations that we will define or that we can define in the Spring AOP. So that's the Spring AOP part that Spring provides us. The other thing that it provides us the ability to create the web application. So there is a Spring project called Spring MVC that allows us to create the web applications. The other thing is, if you want to work with a database, right? So ideally, if you are directly working with Java, you would be working with a JDBC, and we know that working with JDBC is a really tough thing, right? So Spring provides us the Spring data libraries so that we can connect to the database. So for all the different database that you want to use, for all those things, there are Spring Data projects available. Either you want to use with the MySQL, either you want to use with the Oracle or NoSQL databases, anything. For all those things, there is a project from the Spring framework that you can use to connect to your database, and it would be very easy for you to implement those things. And it also allows us to implement other libraries and other frameworks very easily. Suppose if you want to work with the Hibernate for your database connection or for your ORM, then it allows us very easily to implement Hibernate within the Spring framework. So that's why, because of the ease of implementing other libraries and other frameworks in this Spring framework, it is also known as the frameworks of framework. So by all these particular features, we can understand that Spring Boot is a layer on top of the Java to build our applications. Now, as Spring Boot adds a layer on Java for the developers to make the application very fast, reliably, and with a peace of mind, do the same thing with your identity on internet using VPN. With more than 5,200 servers, amazing speed and one-click connect, NordVPN gives us a lot of features and security. As a techie, we know that how much important it is to secure our data and identity. With NordVPN's diskless servers and end-to-end encryption, everything is secure, which routes through the NordVPN servers, so no one will know your IP address. And if you want, you can route through 2 VPN servers to double down on your security and protection. And it also enables all the content on Netflix and Amazon Prime. You just change the server to that particular location and all the contents and your favorite shows will be available to whichever server you have connected to. So I use NordVPN on all my devices. So if you are interested, go to this link or use coupon code DCB to get a 2-year plan plus a huge bonus gift. Check the first link in the description below. Now, to understand more on the dependency injection, let's go to the computer, open IntelliJ IDEA, and I'll show you some code so we can understand more on the dependency injection. So let me just open IntelliJ IDEA. So I'll just create a new project over here and we will use the Spring Framework dependency in it. So let me just create the new project, and you can create Spring project either using Maven or using Gradle. Both are the excellent build tools. So either one, whichever you are comfortable, you can use. I'm more comfortable with the Maven, so I'll go ahead with the Maven. So here you can just select the Maven project that you want to create, because we are not creating Spring Boot project. We are just focusing on the core Spring framework. So from here, select the SDK. I'm using Java 11. So I'm just selecting the Java 11 over here. And there are a lot of archetypes available, Maven archetypes. So from that, you can directly create the base structure of the Maven project. But we are not going from this. We will be creating entire project from scratch. So click on next over here and give the name of the project. I'll just give Spring Framework demo, and in the artifact coordinates you have to give your details over here. Now your group ID is to identify or to get a unique group ID over here. Now we'll add the group ID over here. Generally we will be writing the domain name in the reverse order to make it unique. So I'll just write com.dailycodebuffer, and the artifact ID would be your name of the project. So with the combination of group ID and artifact ID, your artifact would be unique in the world. And then you can give the version as well. We'll go ahead with the 1.0-snapshot version and we'll click on finish. And here you can see that the project is created. So this is the pom.xml file of your Maven. This is very important for your project. So let me just close it for now. Let me go to the src folder, main Java, and let me create the package over here. Let me give demo and let me create the main class over here. Okay, and we'll have the main method as well. Now ideally when we are working with the Java application, what we do is we create a lot of classes, and whenever we want to use those classes, we create the reference of that particular class and we instantiate that class with the new keyword, right? So the object of that particular class is created and we can use that class. We can assign some variables or whatever we want to do, or we can call the methods available in that particular class. So that's how generally is been done in the Java application. So suppose for the example, let me just create one class over here. So what I'm doing is I'm creating a class which says doctor, and let me say public void assist. The doctor can assist the other doctors, and I'm just printing out doctor is assisting. So this is just a simple class that I've created, doctor, and there is one method that is assist, which is printing doctor is assisting. Now if I want to use this, what I'll do in the main class, I'll just create the reference doctor equals to, and then I'll instantiate this particular class with the new keyword, that is new doctor, right? And then I can say doctor dot assist. If I run this should run, right? Completely fine. Now what if I want to create a new doctor again, or what if there are new objects that are to be added to this particular class, right? Because currently if you see there is only one doctor. If you go to this particular doctor class, suppose there are different classes created and the objects of those particular classes are required over here, right? Suppose doctor have qualifications, right? So suppose if you're creating the class qualification and you want to use that particular qualification in this doctor class, what you will do, you will just create a qualification reference to it, and whenever you want to create the object for it, either in the getter setters or in the constructor, you will instantiate this particular object using the new keyword. So that thing is bound to this doctor class, right? Because whenever you want a doctor class, you have to have the qualification class. So you can see that those two class, doctor and qualifications, are tightly coupled, right? Because whenever you need a doctor, you need to have a qualification. Without that particular qualification, you cannot create the doctor, because you have directly instantiated the qualification class within the doctor constructor itself. So this is a particular concern that we have to solve, right? And Spring allows us to solve that particular concern. Now to solve this concern, what we have to do is we have to do the loose coupling. You might have heard this term, right? Tight coupling and loose coupling. So we have to create a loose coupling within the objects that we are creating. So that means if you want to work with directly qualification, you should be able to work. And if you want to directly work with a doctor, you can work. And if qualification is available, that's fine. We can use the qualification. If qualification is not available, we can still create the doctor, right? Ideally, it should not be, right? But here to understand, we can create the object. And the other thing why we have to do the loose coupling is for the unit testing. We will be creating a huge projects, and to test it everything every time is not possible. So what we do, we separate down, or we create a different components, small components, and we try to test those small components. We do the unit testing of those components and we try to build the application. So that means if we create a doctor class over here separately and we create the qualification class also separately, we should be able to test both of them separately, and we should be able to test both of them together also. So that type of thing should be possible, and that's the design principle that we should follow. So to achieve this, to do the loose coupling, dependency injections comes into picture from Spring. So what it allows us to do is we can create the different classes, and we just tell Spring like these are the classes I have. And what Spring will do is Spring will try to reference all the classes. So it will have the graph of reference, right? It will have like this particular object is connected to this particular class. This is a separate class. This is connected to this particular class. So this all reference graph it will have, Spring will have, and it will try to match everything. So you don't have to do anything. So you don't have to use a new keyword to create the objects or anything. We just have to annotate it, or we can do the XML configuration as well, that this particular class might need this or may need this particular object. So we'll just define everything like a blueprint. So we'll just create a blueprint like this is all I need, and Spring will take care of everything, like whenever the objects are there, to creating the objects and to inject all the objects whenever it is required. So everything Spring will take care of. So that is, we are giving the control to the Spring. So that is the inversion of control, and dependency injection is the process that we are doing. So let's understand how to do this dependency injection. There are different ways that we can do dependency injection: constructor based, setter based, and we can do via XML configuration as well, and then we can do via annotation based as well, and we can do via Java configuration as well. So we'll see how we can do via XML configuration, how we can do via annotation based configuration, and how we can do via Java configuration. So let's see how we can do this. So I'll just remove this for now because I don't need this, and let me go to the main class, and I don't need let it keep this way, right? So now to work with the Spring, we need to add the dependency. So to add the dependency, what we have to do is we have to go to the pom.xml file, and here we have to define the dependencies. What all the dependencies that we need, we can define here, and we can add the dependencies. So what I'll do, I will go here and I will add the dependencies. Okay, inside dependencies, I need to add the dependency. So I'll just add the dependency tag. Okay, in this particular dependency, you can see that you have to provide the artifact and the group ID. That too would be unique. So I just want Spring context dependency, and that is the from the group org.spring framework, and the version that I want to use is 5.3.14. Okay, currently Spring Framework 5 is the latest one, and within few months Spring Framework 6 also will get released, but the base will remain the same, right? This tutorial will be applicable at that particular time as well. And once you add this, you can just refresh the Maven dependencies, and Maven will try to get all the dependencies in your local repository. There will be a central repository as well for Maven, and it will try to fetch all the jar files whichever we have defined over here, and it will create the local repositories so it can give you the content from there directly. So this one dependency is created now. Now if I go to this particular main class, so now we need to understand, okay, Spring will create all these particular beans, right? But where? From where to get all these things, right? So what Spring does is, whenever you start the application, Spring will load all the beans and it will store all the beans in the container, right? So we can get all the beans from the container itself. So there are two interfaces available, that is bean factory and application context. From that we can try to get all the beans which are loaded, and we can use those particular beans. So we don't have to use the new keyword to get the object, and we can use that particular object. So let's try to understand that. Now what's the difference between bean factory and application context? Application context extends bean factory, so there are a lot more features within the application context. Now if you want to know the exact differences, you can go to the documentation and you can go through everything, but here we will be using the application context for now. For that I will link the article in the description below. So let me just create the object of application context, and here you can see that it is part of the org.springframework.context package. Okay, and I'll create the context object equals to new, and here you can see that there are a lot of different ways that we can get the Spring context, but here we have to go with the XML based configuration because we will try to use the XML based configuration. So here there is a class called class path XML application context, so we will be using this one, and as we are using class path XML application context, we need to create the XML configuration for it. So let's create the XML for it. So, and that particular XML has to be in the class path. So whatever it would be in the resources folder, it will be in the class path because everything is in the main, right? So let me just create the XML file, and I'll just say it's spring.xml. So we just define the XML version over here, and then we have to define the beans, because whatever the classes or whatever the objects that we'll be creating, all those will be called beans in the Spring. So all the objects are beans, and we can get those particular beans from the bean factory or the application context, wherever the container, whatever the container is holding those things. So we need to have beans, but it's XML, it doesn't have the XSD to understand it. So we need to provide the namespace and those particular information in the XML. So what I'll do, I'll just copy paste the details from the documentation, and this particular namespace and everything will depend on the Spring version that you are using. So currently I'm using 5.3.14. Hopefully that's the one, right? Yeah, so accordingly I'll add the beans tag over here. So don't worry, it's very easy to find. If you just Google it, Spring Bean XML, you will get it and you can directly use it. Okay, so this is what I have done. You need to create the beans tag, and within this beans tag we can create the beans. So whatever the classes that we are creating or we will be creating, we can define over here. And this particular context, this particular XML file, we need to provide to our class path. So what I'll do, I'll just provide, this is spring.xml. It's simple thing that we created the context from the spring.xml. So whatever the beans are defined over here, we can get those particular beans from the context. So how we can directly do context.getBeans method. Okay, so from here we can say, okay, I want a bean of type doctor. Simple thing, right? So in this particular factory, whatever the beans are there for the doctor class type, we will get that particular bean and we can use this particular bean. So if you run this, let's see what happens. And it should fail, obviously. You can see that no such bean definition exception, because Spring still doesn't know that I have to create this bean, because we just created the class over here, but we have to define that this class, whatever I've defined, that's a bean that you have to use. So that thing we have to define in the Spring XML itself. So what we will do is we'll create a bean tag, and in this particular bean tag we will say which class we want to use. We want to use demo.doctor. Okay, and for every bean that we define, we need to make it as unique. So we will define the ID. So I'll just define that ID is doctor. So we just define the bean. Now if we go and check, and if we run the application again, it should work, right? You can see we got the bean from the context itself and it is executing. Cool, right? Let's try to create one more object. So what I'll do, I'll just create one more class that says nurse. Okay, and this also has the same method. Let me just copy it from here, and I can say nurse is assisting. Okay, if I go to main over here and if I say I just need nurse over here, and this is also nurse. Okay, so instead of doctor, we'll get the object of nurse, and we got the error because we have not defined the bean. So let's go ahead and define the bean as well. So we'll go to the Spring XML over here, and let me just define one more bean. Bean class equals to demo.nurse, and I'll give the ID as well. ID equals to nurse. Okay, let me run this again, and you can see that it should work. Now if you see over here, we are defining the type over here, right? That I want the class of a type nurse, but instead of that, you can get the values from the ID also that you have provided. If I just say nurse, so here you can see that it will get the data as an object because it doesn't know the type yet. So we can do the casting. Okay, and if we do this way also, then we should also get the object. You can see that it is working completely fine. Now generally this is not the way that we create the applications, right? Because we'll be having the lot of complex structures, right? So let's make it something complex. Let's add the hierarchy. So this nurse and this doctor belongs to the staff of the hospital. So let me just create the staff interface over here. Staff is the interface, and this staff interface has method void assist. Okay, nurse and doctor both implements staff. I'll go to the doctor as well, and doctor also implements staff. Now doctor and nurse both are part of the staff and both have implemented this assist method. And now I have added both these beans also in the Spring context in the XML file. Now if I go to the main.java file, and instead of doctor, I just need the staff to assist. Okay, so what I'll do, I'll just say staff over here, and I want staff to assist. Now instead of this, what I want is I want the object of doctor for now. So I can say doctor.class. Now this doctor.class should be assigned to the staff, and we should be able to call the method. Pretty good, right? Now either from the doctor we can change to nurse as well, and we should be good here. Now you can see here, right? It's pretty simple. We just decouple the entire application. You can see we are not creating the objects. We are not injecting the objects. We are just getting everything from the container itself, Spring container itself. And we define what are the beans that I have in the XML file. Now, if you see, these are just a simple classes. What if we have some properties? So let me go to the doctor class and let's see if I add properties. Private string qualification. And for basic Java class, if there is any properties that we are defining, we'll be having the getters and setters. So let me create the getters and setters for this. Okay, these are the getters and setters created. Now what will happen over here is Spring will try to create the object that is doctor, right? So it will create the object, but it doesn't know that it has a property qualification, right? Or what value to add to the qualification, right? It will try to add the default value that is null. So if you want to do that, we can inject those particular values of the properties from the XML file itself. So if you go over here and if you see, if I want to add some of the properties, that's the setter injection that we are doing. And if I want to add the properties, I can add using the properties tag over here. And you can see that the property is qualification and the value that I want to give is suppose MBBS. Okay. So this is the value of the property that I have provided to the doctor class. So if we go to this particular class and if I let me just change to doctor for now. Okay. And I also need to change to doctor. And if I do s out staff.get qualification, I should get the qualification. You can see that I got the qualification that is MBBS. So the value MBBS was injected via setters from the XML itself. Now suppose what if you want to inject the entire object itself, right? So suppose just for simplicity I'm doing over here. Suppose if you want to add the object of nurse over here, okay? So private nurse. This should not happen, but just for simplicity to understand, I'm just showing you over here that suppose if you need the object of nurse or whatever over here, what you will do over here is you just define over here nurse, okay? And if you want to inject the value of nurse, so you will go to the spring.xml file. You have already defined the bean. You have to define the bean, right? Then only Spring will understand it. So the bean you have defined over here, and here if you are doing with a constructor argument, you can go ahead with the constructor args tag over here. But here we are just adding the properties. We can add properties and it doesn't have the value because we need to add the getter setters over here. So let me just add the getter setters. So now you can see we are getting the nurse over here. So now you can see that in the first one we added the static values because we had a value defined. So we just use the values attribute over here. Here we need to use the ref attribute. So we have to reference the nurse object that we have created over here. So the entire object from here will be injected to this particular doctor class over here, doctor object over here, right? So here you can see that we are just defining the definition like this is what I want. Spring will take care of everything. We are not using any instantiation anywhere like new keyword or whatever is available in the Java, right? Everything is done by Spring. So that's the beauty of Spring framework. So let me just remove it because I don't want it. I just added here to show you that we can use this way as well. Let me go to the doctor. Let me remove this property. If I go back to the Spring XML, if I remove this as well, and if I want to use the constructor based, then I can use using the constructor arguments. And I can give value equals to MBBS. So it will add to the first property. Okay, I need to remove this. Let me just remove this. Go to the main and run this again. We wanted the error and we got it because you can see Spring could not resolve the matching constructor. So yeah, you can see that we have defined like this particular bean of doctor will have a constructor that's have one argument, but we have not created the constructor. So we need to create a constructor. So if you go to the doctor and if we create the constructor, if I say constructor with qualification. This is the constructor created. Now if I go to the main, if I run this, you can see that I should get the value that is MBBS. So this was injected using the constructor injection. The earlier which we saw using the properties was the stator injection. This was using the constructor injection. So these are the two ways that we can use to inject the values to our beans. Now let's try to do with the annotation based configuration. This was the XML based configuration that we did. There is also another way that we can implement this using the annotations. Within the recent Spring frameworks, you will see everywhere that annotations would be used. Now to use the annotation based configuration, what I'll do, I will just comment this beans out because I'll add the annotations for it. And now after commenting, if I go to the main class, okay, I'm just using the doctor for now, and let me go to the doctor class over here, and let me just remove this everything. Okay, just let's try this simple thing first. It has the assist method, and from the main as well, I'll just remove this. Now to use the annotations, we have to mark this as a Spring component. Okay, that's it. So what we are telling Spring is that whatever the class that we have created is the component that you can use to create the beans out of it. That's it, right? If we try to run it again, let's see what happens. And it should fail actually. And here you can see that it failed over here because Spring doesn't know yet, like you just created the class, you defined like it's a component, but where I should search that, right? So we need to define that search here, you will get the components. So we will go to the spring.xml and we have to define that we need to search the base package. So here what I'll do, here I'll define context component scan over here. Okay, like in which base package I want to search. I'll just say that in the demo package every components are there, so search there, whatever the components that you are getting, try to load those components. So we just defined over here, and we have just removed every bean definitions and everything, and we just added the component over here. Now if I go to the main class and if I run this again, I should get the doctor object. You can see we got the doctor object. But if we try to get the nurse object, right, let me try to get the nurse, and this is stuff. And if I run this, you can see that we got the error because Spring doesn't know that nurse is a component yet. It only knows that doctor is a component. If I run this, doctor should come, right? Doctor is coming. So to make nurse also as a component, we can also annotate with @component. That's it. Simple, right? So this is the annotation based configuration. There are a lot of different annotations specific to the specific needs available. You can see it's a stereotype annotation. So there are a lot of different annotations available. So once you explore the different tools or projects in the Spring framework, then you will get to know more about the different annotations also. So you can understand that this is the way that Spring handles the annotation based configuration as well. The other thing is we can handle using the Java configuration as well. So let's try to create the Java configuration. So for Java configuration, we have to create a configuration class. So let me just create the Java class that says bean config. Okay. And this particular bean config, I need to annotate with @configuration. You can see that it's part of the context annotation, and it will try to say Spring that this is the configuration, that whatever the configuration has been defined, we need to act accordingly. Now what I will do, I will here also say the same thing that you say in the XML. So in the XML, whatever currently it is there, right? Currently you can see that we have defined only one thing. This is not the XML. This is the spring.xml, right? Currently we have defined only one thing, that is component scan, where we need to scan the components. The same thing we will define in our bean config. We are not going to define the other beans for now. I'll just say component scan over here, and where to scan. I'll just say base package equals to demo. That's it. Okay, this is a simple thing that we did over here. Now if you go to the main.java file, here instead of class path application context, we need to use this particular configuration that we are using. So let me just comment it out over here, and I'll use the different context. Okay, I'll say application context equals to new. I'll just say annotation config application context, and here I'll define bean config.class. This is the class that defines the configuration for my annotations. So it will refer to this particular bean config class, and it says, okay, this is a configuration class and we need to scan demo as the base package, and whatever the components are there, we need to load those components. That's it. We'll go to the main. We are not using the XML now. We are using the bean config. If you run this, it should work completely fine. And you can see that it's working fine. Now the other thing also that we saw in the XML is when we had not defined this component scan, we had defined the beans, right? So this also we can do using the configuration. So if we go to the bean config, and here for the same thing, what I'll do, I'll just remove this, okay, for now. That I don't want, okay, let it be. What I'll do, I'll just say public method which will return doctor. I'll say this is also doctor, and I'll say return new doctor. So here you can see that I just created the method over here, that is the public doctor, which is returning the new object of the doctor. And you can, and what I'll say, I'll just say this is the bean that you need to load. Okay, so whenever you're loading anything, this is the bean that you need to load. And to make this work, what I'll do, I will remove the component from here. This is not the component now. I'm defining bean myself in the configuration. This is the bean of type doctor that I need. Simple thing, right? And if I go to the main, this should work the same way, because whenever it will try to load the bean configuration, there is a method that has been defined as a bean. So this will be acted as a bean. The new doctor will be created with a default constructor, that whatever I'm defining over here, and it will be available in the container. Let me just run this. It should work. Cool, right? So this is the way that whatever we define in the XML, we can define here as well. The same thing, whatever you did in the XML configuration, like constructor injection, setter injection, everything is the same way. You have to define this way, either with the bean, or you can annotate with the component. Make it as a component and it will be available in the context. Now let's understand about the different scopes available in the Spring Bean. So whenever the Spring is creating the beans, we need to define how those particular beans we want, right? There are 5 different types of scopes available in Spring Bean. By default, all the beans will be created using the singleton scope. So for each and every class, there will be only one single object available in the entire application. So by default, that's the thing that Spring is going to do. But if you want, we can ask for the different types of scope as well. So there are 5 scopes available, that is singleton, prototype, request, session, and global session. The other 3, that is request, session, and global session, are used mainly when there is a web aware context available. So that is when we are implementing the Spring MVC. But we can still go ahead and see the singleton and prototype design patterns and how to define the different scopes of bean in the Spring application. So default is singleton, which will always result into one particular object in the entire application, and prototype is you will get a different object every time when you request the object from the container. Request is used when you need one object or you need a different object for each and every request that you receive in the application. So currently, let's try to see the current scope, that is the singleton scope by default available, and see what it happens. So whenever we do any changes, that changes should reflect to all the particular objects that we get. So here what I'll try to do is I'll go to the doctor class and I'll add the qualification again. And I'll add the get status for it. Okay, and I'll also generate the toString method. Okay, this is the 2 things that I have done over here, that I have added the qualification property, added the get status for it, and I have overridden the toString method over here. And if I go to the main class over here, and let me just say I need a doctor. Okay, let me convert this to doctor and doctor.assist. Okay, that's fine. Now what I'll do, I'll just try to do sout doctor. Okay, and let me run the application. Currently you can see that I'm getting doctor is assisting and I'm getting doctor qualification is null. But before that, let me just set the doctor.set qualification to MBBS. So I just set the MBBS as a qualification and I'm getting the qualification as well. Now after this, let me try to get the object again. So I'll just say doctor1 equals to context dot get bean. I need doctor.class, and I'll do system.out.println doctor1. Simple thing, right? I just took the object doctor over here and then I added the qualification, and after that I'm getting the doctor again from the container. And if I run this again, you should see that I'm getting the same object back, right? I have set the value over here and I'm getting the object back again, because by default is the singleton design pattern implemented for all the beans, scope of the beans. So Spring is creating only one object for the entire application and I'm getting the same object. And if you want to change it, right, so you can go ahead to the doctor class over here and you can write with @scope. Okay, you can define the scope over here and you can see that there is a scope name available, and if you define singleton, then this will be your default scope, that will be singleton. And if you want to change the scope, suppose I want to change the scope of this particular bean to prototype, then I can go ahead and change to prototype. When I change this to prototype, for every time when I try to get the object from the container, I'll get a new object. So if I go to the main again, if I run this for my second object, I should not get the MBBS, because that should be the new object where MBBS is not set, because in only first object I have set the values. So if I run this, so you can see that we got the MBBS in both the objects because we have not added the component over here. We have to make this as a component. So once I make this as a component, and if I go to the bean config, let me just remove this bean for now. Now everything is coming from the component of a doctor that sets the scope as a prototype. And if I run this again, let me go to the main.java, and then if I run this, I should get MBBS for the first and null for the second. So that means based on the scope that we defined, Spring will create the objects and it will return the objects accordingly from the container. So now we understood how to create the beans, how to define the different scopes. We need to understand the life cycle of a bean as well, and what are the ways that Spring gives us to do any modification in that particular life cycle. So in the Spring life cycle, there are 7 different steps. The first thing is the definition of a bean, that you will define that these are the beans that we need to create, and after that Spring will try to instantiate those beans. So that's the bean creation or the instantiation process, that particular step in the life cycle. After that, it will try to populate the properties. So whatever the ID that you have provided, what are the different scopes that you have provided, or the default values or whatever that you have provided for that particular bean, Spring will try to add those particular or set those particular values. So the next step is the post initialization step. In this step, whatever the aware interfaces that you have implemented, those particular interfaces will be executed, like whatever the custom execution that you want to do in the bean lifecycle, that particular will be executed. So after that, bean would be ready to serve. All the dependencies and everything would be injected and the bean would be ready and would be available in the container. And the next 2 steps are the destruction of the beans. The 6th step is to pre-destroy. So whenever a particular bean is trying to get destroyed, right? So whenever any cleanup is happening, at that time, if you want to execute in custom logic, like to delete some data or to release the connection or or to close the file or anything, at that particular time, you will define your custom implementation in the pre-destroy phase. And then the last step would be bean destroyed. At this particular time, bean will be destroyed from the JVM itself. So this is the Spring Bean lifecycle where all these particular steps have been mentioned and what happens at what particular step. So if you want to do any modification, then how we can do the modification, that we need to understand. So from this diagram, you can see that once the bean definition is been passed, that particular bean will be instantiated, and then after that, it will populate all the properties, and after that, all the aware interfaces which are there, those will be executed. There are different aware interfaces. So the bean name aware would be executed first, then it would be bean factory aware, then application context aware, then pre-initialization bean post processor process will happen, and then initializing beans after property set will be executed. And after that, if there is any custom methods, then those particular custom methods will be executed. And after that, post initialization process will happen, and at that particular time, bean will be ready to use. And when the container shuts down, disposable beans destroy method will be executed, and then any custom method is there and custom destroy method that will be executed, and then the bean will be cleared from the JVM. Now why we need to implement custom methods in the bean lifecycle? Suppose assigning a default values, right? So whenever you want to create any bean, if you want to give some default values like file path or anything, at that time we can use this particular custom methods to inject those values. If you want to open or close the files, or if you want to open a DB connection and close the DB connection when the object is created and destroyed, so at that particular lifecycle points we can create the custom methods and we can create the connection and we can destroy the connection. And if you want to start the threads or destroy the threads at the time of construction and destruction of the beans, for those purpose also we can use this particular custom methods in the bean lifecycle. So these are just the different examples that I have given you. At this particular places, this bean lifecycle can be very handy. So let's see in the code how we can do this. So the first thing we'll do is we will implement one aware interface. Okay. So in the doctor class, what I'll do, I will try to let me use bean name aware. Okay. And for this, I need to implement the method. So let's go ahead and implement the set bean name method. And this is the method. Okay. So what I'll do, I'll just do a out over here. And I'll just say set bean name method is called. Okay, simple thing. Let's go ahead and run this. Let's just comment this out. And you can see that before creating the object, set bean name method was called, and after that doctor is assisting, this particular method was called. Okay, so this way we can implement all the different aware interfaces which are available to modify the behavior of the lifecycle. The other thing also we can do is to use the annotations. So suppose once the object is created, right, at that particular time, if you want to call anything, what we will do, we will create one method public void, and we'll say post construct, and I will say out post construct method is called. Okay, and I need to annotate with @post construct, but that particular annotation is available in the JavaX annotation API, so we need to add the dependency for that. So let me just go ahead and add the dependency. Let's say javax dot annotation API, which is part of javax dot annotation, and the version is 1.3.2. Let me just refresh the maven, and if I go to the doctor again, if I do post construct, now that it is available. If I go to the main, if I run this, I should get it. You can see that the name was called first, and then after that post construct method was called, and after that object was created, and I was able to execute this object. The same way you can go ahead and implement the pre-destroy method as well. So this way you can add the custom method implementation for your bean lifecycle. So this was all about the Spring framework and the dependency injection, what are the different features available, and how we can use Spring framework for our advantages. If you know these basics and if you know these concepts very well, then you will be able to understand any of the libraries available within the Spring ecosystem, because for everything this is the base. So we already learned about the Spring framework, and in this video we are going to learn about the AOP with Spring framework. So first of all, let's understand what is AOP. AOP stands for aspect oriented programming. Now okay, that's the definition, but what exactly it is, right? Aspect oriented programming is just a methodology with which we will create the applications, just like OOP, right? Object oriented programming, we create the application. Similar to that, there is an aspect oriented programming with which we will create our application. Why AOP and what are the benefits? Let's first understand that. So AOP gives us the flexibility to remove the cross-cutting concerns from our application and to separate it out from the main business logic. That's a lot of jargons, right? So let's understand what are cross-cutting concerns and why we need to separate it out. So when we are creating the application, we tend to do a lot of things, right? So suppose let's take the example of a shopping cart, right? So in the shopping cart, what we do is we add the items to the shopping cart which we want to buy, and from that shopping cart, if we want to remove the items, we can remove the items, and after that, that particular shopping cart, we will check out that shopping cart and we will try to order those items which are there in the shopping cart. We will do the payment for that, and we will add the shipping address and payment details and everything. So all these things will happen, and to do all these things, what we generally do is we try to add a lot of different logics to it, right? There will be a lot of business logics also. and there will be a lot of different extra things that we are going to do. Suppose we are going to do the logging for each and every request that is going for the shopping cart. Whatever the actions are performed by the user for that particular request, we are going to log all those data in the loggers so that we can understand when there is an issue what happened to that particular request. So that thing we will do, try to add the loggers. The other thing we will be possibly doing is to handle the authentication and authorization. We will try to see that particular request is authorized and authenticated properly. Whatever the features the user is trying to use, that particular user has all those rights to use that feature or not. So this type of logic also will be going to implement. Then there might be logics to convert the input data, whatever we are getting input data, to sanitize those data, right? So whatever the JSON format or whatever the JSON input that we would be getting it from the request, we would sanitize those data. So these are all the things that we would do every time when we get a request. Either it would be in the payment page, either it would be in the shopping cart, either when adding the data to the shopping cart, while going to the home page, anywhere. This type of things that generally we do. And this is completely different from the business logic that we have, because for each and every operation that we do, business logic will be different. But these are the things that we would generally do. So these are known as cross-cutting concerns. So what aspect-oriented programming tells us that just try to remove those cross-cutting concerns from the main business logic and keep those things as a different place and run it separately. So that means your business logic is completely different and your cross-cutting concerns like logging, authenticating, authorization, you're sanitizing the data and everything are at the different places. So that's what we are going to do, right? To separate out the cross-cutting concerns in this video. So we will be taking one example where we will see what are the different ways that we can do, what are the different methods available, what are the different ways that we can implement it. We would be using the AspectJ library to implement this AOP with Spring Framework. So let's open IntelliJ IDEA and let's see the demo for it. And before that, if you're enjoying this video, then give us a like on this video and subscribe to this channel for awesome new videos. If you want, you can also join this channel by clicking on the join button below and support me. Now let's go to the IntelliJ IDEA. So let me just open the IntelliJ IDEA. And here I'll create the sample Maven project. So let me just create a new project over here. And here I'll just select the Maven. Project SDK is Java 11. I'll click on next. And the name of the project I'll give as, let me just give Spring AOP demo. And in the artifact, let me give com.dailycodebuffer. So this is what you give to make your group ID as unique. And the artifact ID I'll give as the Spring AOP demo. And the version I'll just keep it the same, 1.0-snapshot. And let's just click on finish to generate the project. So here in this pom.xml file, we have to add the dependencies for the AspectJ and the dependencies for the Spring context, because we will be using the AspectJ library and the Spring framework to implement this demo. So let's do that. What we have to do, we just need to add the dependencies tag. Inside dependency, we need to add the dependency. So we will add the dependency. Here I need to add the Spring context from the org.spring framework, and the version I'll add as 5.3.14. So this is the one dependency that I've added. Let's add the other. And if you don't know how to add this particular dependencies tag, don't worry, I'll show you one way as well. You can directly go to the Maven repository and you can search from there and you can add. Okay, so just go to the browser. Okay, and here search for Maven repository. And here you can search everything. Suppose Spring context. So here you will get that this is a Spring context, and you can go here, you can go to the version and you can just copy this details and you can paste in the pom.xml file. Similarly, I just need the AspectJ as well. Okay, AspectJ runtime. So I'll just go here and I'll just take the stable version. Okay, so this is the stable version and I'll just copy this and I'll add in the dependency. Okay, and let me go back and I just need the AspectJ viewer as well. So let me go here, go to the 1.9.7, the same version, copy it and add. Okay, just save it and refresh your Maven project, and all these dependencies will be added in your project. So the process is completed now. Now let's go to the src folder, main java, and here we can create the package. So let me just create a package that says demo. Okay, so let me create the main class over here. I'll just create the java class and says main, and inside this I'll just create the main method. This is simple thing. Okay, now what I'm going to do is I'm going to create one shopping cart class. So let me just create a shopping cart class. And this has a method public void checkout, and I'm just printing out one thing. Okay, checkout method from shopping cart called. I know spellings are wrong, let me just correct it. Okay, so consider that this is a checkout method and it's doing the checkout for your items in the cart. But for simplicity, I have just written one print statement over here which is printing that checkout method for shopping cart is called, considering this is a logic. Okay, now in the Spring we need to create the bean for this shopping cart, so we need to make this as a component, right? And to get this all the components, either we can go with the XML based configuration or we can go with the annotation based configuration. So what we'll do, we'll go with the annotation based configuration with the bean config file. So let me just create a configuration file. I'll create Java class and say bean config, and this bean config, I'll say this is a configuration. Okay, with the configuration annotation. And what I'll do, I'll just enable the component scan, and I'll say base package is equals to demo. So this is my demo as a base package. So whatever the components that I'm going to create, it will scan all those components. It will scan all the components in this base package available. Okay, now if I go to the main, and I can get that from the application context. So I can say application context equals to new annotation config application context. Here I can give bean config dot class. Simple, right? This is the same thing that we did in the Spring framework video. We got the context, and from this particular context we can get the beans. So suppose I want the shopping cart bean, right? So I'll just say shopping cart equals to context dot get bean. Here I'll say I need the bean of type shopping cart dot class, and I can say cart dot checkout. Simple stuff. Let's run this, and it's working fine, right? Checkout method for shopping cart is called. Now if you go here in the shopping cart, generally what you do when you have a lot of logics available, right? You can do logging, right? You will do logging like you have entered into this particular method and you have exited this method. You will do authentication and authorization. You can do sanitization, sanitize the data, right? So these are the general stuffs that we will be doing every time, right? But this is your business logic. So what AOP, as we defined in the earlier, right, is to separate out the cross-cutting concerns. So these are the cross-cutting concerns that we need to separate it out. Now all the cross-cutting concerns that we want to separate it out, that's called an aspect. So this is the aspect, this is the aspect, this is the aspect logging. Okay, so for all these different cross-cutting concerns we can create the different aspects. So let's take an example for logging. Let's create the aspect. So in the demo, let me create a class that says logging aspect. Okay, and whatever the aspect that you have created, that you need to annotate with aspect. Okay, so we annotated with this particular aspect. Now here you can create the different methods that can be executed. Now if you create a method, right, suppose public void logger, suppose you want to add the loggers, and you just added loggers here, right? whatever. Now how the system will get to know, okay, this is the logging aspect and this is something that we have to learn, and from where we have to learn. So this is something that we have to add. So we need to define the point cuts. So this is a point cut, if we can say, okay, like what we have to run, like this is something that we have to run, but we have to define where we have to run. So for that we will be creating the point cuts and at what location we have to run. So wherever the point cuts you're calling, right? Like suppose if you go to the shopping cart and at this point you want to call that particular point cut, that particular method, so this is known as a join point. So it's simple to understand, okay? Just don't get confused with the lot of different jargons like what is point cut, join point, aspect and everything. Simple thing we need to understand is what is something that we want to call and where we want to call. That's it. We just need to define these two things, and that's what we are going to learn in a simple way. So suppose consider this is a method that we have to call at every method before the execution starts. Simple thing, right? So whenever there is any method available, right? Suppose let's consider a simple thing. For this particular checkout method, whenever this checkout method is getting executed, I want to call this logger. Simple, right? So what I can do is I can define the annotation, that is the before annotation. Okay, and in this particular before annotation I can define, before calling this method I want to call this method. Simple. So what you're doing is you are just removing whatever code that you might have written from the log for the logging from here to a different altogether aspect. So here I can define the execution. Okay, so in this execution you can define which particular methods that you want to invoke. Okay, so I can say I just want to invoke the method from demo package dot shopping cart dot checkout method, whatever the return type may be. Simple thing. I've just defined like for any return type, whatever the return type, currently it is void, so that's fine. So that's why I have written mention star, and in the demo package shopping cart type, that is the class, in that there is a checkout method. For this particular checkout method I want to call this logger, where before calling this method. Okay, now if you could try to run this, still it won't work, because if we can check, it won't work, right? You can see that it didn't work because we need to enable it. So if you go to the configuration bin config, and here we need to enable aspect j auto proxy. So once we define this, and if you go back and run this again, still it didn't work. Because how Spring will know that there is something called aspect? Because Spring just understands what components, right? So let me go to the logging aspect, make sure that this is a component, so it's in the Spring's radar. Okay, because we have defined that whatever is inside the demo package we need it, right? So let's go back to the main class and let's run this again. And now we should get it. You can see that the loggers was called first and then the actual method was called. Okay, so that means you just removed the loggers from the main method, only kept the business logic, and you just removed the loggers to the new aspect that you created, that is the logger aspect. Now there are different point cuts that we can call, right? Suppose currently we called for before, we can call for after, we can call after returning a value, we can call after throwing a value. Okay, and we can also call around the method. So these are the 5 things that you can call a method for. So let me go to the logging aspect again, and let's create for after as well. Okay, I'll just tell this as a before logger, and let's create one more public void after logger, and I'll just say s out after logger, and I'll just say before logger, just to separate it out. And I'll annotate this with after, okay, because I want to call it after, and I want to call around the method. So I'll just define in the execution, and here I'll just define that star for any return type, star for any package, dot star for any class, dot checkout method. Let's run this. Let's go to the main and let's run this. And you can see that it worked because we have defined the logging aspect this way that for any return type, for any package, for any class, if there is a checkout method, then we need to run this particular method. Okay. Now what if I just add any of the input parameters? Suppose I'll just add the input parameter string status. Okay. And now if we try to run this, okay, there is an error. So we need to go to the main class and here I can say status is cancelled, suppose. Okay. And if I run this again, and here you can see that only checkout method for shopping cart was called. So the aspect was not called. So to make sure that the aspect matches the input parameter as well, we need to go to the logging aspect, and here in this particular parenthesis we just need to define 2 dots. So it will just make sure that whatever the number of parameters are there, it will match. Okay. And if I go ahead and run this again, it should work. You can see that it is working completely fine. So we just saw that how to define a particular point cut over here and what are the patterns that we can give for the point cut to match the join point. Now let's define one more aspect because we need to separate out the authentication and authorization as well, right? So let me just create one more Java class that says authentication aspect. Okay. And as we did in the logging aspect, we need to annotate with aspect and we need to annotate with component as well. Now here what we can do is we can create a point cuts, and that point cuts also we can define in the methods to be called. So suppose if you have multiple point cuts, right? So suppose we have multiple different packages available, and for all the different packages we want to do the authentication and authorization. So we can define the different types of point cuts. Like this is the point cut for this particular package, this point cut for this particular package for different packages, and you can call the aspect for all the different types of point cuts. So let's try to do that. I'll create one more method, public void. I'll just say authenticating point cut. Okay, and I'll just say public void authorization point cut. Okay, you can see that I just created 2 point cuts. So rather than directly defining where to call, let me just mark this as a point cut. So I can mark with @point cut annotation. Now here if you see the logging aspect, you can see we use the execution over here. So this execution defines for which particular method that you want to execute. And here in the authenticating aspect, we will define with within. So this will define for which particular type of class that we want to execute for all the methods available. So I just want like whatever the methods available for the shopping cart, I want to execute the authentication. So I can just define for all the demo dot star, simple thing. And for all the types within this particular demo package, I want to execute this authentication point cut. And similarly, this also I want to define within means for your class, your type. Okay. And within the demo package, if you want, you can select the shopping cart. Okay. Dot star for any methods. This way also we can do, and we can give directly dot to make sure that for any of the class. Okay. Let's keep it this way also. So we have one more example for this as well. Now these are the 2 point cuts that we created. Now we need to call these point cuts as well. So what I'll do, I'll just say public void authenticate, and I'll just say SOP sout authenticating the request. Spelling is wrong. Let me just correct it. Okay. So I'm just trying to authenticate the request. Now I need to check where. So I just want to do before. Okay, I want to do before a method is called. When, so here I just want to define like when I want to do the authentication. I want to do authentication before the point cuts that I have mentioned, because first thing I want to do when any request comes is to authenticate that request. So here I'll define that I just need to do authenticate. So whatever the point cut I have defined, right, it will come here at the authentication point cut, authenticating point cut. But I also want at the time of authorizing point cut. So I can define with end operator and authorization point cut. Okay, so I'm just telling for these two, authenticating point cut and authorizing point cut, I want to call this method. If you want, you can also go ahead with or as well. Okay, and you can go with and as well. So either of the whatever the requirements, we can call these particular point cuts this way as well. So let's go ahead and run this. If you go to the main, if you run the method again, and it didn't work. So let me just change to all the type over here and let's run this again. It should work now. And here you can see that it is working, authenticating the request. Okay, so this way we can define for the type as well. And if we have this available in the different packages also, then we can go ahead and add the different packages and we can mix and match the packages with AND condition or conditions. Now these are just the simple things that we did, like how to call the aspects. Now there will be scenarios where we need to get the data as well. So whatever is happening within the shopping method, we might need those details as well. Suppose we need to have the input arguments, we need to have the return variables and everything. So let's try to understand that as well. Suppose for this particular logging aspect, if we can see for the checkout method, we have defined that we might also get the input variable or we might not get as well. And here we have defined that there is an input variable. Now let's see what are the different ways that we can get. And if you want anything to access within this, then we can define the join point over here, join point object. Okay, and from this join point object, you can see we can get many things. What is the kind, what is the signature, source location, static part, what are the two long strings, short strings, arguments, target, this lot of things that we can get for the point cut, whatever we have defined. So let's try to get the signature. Okay, and let me just add this in the sysout. What is the signature of the method that has been called? And if you go ahead and run this, and you can see that the signature is void demo shopping cart dot checkout and the input parameter is string. Okay, so you can see this way we can get the details. Now let's try to get the details of the arguments. So the argument we have passed is type string, and let's try to check what is the value. Suppose if we want the value, right, to log anything, so we can do that way. So in the logging here, what I'll do, let me just comment this out and I can take gp dot get arguments. Okay, so it will return the array of arguments. So we might have multiple arguments, right? So it will return the array, and from that array I just need the first argument because I have only passed one argument, and that argument is type string. So I just want to convert it to toString. So this is my argument that I'm getting, and if I get in this string argument over here before loggers with argument, okay, I'm just printing that argument. So let's run this. So we should get that argument as well. And you can see that the argument that we had passed was cancelled, and we are getting the cancelled here, that before logger with argument cancelled. So this way you can see that we just define that whatever the input parameters are there, we can access those input parameters at the join points and we can do any operation. So we just logged it, like whatever we had to do to log. Now we can also access the return type as well. What is the return type? So let me change a method. Let me add a method. Okay, public int quantity, simple quantity. I've just created a simple method which defines the quantity and it's returning value 2. So whatever has been written over here, if we want to access that, we can access using the after returning annotation. So let's go to the logging aspect. Let's create one more method, public void after returning and I can just sys out after returning. Okay, now for this we need to define a point cut, right? So what I'll do, I'll just define public void after returning, hope the spelling is correct, after returning point cut, and I'll just mention this is a point cut, and point cut is execution, and execution is for any return type from demo dot shopping cart dot quantity method, and I'll just keep double dot. So if we change the input variables also in the future, this will work. So this is a point cut where we have to execute, and we want to get the input variable as well. So the input variable, suppose I can say it's a type of string, right? And I can say it's a return value. Now how I will get the values over here? So here I need to define after returning, and here at which point cut I need to call this. So I can define point cut equals to, the point cut name is after returning point cut. This is what we created, right? So I'll just mention this over here, after returning point cut. This place I want to call this. Now I need to define the return value as well. So what is the return value? Returning. And what it is returning to? It is returning to the input variable that I have defined over here. So it will return the value to this variable, and we can access that variable over here. Hope this is clear. We just created the point cut over here. That point cut defines that this point cut has to be executed where? At the quantity method of the shopping cart, and this is the execution that I want for that. So I just define that after returning whatever has been returned from here, after returning 2, this has to be called. So I just define this after returning point cut, this will be called. And what will be the return value? That returning value should be coming to this retval variable that is been passed into the input variable. And here if I say after returning plus return value, so I should get to over here. Simple, right? So similarly we can also define for the after throwing as well, where if there is any exception we can get the exception and we can work for that particular exception in this aspect. So this was just a quick intro about the aspect J and how we can use it with the Spring framework. And there are a lot of different things that we can do, like for all the different types of packages and for all the different types of methods that we can define, and how those will be executed we can define using the point cuts. So this is all the basics and foundation of the aspect J. If you want to learn more, I will just link the documentation for it. In one page everything is defined there, and it's very easy to understand. After this video you will be able to understand that very easily. Start with the basics of a theory first, and then we'll move ahead with the application itself. So we will learn what is Spring and what is Spring Boot framework, and why we need a Spring Boot at the first place. After that we will see how to create a REST APIs using the Spring Boot framework. We will take one of the example, and with that example we will try to create all the REST API endpoints like get data, delete data, update data, save data, get a particular data. So all those endpoints we'll try to create. After that we will try to add the logging in Spring Boot. After that we will try to add the particular configurations in the configuration files. After that we will try to add the exception handling in the Spring Boot. We'll see how we can do the exception handling and all those stuffs. After that we will implement the unit testing for all the layers. So whatever layers we create, like controller layer, service layer, database layer, for all those layers we will implement the unit testing using the JUnit and Mockito. We will do all this using the in-memory H2 database. And after that, once you are comfortable with any of the database, then we will convert that in-memory H2 database to actual SQL database. So we'll be using MySQL database. So we will save all the data in our database. After that we will see how to get a particular values from the configuration files, whatever data or whatever configurations you can add in the properties file, how to fetch all those data. So we will also see how to implement metrics for your Spring Boot application, how you can monitor your application and how you can deploy your application to production. We will also see what are the different ways we can deploy Spring Boot application in our servers. So this is going to be a pretty advanced and long tutorial, so stick around till the end to learn everything in detail. I suggest you to practice alongside what I teach you for each and every topics, so you will get more hands-on experience for all the topics that we cover in this tutorial. So this is all about the different concepts and topics that we are going to cover in this particular tutorial. This is going to be very fun and very interactive video, so watch till the end and learn Spring Boot framework. Now firstly, let's see what is Spring and Spring Boot. So Spring is a Java framework built to create an enterprise ready application. So when you create a Java application, there are a lot more things that you have to do, a lot of configurations, a lot of property additions and lot of technologies, or a lot of packages and a lot of modules and jar files that you need to add to create your applications. Now Spring is a framework that allows us as a Java developer to do a lot of things. There are a lot of modules available for different kind of stuff that we can use as a part of Spring framework. There is Spring Core, Spring MVC, Spring Web, Spring Batch, Spring Data, Spring Data JPA. There are a lot of stuffs available in the Spring framework. We can use all those stuffs for our different activities. So we can only concentrate about the actual coding that we have to do. But when you're creating a Spring application, there is a lot of configuration that you have to do, right? If you're working with Spring framework and you want to include Hibernate, then you have to do the configurations for that. If you want to include any caching mechanism, then you have to do configurations for that. If you want to use any messaging queue, you have to do the configurations for that as well. So as a Java developer, as a Spring user, you have to do a lot of configurations to get ready with your application. After that, once you create your application, you have to deploy your application to any of the application server or web server. So there are a lot of moving parts when you are working with the Java applications. So Spring framework makes it easy for us to create all the application, but there is a lot of configuration that we have to do. So with this in mind, Spring developers thought of, okay, let's create something easier so all the developers can really concentrate on their actual work, only concentrate on the convention, not the configuration part. So for that, they created the Spring Boot. Now what is Spring Boot? Spring Boot is just the extension of a Spring framework. It's not a different framework. Spring Boot itself uses the Spring framework internally. It's just the extension layer for our Spring framework. Now Spring Boot provides key benefits for use for a Java developer. Firstly, the main thing is rapid application development. Spring Boot provides us to do the rapid application development. So whatever application that we want to create, we can create using Spring Boot very easily. The other thing is managing the dependencies. When you're working with the Spring framework also, at that time also, you have to add a lot of dependencies that you are using for your application. Spring Boot provides a way to group all those dependencies into a different starter templates. So Spring Boot provides different starter templates that includes all the dependencies that are required to do that particular task. So suppose if you want to work with the JDBC, then there is a Spring Boot starter JDBC template available that will include all the dependencies required to do that particular thing. If you want to work with the JPA, there is a Spring Boot starter JPA template available that will include all the dependencies required to do that particular task. There is a Spring Boot starter test available to do all our Spring Boot unit testing using the JUnit and Mockito. So there are a lot of different templates available that we can directly use as a starter template and we can directly work with it. The other thing Spring Boot provide is the auto configuration. So whenever we implement any of the things, we have to do the configuration for all those stuffs. Suppose if we implement Hibernate, we have to do the Hibernate configuration. Suppose we implement any messaging queue, we have to do the configuration for that messaging queue. If we implement any of the other libraries, there might be one or the other configurations that we have to do to work with the Spring framework. What Spring Boot does is the auto configuration for all those dependencies, all those libraries that we can use. So if you want to implement Hibernate, just add the Hibernate dependencies using the Spring Boot starter. All those configurations will be added automatically using the Spring Boot auto configure template over here. So that's a really good benefit for all the developers here. The other benefit that I like is the embedded servers. So if you see the traditional way of deploying the Java application is like you create the application, you create the WAR files of your entire application, and you deploy that WAR file in any of the application server or the web server, either JBoss, Tomcat or WebSphere or anything. You will deploy your WAR file to that particular server. But with Spring Boot, that particular server will be embedded to that particular entire application. So we won't be creating the WAR file of our application, we will be creating the jar file and in that particular jar file our server will be embedded, so we can directly run that jar file in any of the environment, so it's always production ready. So there are a lot more benefits to work with the Spring Boot applications, and the main thing is market is moving towards the microservices architecture rather than creating the monolith. So to create all the microservices using Java, Spring Boot is the default option. So now with this, it is pretty much clear that Spring Boot is the way to go. Now, whenever we talk about the Spring framework or Spring Boot, dependency injection is the topic that everyone discuss, right? So let's understand why dependency injection is so hype over here. So if you take any of the programming languages or any of the frameworks for that particular programming languages, dependency injection pattern is a default way they will go for creating the different objects in the application. Now why that? Now if we take the traditional example, you create any of the class in your Java application, suppose student. Now to create the object of that student, what you will do? Student as equals to new student. So that means you yourself is creating the object of that particular class over here. And when there are a lot of hundreds and thousands of classes created and all those classes are interrelated to each other, then it's not a good idea to use that approach to create the class manually. So in this type of scenarios, inversion of controls comes into picture. What is inversion of control? Inversion of control is nothing but to give the control from yourself as a developer to the framework that you are using. So suppose if you are using Spring framework, that means we are giving the control to Spring to create the object for us. We will just tell the Spring, okay, you are the boss, you create the object for me, I'll just directly use it. So that's the inversion of control. We gave the control to Spring. Now to implement that thing, dependency injection is the pattern that we use. Dependency injection means, suppose you have created one of the class that is student, and in that particular class there is another class that is subject available. So you don't have to create that particular object for that. Dependency injection pattern will create that particular object for you whenever you want. So what will happen is when the Spring Boot application start, it have the factory that will create all the objects or all the beans of your application. So suppose if you have hundreds and thousands of classes in your application, all those particular classes object will be created when that particular Spring Boot context is started, and all those particular beans will be stored in one of the Spring's container. And whenever you want that particular bean or particular object, you will tell, okay Spring, I want this particular class, and Spring will give you directly. You don't have to create the object. Spring already has all the objects, you can directly use it. So this is a very important part to understand. When we do the demo, we'll be using it everywhere. So at that time I will show you how to do this, but this is the theoretical part that you should understand what is IOC and what is dependency injection. So this is the concept in which everything will be working. So this is all about inversion of control and dependency injection in Spring framework. Now let's go ahead and start our applications. So Spring Boot provides us one tool to create the bare minimum or bare bone Spring Boot applications, and on that we can create our applications. So let's see what it is. It's called Spring Initializer. So let's go to that tool. If you go to start.spring.io over here, I'll link that into the description below so you can check this out. So with this particular tool, we can create the bare bone Spring Boot project. So here you can see that there are different things available over here. Here you can see that project information. You can create the Maven project or you can create the Gradle project. So these are the two project build tools available, Maven and Gradle. I'll be choosing the Maven over here, and you can see that you can choose any of the language over here. There is an option for Java, Kotlin and Groovy. We'll go ahead with the Java over here. And here you can see that you can choose the different Spring Boot versions available over here. Here you can see that different snapshot versions available, release candidate versions available. There will be different M1, M2, M3. That means a milestone versions available. I suggest you to always go ahead with the latest stable version available. Currently it's 2.4.5. Whenever you're watching this video, whatever the latest version available, you can select that particular version over here. So I'll be just selecting 2.4.5 over here. And if you go to the bottom over here, you can see the different packaging type is available. It's jar available and war file available. We'll always go ahead with the jar file. And at the below, you can select the Java version. Whichever Java version is available, you can select. I have Java 11 installed in my machine, so I'll go ahead with the Java 11 over here. You can see that you have to add the different project metadata over here. Here you can see that you have to add the group, artifact, a project name, project description, and your bees package over here. So let's go ahead and give this information. I'll just give com dot daily code buffer, com.daily code buffer over here, and artifact I'll give as Spring Boot tutorial. The name of the project is Spring Boot tutorial. Description is demo project for Spring Boot. That's fine. And here I will change the package name as Spring Boot.tutorial. So that's it. Now if you see over here, you can add the different dependencies over here. So as we will be creating the REST APIs in this particular application, Spring Web is the base dependencies that we need to add. So if you click on the add dependencies over here, you can see there are a lot of dependencies available. Yeah, you can search for it and you can add multiple over here. So we'll search for the web over here. Here you can see that Spring Web, build web, including RESTful application using Spring MVC, uses Apache Tomcat as the default embedded container. So when we add this Spring Web in our project, it will add all the default libraries that is needed to create our Spring Web application. So let's add this over here. We can add multiple over here as well. If you go ahead and click Ctrl B, you can see that there are shortcuts available. You can use all those things. Let me add over here. So currently we'll be using the H2 in-memory database over here. So if you don't have any database installed in your application, then also you can follow along the tutorial. So let's add that H2 in-memory database for now, and later when you are comfortable with the Spring Boot application, and then you can go ahead, install any of the database and you can connect that database. So currently let's add the H2 database. So you can see this is the H2 database, provides a fast in-memory database that supports JDBC API and R2DBC access with a small 2 MB footprint. Supports embedded and server modes as well as browser-based console application. So we'll be using this browser-based console application for this H2 database. So let's add this over here. Now you can see that we added all those particular informations. We added all the dependencies that we want to start our application. And if you click the explore button over here, you can see that this is your entire project. If you see this is the pom.xml file, as we have created the Maven project over here. And here you can see that this is the parent available. Okay, this is the Spring Boot startup parent and version information over here. And these are all the project metadata that you added over there, and these are the dependencies that you added Spring Web dependency, and we added H2 database dependency, and Spring Boot starter is the default dependency added for our unit testing. So this is the particular pom.xml file, and if you go to the src folder over here, this is the entire folder structure. If you see, src mean java com.daily code buffer.springboot.tutorial. This is our default package that we created, and this is the base file Spring Boot tutorial application.java that is created. This is the main application file. With this our application will start. And here you can see that we have resources folder where we have our application.properties. We have test folder for our unit testing. So this is the entire project structure that we will be getting it. Let's close this. We can generate the project from here, and if you want to share this project with anyone with all the dependencies and all this particular information added, then you can click on share, and with this particular link everything will be added with by default values, whatever you added over here. So if you want to share with anyone, this is the great tool to share those particular project details as well. So this is all about the Spring Initializer project. Let's generate the project and then we'll open in any of the IDs available. So let's generate it, and here you can see that the project is generated. So this is the project that we downloaded over here. Let me just extract it. Now we can open this particular project in any of the IDEs of your particular choice. You can use IntelliJ IDEA, you can use STS that is built on Eclipse, you can use Eclipse itself, you can use VS Code, you can use any of the editor as well. There are a lot of different plugins available for all the different editors. You can add those plugins and it will be very useful for the Java applications as well. Nowadays I really like to work with VS Code as well with the different plugins available for Spring Boot applications. But today we will be working with the IntelliJ IDEA. There is an IntelliJ IDEA community edition that is free of cost that you can download. I will add the link in the description below for you to check that out. I'll also add the link for the STS for you to download. So let's open the project in IntelliJ IDEA, and we'll also open the same project in STS and see how it works. So this is the project over here. Let me open the IntelliJ IDEA. And here, let me just open the project. I'll click on open. And here, my project is available. inside my G directory, Spring Boot tutorial. This is the project. Okay, so let me open this particular project. Plus the project. You can see that it is downloading all the Maven dependencies and indexing all the files. So once that is completed, you can see this is my project over here. This is my pom.xml file over here. And this is my source directory, main Java. This is my package and this is my main application file over here. And if you go to the resources folder, you can see static folder, templates folder, and this is my main application.properties file over here. Now let me show you how to open the same in STS also. Okay, let me just minimize it. Let me open the Spring Tool Suite. I'm creating the workspace over here. I'll launch it. Here we'll import the project, and our project is Maven. So I'll just go to Maven, existing Maven project. I'll browse the directory. It's over here, G directory, Spring Boot tutorial. Select folder, and here you can see that pom.xml file is been identified. So click on finish, and here you can see that this particular project is imported, and at the below you can see that all the Maven dependencies are getting downloaded over here. And here you can see that if you open, this is your main Spring Boot application.java file over here. You have all your property file as well. Now to run this particular application using STS, you can go to Spring Boot tutorial, right click on it and click on run as Spring Boot app over here. Okay, you can also do run as Java application to run from here. So this is how your application will run from Spring Tool Suite. If you go to IntelliJ IDEA, if you want to run the application, you can see that if you have opened Spring Boot tutorial application.java, which is the main file over here, you have the play button. You can directly click on it to run the application. Else you can go to the file over here, that is Spring Boot tutorial application, right click on it and click on run over here. After you start running, here you can see that the play button is over here. You can run from there as well. So this is how you can run your application using STS and IntelliJ IDEA. So we'll be using the IntelliJ IDEA only, but if you are using STS, you can open this way and you can run from here as well. There is another way to run from the command prompt as well. That also I'll show you in a bit. So let me just close this STS for now. Okay, but you should get an idea like how to work with it as well. So let me just close it, and here you can see that this is my application over here. So let's go through everything over here. So if you go to pom.xml file over here, so here in the Spring Initializer also we saw that we had different starters available. At the starting also we talked about different Spring Boot starters available that will have all the dependencies which are needed to run our application. So here you can see that this is our main parent for our Spring Boot, that says Spring Boot starter parent, and after that we have added couple of more starters. So we added Spring Web, that added this particular dependency, that is Spring Boot starter web and Spring Boot starter test dependencies, and we added the H2 database over here, and this is the Maven plugin over here. So let's go ahead and see what's available, which are the dependencies added to this particular Spring Boot starter web. So if you do control click over here, this particular pom.xml file will open over here, and here you can see that these are the different dependencies available. You can see that it has added Spring Boot starter, okay, Spring Boot starter JSON, Spring Boot starter Tomcat, Spring Web dependencies, Spring Web MVC dependencies. Okay, so these are all the dependencies available. If you open again Spring Boot starter Tomcat, and if you go down over here, you can see that for this Jakarta annotation API is available and Tomcat embedded core is available. Okay, so you can see that we don't have to add all these particular dependencies, all added with just one Spring MVC starter dependency. So this is the benefit of Spring Boot application. Now if you go to the Spring Boot starter test over here, so here you can see that it has added Spring Boot starter, Spring Boot test dependency, and you can see Spring Boot test auto configure dependency. So this particular Spring Boot test auto configure will allow Spring Boot application to auto configure all the particular configurations to run this particular test. So you can see that it also added JSON pass dependency, Jakarta, XML bind API, Aspect JCore, Hemcrest, JUnit Jupyter, Mockito, JSON Assert, Spring Core, Spring Test. So yeah, you can see that if we were not using Spring Boot, we have to add all these particular dependencies and we need to start our application. We need to configure everything. But here, everything is configured easily. So this was all about the Spring Boot starters, which are the different starters available. Now, if you come to this particular file, that is Spring Boot tutorial application, which has the main method, which is the starting point for our Spring Boot application. And here you can see that there is an annotation added, that is Spring Boot application. So this is a key annotation for our Spring Boot application. If you open this particular annotation, you can see that it has few of the main annotations. You can see that it's Spring Boot configuration, and you can see that enable auto configuration and component scan. So what all these particular annotations do? Here you can see that it has added Spring Boot configuration. So that means it tells the application that this is the main Spring Boot configuration file. So this particular Spring Boot application, this is the main Spring Boot configuration file, and it is also added enable auto configuration. So that means all the auto configurations for our application will be added to it. And suppose if we want some of the classes or some of the configurations to not add automatically, we can also exclude them. So suppose taking the example of an Hibernate, if you don't want to add the auto configuration for Hibernate, you can add the classes in this particular enable auto configuration annotation to exclude all those particular things. If you open this, you can see that in this enable auto configuration, there is an exclude class list. You can add all the different class that you want to exclude. And here you can see that there is a component scan available. So component scan, if you are already aware about this Spring application, component scan will scan all the components available in your Spring Boot application, and all those particular components will be added to the Spring container when the application is started. So by default, whatever the package is there, like com.dailycodebuffer.springboot.tutorial. So this is the default package added. So whatever the classes or whatever the objects available inside this particular package or the sub packages will be added to the Spring container. So if you're creating different packages, you have to add the component scan and you need to add the package information. So those particular packages will come to Spring Radar and all those particular objects will be added to the Spring container when the application is starting. So we need to understand what this Spring Boot application annotation does. So these are the key things that has been added to the Spring Boot annotation. And the Spring Boot application.run method starts our application. Okay, and this is the class that is already passed. Like this is the main configuration class that should be running over here. Now we can run this application. Okay, nothing will happen, but it will be running. So if you start the application over here, run Spring Boot application, you can see that it started running. Okay, you can see that the application started running. Here you can see that my application is running on Tomcat with port 8080 over here. Okay, the Apache Tomcat is Apache Tomcat 9 and it started in 2.335 seconds. Okay, so my application is running on Tomcat now. If I go to the browser and if I hit localhost 8080 over here, you can see that we are getting the white label error page, that is a fallback page. Okay, because we have not created any of the APIs now, so it's redirecting me to the blank page, blank error page for now. But my application is running on my embedded Tomcat. So you can see that we did nothing till now. Okay, we just opened the application in our IDE and we start, and entire application was deployed to our embedded Tomcat and everything was running. Now here let's create this sample REST API over here. Okay, so to start with, what we will do, we will create one of the package over here. Let's create one package. We will say as a controller, and inside this particular controller package we will create one controller. So we'll just say hello controller. This is my controller over here. Now we have to create a simple basic API. So now we already talk about the component scan and inversion of control and dependency injection and everything. So to make this particular class as a component of a Spring, so that whenever the application is started, this particular class is added to the Spring container. For that we need to add the @component annotation for this particular class that we created. So now this particular class will be in the Spring's radar, so that whenever the application context starts, this particular class that we created new will be added to our Spring container. So whenever we need this class, Spring can give us. But technically this hello controller is not a simple component, right? It's a controller, it's a resource. So we can use a different annotations that is available, that is called controller. Now this particular controller, when you add this particular controller, it's a stereotype annotations. That means it tells us directly, okay, this particular hello controller is been added the @controller annotation. That means this is the controller by default. Now when you open this particular @controller, you can see that @component is added. So that means this will be behaved as a component by default. So that's a good thing over here, right? Because we have different components for different types of classes that we create. Currently we are creating the RESTful APIs over here. So that means my controller is still has to be REST controller, right? Not a simple controller. So for that also we have the annotations. Okay. So instead of controller, we can use REST controller over here. So this particular, when we add REST controller over here, it defines two things. It will tell, okay, this is a particular controller and as a component, plus it will tell that it will return always a response body. So if you open this, here you can see that it will always return the response body, because our REST APIs will always return some of the data. It won't return any of the JSP pages or anything, because we won't be working with all the JSPs. It's old technology. Let's use the new technology. So instead of controller, we defined, okay, this particular controller is my REST controller. So whatever the things I will be doing in this particular class, that all will be my REST endpoints. So I'm just removing the unused imports. For here in the IntelliJ IDE, I can use Control Alt O to remove all the unused imports. Okay. Now let me create one of the methods over here. Okay. I'll just say public string hello world. Okay. And this particular hello world will return welcome to daily code buffer. Now what I want to do is I want to serve this particular endpoint. Okay, whenever I hit that particular endpoint, I want this particular method to be executed. So for that, what I'll do request mapping. Okay, so whatever the request I want to execute, I'll map that request to this particular method. So for that, I will do request mapping over here, and I'll pass value as slash. Okay, so whenever I'll hit localhost colon 8080 slash, this particular method will be called, and here I'll define the method. So which type of particular method it is, it's get, post, port, delete, or whatever. So this will be my get request. So I'll say my request method is request method dot get over here. So what I did, I assigned one of the endpoint, that is slash, that is my default endpoint, to this particular method. That's a get request. So whenever we hit this particular endpoint, we will get this particular string in return. Okay, simple thing over here. One more thing, as we talked earlier, Spring Boot does all the auto configuration for us. But if you want to change any of the configuration, Spring allows us to do all those configuration using the application.properties file. So we can add all the different properties to change whatever configurations we want to change. By default, my application is running on port 8080. That's the default Tomcat container port. Okay, so that's the auto configuration done for me. But now I want to change that particular configuration. I want to run my application on port 8082. So for that, we can add the configuration in my application.properties file. So let's go to the application.properties file, and here I can change my server port. So the property is server.port over here. Okay, equals to 8082. So that's it. Now my application will run on port 8082. Really simple, right? Now you might be thinking, oh, there will be a lot of properties, and how I'll get to know, okay, which properties to change. There is an entire documentation available that Spring Boot team has provided, like which particular properties is for which particular thing. So I'll link that particular thing in the description below, that particular URL. So you can check that out, what all configurations are available and which particular properties is for which particular configuration. So it will be very easy for us to change all the configurations. So this is the default for my server port that I changed, server.port equals to 8082. Now let's run this application. I'll just click on run over here to run my application. Here you can see that my application has started. Now my application is running on port 8082 over here. You can see that. So if I go to my browser, if I change my port to 8082, and this is my default endpoint I added, and here you can see that I'm getting welcome to daily code buffer. So my application is running. Cool, right? So this is the first Spring Boot application. Now if you come over here, you can see that this particular line is still verbose, right? Because you are adding the request mapping and you're telling, okay, this particular request should be of type get. So always there are different types of requests available, right? Like get, post, put, delete, options, trace, everything. But always to add that particular thing, it's a little bit verbose over here, right? So what we can do, instead of using this request mapping, there is a different annotations available that defines that particular mapping. So we want to use the get over here. We want to map this particular method to get. So rather than using request mapping and to add the method as a request method.get, we can directly use get mapping annotation. And I'll define, okay, this is my endpoint. So you can see that we removed the entire line and it's very simple now. So this particular method we can directly identify, okay, this is the get mapping for this particular URL. And if you open this get mapping over here, you can see that get mapping has this particular request mapping over here, and it says that method is equal to request body.get, which already we did earlier, right? Instead of that, we can simplify with @get mapping. If you want to do post mapping, you can do @post mapping. If you want to do delete mapping, you can do @delete mapping. So all these particular annotations are available. We can directly use it. So it's very easy to use. So for this, let's again start our application. Okay. But for now, I'll show you the different way. So Spring Boot have the different Maven goals also to run our Spring Boot application. If you see over here, Maven, you have the different Maven life cycles available. You can run any of the particular life cycles also. So if you want to run this particular application using the command line, there is one way to use the Spring Boot Maven goals over here. So if you go to the terminal over here, we are not running from the application, from the ID itself. If you go to the command prompt to this particular folder, and if you do mvn spring-boot colon run over here, so this particular spring-boot is the Maven goals, we can run over here. So here you can see that my application started now. Okay, it's the same thing. If I go back, if I do refresh, you can see that my application is running. So we saw the two ways to run our Spring Boot application. There is one more way to run the Spring Boot application, that how we will be running our Spring Boot application in production, that I'll show you at the last. So stick around till the last. Now to close this server, I'll just do Ctrl+C over here. Okay, yes. So whenever we are developing the applications, we need to do a lot of changes and we need to start our servers after our changes. We need to test everything. So to stop the server and start the server every time once we do the changes, that's a really tedious task. So for that, Spring Boot provides the Spring Boot DevTools dependency that we can add into our project, so that whenever there is a changes, Spring Boot will detect those changes and it will restart our application. Okay, so let's add that particular thing and let's see how it's working over here. So for that, we need to go to our pom.xml file to add that particular dependency. We will use the particular project that we had already created in the Spring Initializer to add that particular dependency. So let me add the DevTools dependency over here. Okay, and if I go to the explore path over here, and here you can see that this is the DevTools dependency added. So let me just grab this thing and add in the project over here. After this, I am adding the dependency. Okay, save it. Now we need to reload our Maven configuration. So here you can see that you can reload the Maven configuration from here, and here you can see that the configuration has been added over here. Now if you are working with the STS, this particular DevTools will start working for you by default. But for IntelliJ IDEA, we need to do couple of changes so that our IDE is supporting live reload functionality, live building functionality. Okay, because by default IntelliJ IDEA is coming by disabling all those particular functionality. So let's go ahead and add that particular thing. So if you do Ctrl+Shift+A over here, you can see you can search everything over here, and here you search for the registry over here. Okay, in this registry, search for the compiler.automake.allow.when app.running. Search for this and tick mark this, so this particular things will be enabled over here. So that's the one thing that you need to do the changes. After that, go to the file, go to settings over here, go to build execution deployment, go to compiler, and here you can see that enable this build project automatically. Okay, so these are the two settings that you need to add in the IntelliJ IDEA. Once this is done, you can run your server. So you can see that my server has started running now. And if I go to the home controller, this is what I should be getting. So here you can see that I'm getting welcome to daily code buffer. Now if I do any changes over here, if I do some extra AAs over here, okay. And here you can see that if you wait for some times, this particular changes should reflect. Here you can see that it reflected the changes. You can see that condition evaluation unchanged. So we are not restarting the server. If we go again and if I hit refresh, you can see that my changes are reflecting over here. Okay, so that means my DevTools is working. So this is what you should add when you are developing your Spring Boot applications. It will save a lot of time for you guys. So this is all about Spring Boot DevTools dependency. Now let's see what we are going to build today over here. Okay, what application that we are going to build. So if I have created a diagram over here. So here you can see that we will be building the backend application only. That is the creation of the REST APIs. So here you can see that I've just added all the front-end technologies. So from all these particular technologies, we can call our RESTful APIs, right? So we can create our entire backend using the Spring Boot, and from the front-end, anything can call these APIs to create the entire end-to-end full stack application. So what we'll be doing is we will be working with one department entity. So we'll be creating one department. So for that particular department, we'll be adding the different REST APIs. We'll be creating one post API to save that particular department. To get all the departments, we'll be creating one of the API. To get a particular department, we'll be creating one API. We'll pass one of the IDs. So for that particular ID, we will be getting the data back. We'll create one of the API to delete that particular department. And we'll also create one of the APIs to update that particular department. When you pass any of the ID, like I've created 4 to 5 departments and I want to change one of the department, that is department ID 3, then we can pass 3 and we can pass the data. So that particular department will be updated. So we'll be creating bunch of APIs over here to work with the department entity over here. So this entire particular thing we will be adding in one of the department controller that we create. So that will be our controller layer to handle all our requests. After that, we'll be creating one service layer. Our service layer will be our business layer. So all the business logic that we want to add to handle our department will be adding in that particular business layer. Controller layer is just to get the particular request and get the response back. So it's just for the routing purpose. Your service layer will be the main business layer where you will be writing all your logic. And after that, from that particular service layer, you will be calling your data access layer or your repository layer. This particular layer will be responsible to interact with your database. So whatever database operations will be there, this particular layer will be handling all those particular database operations. And we'll be having one database also. So currently for starting, we'll be using the H2 in-memory database. But after that, once we create a few of the APIs, we will switch over to the MySQL database. So you will get the understanding also how you can switch the database as well using the configurations. So these are the different layers that we are going to create. We'll be working with one of the department entities as well. So for this particular repository layer, we'll be using the Spring Data JPA over here. Okay, so for Spring Data JPA, we need to add the particular dependencies as well. So we'll be adding that particular dependency also. And for the database, we are using the H2 in-memory database. So we'll be using the browser-based console. So we need to add the configurations to enable that particular console as well. And we can add all the different configurations also. So let's create that particular application now. We already added the H2 in-memory database dependency. If you go to the pom.xml file, okay, we already added H2 database over here. Now we need to add the JPA dependency. So let's go to the Spring Initializer and let's add the JPA dependency. Okay, Spring Data JPA. This persist data in SQL, stores with Java Persistent API using Spring Data and Hibernate. Let's go to the Explore. And here is your Spring Data JPA. Okay, I'll just copy paste over here. You can see that we are not adding the version information over here because whatever the Spring Boot parent version would be, all those particular versions will be the same. All those particular things will be based on the our parent Spring Boot version. So here you can see that all the dependencies are added for my Spring Data JPA. So let's close this particular file. Now let's add the configuration for our H2 in-memory database. So we need to go to our application.properties file. And here we can add the configurations. So I'm just copy pasting all the properties over here and I'll explain you. Here you can see that we have added spring.h2.console.enabled equals to true. So we are enabling the web console using this particular property over here. Now after that, you can see that we are adding spring.datasource.url, that is jdbc:/h2.memory.dcbf. So this is what our database URL is. So we are using the H2 memory database and DCBF will be my database name. And after that we define spring.datasource.driver class name. So this is my driver, that is org.h2.driver. So we are using H2 driver over here. And these are my username and password, that is spring.datasource.username equals to SA and spring.datasource.password equals to password over here. And we define the JPA database platform as well, that we are using H2 dialect over here for using our JPA data source platform. So with this particular properties, our entire H2 database is configured for our JPA in Hibernate. And we also enable the H2 console. So let me just start the application and I'll show you our database as well. Okay. Let me just start this. So here you can see that once we added this particular configuration, that is JPA, here you can see that Hikari connection pool has been added. Okay, so all this particular, you can see that JPA entity manager factory has been added. Internally it is using Hikari connection pool to maintain all the database connections. So if I go to my browser now, and this is my application, and here if I do /h2 console, over here my H2 console will open. Okay, here you can see that this is my H2 console over here. This all the details are pre-populated. You can see that your driver class name, your JDBC URL, whichever we gave over here. Okay, everything is populated. If not, you can copy paste this information and you can add over here. Here you can see that your username is also populated, that is SA, and your password is this password. So you can add this particular password over here, test the connection. You can see that the connection is successful. So after that you can connect also. So here you can see that you are connected to your H2 console, and you can see that this is my schema, this is my database. Currently there is no table created for it. Now let's go ahead and create the department entity and create all the layers, and let's start working on it. And here you can see that we have created one of the packages. So let's go ahead and create the different packages for it now. So I'll go ahead and create. So the first package I'll create is the entity package. Okay, to create my entities. Then I will create the service package for our service layer. Then I will create repository package for our data access or repository layer. Cool. Now in this entity, we will create our department entity. So let me go ahead and create new Java class, and I'll say as a department over here. Inside this particular department, let's create few of the properties. So I'll just say private long department ID, private string, department name, private string, department address, private string, department code over here. So these are the different properties that I have added over here. Now let's create the getter setters. In the IntelliJ IDEA, you can use Alt Insert to create the different generators. So I'll just use getters and setters over here. I'll select all the properties, click OK to generate all the getter setters for it. Now I'll also use the same Alt Insert to create the constructor over here with all the fields. Okay, this constructor with all the fields, and I also create the default constructor as well. Constructor, default constructor, and I'll also create toString method over here. Cool, right? So this is the entity that we created. So now to make this particular class as an entity so that it can interact with our database using the JPA, we need to annotate this particular class with @entity over here using the javax.persistent.entity package over here. So now this particular department can interact with my database. Now as in the relational database, all the tables will have one of the primary key. So for this particular entity also, we need to create one. So my department ID will be my primary key. So to make that primary key, I need to annotate with @ID over here. Now how you will be generating your primary key, that also you can define over here. So here I'll define generated value status equals to generation type auto. So this is my entity created over here. Now for this particular, we need to create the controller now. So I'll go to the controller package and I'll create the new controller that will say department controller. As we saw in the particular home controller, we will annotate this particular department controller as REST controller. So this will be behaved as a REST controller and we can create the REST APIs over here. Now we have to create our services and repositories as well. So here we'll go with the standard practice over here. So we will create the interface for our service and we will create the class implementing that particular service, because one service can have multiple implementation as well. So we'll go with the same approach. We'll create the interface and we will add the implementation for the service as well. And for the repository also, we will create the interface for it. So let's go ahead and create the interface, that is new Java class. I'll select the interface over here and I'll say department service. This is my interface over here. Now I'll go ahead and create the implementation class for it. I'll say department service implementation, that is IMPL class. And I'll say this particular class will implement department service. And for this particular department service implementation, I will annotate this with @service. So we can know this is a service implementation for it. And here you can see that it also has the component source. This will be in the Spring's Radar. And if we go to the repository also, we can create the interface, that is department repository, which is an interface, and we will annotate this particular interface with @repository. Now for this particular department repository, we won't be creating the concrete implementation class, rather we'll be extending the JPA repository itself, because JPA repository gives us a lot of different methods that we can use directly for interacting for our entities with the database. So let me just show you how to do that. I'll just use extends JPA repository over here. Okay, you can see the first one, JPA repository. And for this particular JPA repository, you need to pass your entity. So that is my department entity. And you also need to pass what's your primary key type. So my primary key type is long. So if I go to the JPA repository over here, you can see that this particular JPA repository extends paging and sorting repository and query by example executor. And if I go inside this also, you can see that it is extending CRUD repository. So we will be getting all those particular methods that are already been created for it. You can see that we're getting find all method. Okay. And here you can see that find all by ID, save all, flush, save and flush, delete in batch. All those particular methods are already created. So we don't have to create all this particular implementation. We can directly use this particular JPA repository for entire implementation itself. So I'll show you how easy it is. Okay. So here you can see that we created all the particular different class, that is my department controller, my department service and department service implementation, and my department repository also, which is extending JPA repository. And for all this particular classes and interface, we have added either repository or either service or either REST controller, which are the default annotations, which is adding component for all our classes. So that means all the classes that we already created are in the radar of Spring now. So whenever the Spring application starts, all this particular objects will be created and will be added to our Spring container. So whenever we want, we can tell Spring that, okay, I want this particular class, so we can use it directly. Now let's go ahead and create the methods for our controller. So let's go to the department controller, and here I will create first method, that is to save the department over here. So let's create the method. What I'll do, I'll create the public method that returns the department object which is created, and I'll say the method as save department. And this is my method over here, and I will map to post mapping over here. And I need to call this particular post with /departments. So this is a simple mapping that I already did over here. Now what I want to do is, as I'm creating the REST API using the post mapping, that is the post request that I'll do from any of the REST client, I'll be passing the request body as well. So that will be the entire JSON object that I'll be passing in. So what I want that entire JSON object to be coming over here and to convert that particular entire JSON object to my entity, that is the department entity. So first let me define that what I want as an input. So I'll just say I want my department over here. Now whatever the JSON data that you are passing has to be converted to this particular department. So for that, what we'll do, we will add request body annotation. So we are telling Spring that whatever the data you are getting as a request body, okay, whatever JSON you are getting, get that particular JSON and convert that particular JSON to my department object over here. It's a simple thing. Without Spring and Spring Boot, what you have to do is you have to take that entire request body from the request HTTP request that you are getting, get that particular request, and using the object mapper, any of the Jackson or JSON, you have to convert that particular JSON object to the particular Java object. So that's all the steps that you have to do manually. But with this particular annotation, Spring is doing that for us. So with this particular one annotation, we are getting entire JSON object to my department object over here. Now I want to save this. Okay. So now what we have to do is we have to call this service layer to pass this data. And from that service layer, we'll do the business logic. And after doing that business logic, we can call the repository layer to save that particular data over here. Currently, we don't have anything to do. We can directly save it, but still we'll go ahead with the approach over here. So what we can do over here is we can do department service equals to new department service implementation over here. Okay, simple. We are creating the object over here. But why? Right? Because we are already using Spring over here. Spring knows that we already have that particular department service and department service implementation class and interface already created, and Spring also knows that okay, this particular class I have in my Spring container. So whenever someone asks, I can directly provide that particular object that is already created. Why user have to create that particular object by their own? So this is what we are doing over here, right? We are creating the object with this particular new keyword. So we are taking the control back. I don't want that. So what I'll do, I'll just remove it. I don't want to create the object this way. What I want to do is in this particular class layer, I am defining that this is the particular object that I want. I want the department service over here, but still Spring is dumb, doesn't understand. So we need to tell that, okay, this is a particular department service and I want it from you. So for that, I will define auto wire. That means auto wire the particular object that you have in your Spring container to this particular reference that I have created. So that object will be attached, auto wired to this particular reference that we created. So now it's simple, right? We use the dependency injection and inversion control from the Spring's functionality. Okay, we are not creating any of the object now. Spring has the object. We told them I want that object with the auto wired. That auto wired will wire that particular object with the reference that I created. Now there are two types of auto wiring or two types of dependency injection that we can do in the Spring, that is constructor based and the setter based, and here we are using the property based. So we are just creating one of the property and we are directly using the auto wire to attach that particular object to my property. You can also go ahead with the constructor based. You can create the constructor, you can pass this particular department service in the constructor, and you can create the object as well. So there are different ways you can do the dependency injection as well over here in Spring. Now here what we can do is we can create, we'll just return department service dot, we'll give the same name over here, and we'll pass the department object that we are getting. Okay, over here. Now there is no save department method created in either of the service or service implementation, so we have to create it. So let's create it. Here in IntelliJ IDEA, if you do alt enter over here, you can see that it is giving the option to resolve this particular error. So it is saying that create method save department in department service interface. So let's go ahead and create it. So here you can see that this particular method is created over here, and I'll say it as a public method over here. And here you can see that it has a problem for this. So that means whatever the service implementation class for this department service is there, we have to go ahead and implement that as well. So let's go ahead, we'll do the alter insert and we'll say implement methods available. So here you can see that this particular method is implemented over here. Now it's still returning null over here. So what we need to do over here is we need to get the reference of the department repository over here. So we'll do the same thing what we did in the controller layer. We'll just do private department repository. We'll create the reference to it and we'll do auto wire. So that means this particular object will be attached to this particular reference. Now we can call department repository dot. Here you can see that there are a lot of different methods available from the JPA repository that we have extended. Okay, so here I'm looking for a save method. This is a save method which is taking the entity over here. So my entity is department. So I'll just pass this department and voila, that's done. So with this particular method, my department will save to my database over here. And here you can see that we have not created the table also. Spring Data JPA will create that particular table also for us. Okay, and whenever there is an update to it, that particular update JPA will do to our database as well. So now what we'll do, let's test it out. Okay, so now testing out, you can use any of the REST client you want. You can use Postman, Insomnia. You can, if you're using VS Code, you can use Thunder client as well. You can use curl as well. You can use HTTP Py as well. There are a lot of clients available. You can choose any of the one which you're comfortable with. Here I'll be using Insomnia for now. You can use Postman as well. That will be also okay over here. What we'll do is we can start the application. We can open the Insomnia as well, and we'll see what's happening in our database as well. So let's start the application. Here you can see that my application is started now. If I go to the H2 console over here, if I refresh, let me log in, and here you can see that particular department table is created, and department ID, department address, department code, and department name. These are the 4 entities that we created over here, properties, okay, the department. Cool, right? Now let's save the data. If I do over here run, you can see that there are no records available. So if I go to the Postman, let me create the new request over here. Okay, I'll say save department, which will be the post request, create it. And here I need to give the URL. I'll just give http://8082/departments over here. And in the body, I need to give the JSON data. So let me give the JSON data over here. So let me just copy paste the details over here, okay, from the department entity. So I want department name, I want department address, and I want department code as well. My department ID will be auto-generated, okay. So I'll just give my department name is IT, department address as say Bangalore, department code I'll say IT06. So this is my JSON data over here. This is my API with the post request. If I do send, you can see that it's 200. Okay, that means data is saved, and this is the data that we are receiving back. And you can see that department ID is created 1. If I go back over here and if I do run this particular query, you can see that this particular data has been saved over here. And if I save another data, CE is the department, computer engineering department, and I'll say C07. It's still in the Bangalore, and if I hit send, you can see that this particular record has been inserted and we have 2 records now. Okay, so my save functionality is working fine. Now you still have to remember that we are still working with the H2 in-memory database, so whenever we restart our application, we will be losing all our data. So now let's go back and work on the get APIs. Now here we will add one method that will allow us to get all the departments from the database. So let's create one of the method over here. We'll say public, and here as we need to get all the departments available in the database, we will use the list of departments. So I'll just say list of departments available, and I'll just say fetch department list over here. Okay, and here this will be the get mapping. Okay, so I'll just say get mapping of departments. Now from here we need to get the list of departments from the repository and send back. So I'll just use return department service dot fetch department list over here. We are not taking any input over here because we need to send all the data back. Okay, and this particular method we need to create in the service interface and service implementation as well. So click on alt insert, create method fetch department list in department service. Yes, and make it public. We'll go to the department service implementation class, alt insert, and implement this particular method. So this particular method list of department fetch department list will send the list over here, and instead of return null we will say department repository dot inside this department repository we have a method that is find all, that will get all the department as a list and will send back. Done. So this particular method will get all the departments available in our database. So let's run this. Over here we can see that our application is started. Let's go back to the Insomnia in the save department. Let's save the department. Okay, CE Bangalore C07. Let's save this, and I'll save also IT department IT06. It's in Bangalore. And I'll save one more department, that is electrical engineering. It's in Ahmedabad. And I'll say EEE01. And here you can see that we have added 3 records over here in our database. Okay, let's create new request. I'll say get department, and it's a get request. Okay, let me copy paste the URL from here. HTTPS localhost 8082/departments. That's what we have defined over here in the department controller. Okay, so we'll be using the same. This will be the get request. Now this particular request should return me 3 records. If I hit send over here, we can see that we are getting 3 records over here. So all the data we are getting from our database. Now this is to fetch all the data available in our database. Now what if we want to get a particular record based on the ID, that is a primary key, which is department ID over here. So let's go ahead and create one of the APIs where we will pass the ID of the department, and based on that ID we will be getting that particular record over here. So let's go to the IntelliJ IDEA, and here what I'll do in this controller layer, okay, I'll create one of the methods that is public, and here we need a particular department based on the ID. So I'll say department because I need that particular object only. I'll say fetch department by ID, and this will be again get mapping over here. I'll say it will be /departments. Now whenever we are calling this particular /departments, I want to pass a particular department ID for which I want to get the data. So that particular part will be dynamic because I can send any of the IDs over here. So that is called a path variable, right? Because what we'll be doing is we'll be doing localhost colon 8086 slash departments slash whatever id we are adding. Okay, that's a path variable. So we can define as this way. So this is particular dynamic value, that whatever id we get, we have to get as a department id, and we have to get this particular id what we define over here as an input parameter to our method as well. So what we'll define long department id over here. Now we need to map this particular id with this department id. So for that we'll annotate this with path variable, and this path variable is id over here. So this path variable id, whatever defined over here, you need to give the same value over here, and this will be attached to this particular department id. Now we can find this particular department based on this id. So let's create the method over here. We'll say return department service dot fetch department by id, and here I will pass department id over here. Again, I need to create this particular method in service class. So alt enter and create method fetch department by id in department service. I'll make this as a public method, and I'll go to the department service implementation, implement methods, and I will implement this fetch department by id method over here. We need to use this department id as an input parameter. So what I'll do, department repository dot find by id. Okay, this is the method, and here you can see that it will return the optional of department, and it is taking long id as the input variable. So I'll pass department id, and here this entire particular thing, this find by id, will return the optional. So to get the value of department, we will use get over here to get that particular department. Now let's go to the Insomnia and test this. Okay, no data because we need to add the data back again. So let's go ahead and add the data. So we'll save the first record, we'll save the another record, that is IT department IT06. I'll add send. Okay, if I go to the get department, and here you can see that I am getting two records over here. But suppose if I want to get a particular record, suppose department ID 2, I want IT department. So with the get request with the same URL, we did extra thing over here is we added the ID over here, that is a dynamic ID that we can pass. So let's pass the 2 over here, and if we hit send, we should be able to get this particular IT department. Here you can see that I am able to get this particular IT department over here. So we did get all and get by ID. Now let's implement the delete functionality. So let's go to the IntelliJ IDEA, and in this particular controller, let's create one more API over here. Okay, I'll say public string delete department by ID over here. Okay, and this is the particular method, and here what we'll do, we will do the delete mapping over here. Okay, and with this delete mapping, I will add the same API over here. Okay, same URL with slash department slash ID, whatever we pass, that particular object I want to delete. And here I will add long of department ID, and this should be again path variable. The same information that we add in the get mapping in the previous method, the same information we are adding over here. As we are passing string over here, what we have to do is, if everything is successful, we can pass return department deleted successfully, and let's call the department service method as well. We'll call department service dot, we'll create this particular method, that is delete department by ID, and for this we will call, or we'll pass department ID over here. We need to create this particular method in the service as well. So let's create So let's create this particular method. Sorry, we need to pass department service over here, right? So now we have a value that is create method delete department by id in department service. Okay, so let's create the method. This is of type void. We'll pass public over here. Let's go to the department service implementation class and let's implement this method. And here what we'll do, we'll call department repository dot delete by id over here. Okay, and here I'll pass department id. Okay, this particular department by id is returning void over here, so that's why we are not returning directly, we are returning the string over here. So whatever the id we will be passing, that particular thing should be deleted. So let's check it again. We'll go to the insomnia, we'll go to the save department API. Let's create this API, that is IT department is created. Let's create the C department, C07, send over here, C is created. The get mapping if we can do, okay, that particular record is created. And if I check for all, you can see that we are getting all the departments. Now let's create the new request for the delete one. New request delete department. We'll use the same API, right? So I'll just copy paste it, and this particular get should be delete over here. And suppose I want to delete this particular C department over here. Okay, so I'll pass 2 over here and I'll hit on send. Here you can see that we are getting department deleted successfully. And if I do the get operation over here again, you can see that we are getting only one record over here. So that means our delete functionality is working perfectly fine. Now let's go ahead and implement the update functionality. So in the update, whatever the ID that you pass, so /department/ID, whatever particular update operation you want to do, plus which particular data, which particular new data that you want to update, and that also will pass as a body over here. So let's go ahead and implement that. In the IntelliJ IDEA, we'll create a new method. We'll go to the controller again. Let's create the new method over here. We'll create public and we'll return the department object over here. Okay, and we'll say update department, and this particular will say put mapping. Put is used for update, and this API would be the same I'll using. Okay, now here we have to add two things. We need to take the path variable also, that is ID over here, plus we need to take the request body as well. So whatever the path variable, whatever the ID that we get for that particular record, if it's present in the database, we have to update with the new values that we have. So let's do that. What I want is, I want long department ID and I want department object as well, but my department object would be request body and my department ID would be path variable with ID over here. Two things I have defined over here. Now we need to call the service layer. So let's call the service layer. We'll say return department service dot, we'll create the method that is update department only, and in this particular method we will pass department ID and department, both the things. And let's create this particular method in the service class as well. We'll create the public method. Let's go to the service implementation class and let's implement this particular method. This is the method update department, which is taking department ID and department as the input parameter. So here what we'll be doing is, we will first get the department which is already available in the database, get that particular object, and then whatever the changes that we have done in this particular department, we will update with that particular value. So suppose after the 3 fields that you have, if you only change in one of the fields, we should only update that particular field, and we should check if the other fields are null, then we can skip it. So let's do that. We will do department from DB equals to department repository dot find by ID. We'll pass department ID dot get. Sorry, it should be find by ID. Okay, simple. Now once we get this particular department, we can check if any of the particular parameters are null. Then we can skip it. If there is any value, then we can update this DEP DB object over here. So what I'll do, if objects dot non null, I'll check department dot get department name and not blank dot equals ignore case department dot get department name. Then I'll say DEP DB dot set department name equals to department dot get department name. Simple, right? We are just checking if anything is not null and not blank, then only set the value, otherwise skip it. So let's copy this and set for the other entities as well, other properties as well. So department name is done. Then we'll go for get department code over here, department code and set department code. And here we'll go for get department address. So department address, I'll just copy paste it and set. So here you can see that we did the null checks and blank checks for all the three values. And after that I can say return department repository dot save department DB. So it's very simple over here. We took the value from the database, that is DP DB over here, and whatever the input parameter that we got from the endpoint as a request body, we are checking the null checks and blank checks for all the values. Whichever are not null and not blank, that only we are updating to the database. Rest we are skipping it. And after at the end we were just calling the save method of a department repository. So that's it. So let's check it. We'll go to the Insomnia. First we'll save the value in the database. Okay. So here you can see that is the first record. Let me add the second record as well. IT06 send, and if I do get over here, you can see that I am having two records over here. Okay, so let's create new request for update. I'll create new request, update department, and then I'll change to put method JSON body create. Here I need to pass a JSON data. So let me just copy it from here, and I'll also copy the URL as well, and I'll go to update and I'll paste it. If I go to the get department, here you can see that for the second department 2, the department name is IT, the address is Ahmedabad, and department code is IT06. Okay, so for the second department ID we will do the changes. So I'll pass /2 over here, and instead of department name IT, I'll say information technology, and the rest of the things I am passing the same over here. Okay, so let's hit send over here, and here you can see that particular department name is updated for the second record over here. If you go to the H2 console also, we can see the same. Okay, let me just log in over here. And if I run it over here, you can see that we are having two records and the IT department is changed to information technology over here. And suppose if I remove this information over here and remove department code also, and just I'm telling that change the address of the second department. Okay, that means information technology to Bangalore. And if I hit send over here, you can see that only Bangalore updated, rest of the thing is everything same. If we check the database also, you can see everything is updating correctly. So we successfully implemented entire CRUD application, CRUD endpoints for our department service. We did get, get all, save, update and delete everything. Now let's see how we can add the different extra endpoints also. So now let's create one of the endpoints that will return the department based on the department name that we pass. So let's go to the IntelliJ IDEA again. Let's go to the controller, and here let's create the new endpoint. We will say public department, and I'll say fetch department by name. Okay, and here I will pass the get mapping over here, and inside this particular get mapping I will pass slash departments, and slash I'll say pass the name, and slash I'll say pass that particular name that you want to pass, and here I'll say string department name over here, and we need to bind this particular department name with the path variable that we have defined, that is name. So I'll just say path variable name over here. It's pretty simple over here. Okay, now let's go ahead and implement in the service and repository layer. We'll just say return department service dot fetch department by name. We'll pass the department name over here, and let's create this particular method in the service layer. Create method. We'll go to the service implementation and we'll implement this particular method, that is implement methods over here. Now for this particular fetching the data for department name, there is no default method available in the JPA repository. Okay, so that means we need to define one for us to use that. So let's go ahead and create one. Okay, let's go to the department repository. This is the interface. Let's create one method. We'll say public, which will return back the department. Now the naming convention is the main thing over here. What we need to do is we need to give find by, after that whatever the name of your entity is. So the name of my entity is department name over here. Okay, let's copy it. Let's go to the repository layer and paste it, and the naming convention should be this way: find by D capital, always in the camel casing. Okay, department name over here, and this department name should take string department name as the input parameter. That's it. So we don't have to do the implementation for it. With this particular naming convention we should be able to get the data back. Let's go to the service IMPL and let's do return departments repository dot find by department name, and let's pass the department name over here. Simple, right? Now let's go ahead and check how it's working. Let's go to the insomnia. Let's go to the save department and let's create the department over here. The first department is created. Let's create the second department. CE07 send. Two departments are created. Let's check in the get mapping. Two records we are getting over here. Now let's create one more request over here, department by name, and I'll do the mapping over here. What we have to pass is we have to pass department slash name slash the name of the department that you want. Suppose I want CE, then I need to pass the exact value that we have added to save the data. That is C in capital, need to pass C in capital, and if you hit send, you can see that you are getting the data back. So it's matching the data correctly. Now if you pass the C small over here, you can see that there is no data available because it is matching the exact value over here. Now how to make sure that you are getting the exact values? So let's implement that method as well so that you are getting the exact values. So what we will do is we will go to the IntelliJ IDEA again. We'll go to the repository and let's create one more method that will return the department based on the department name and ignoring the case. So we will define ignore case. Simple. Okay, now we need to call this particular method from our service IMPL. Now let's check this again. Now let's go to the insomnia. Let's go to save department. Let's save this C department. First record is saved. Let's save the IT department as well again. If you see the get departments, you are getting both the departments. And if you pass CE in capital over here, you can see that you are getting the data. But if you pass C in small also, you should be getting the data because we added the method for case insensitive. So whether it's in capital letters or in small letters, it should be able to match the records. So that's how we can implement the different JPA methods. Now you might be wondering how I'll be get to know like what are the different methods or what are the different method names that you want to give to get that particular records. So for that, let's check the documentation for that. I will link this particular URL in the description so you can check this out. But if you go over here you can see that these are the different keywords available, how you can use and how you can create the method names. So yeah, you can see that if you want to get the distinct records, you can use find distinct by whatever the value you want. Find distinct by last name. So suppose in our case it's department name, so we can pass find distinct by department name. And if you want to get the data based on multiple values, you can see we have here it's added and you can give the another value as well. And in the input parameters, you need to pass the two values. First input parameter will pass as a last name. The second input parameter will be passed as the first name over here. And the equivalent JPQL snippet, JPQL query, you can see it's this: select distinct, the table name, whatever the entity name is, where x dot last name equals to question mark 1 and x dot first name equal to question mark 2. So first and second property it will pass this way. You can go for AND properties or is equals find by first name is whatever the particular value that you are passing. If you want to get the dates between the two dates that you pass, you can use find by start date between. So if you can pass two values, date 1, date 2, and you will get the records between that two dates available. If you want any value with less than, equal, greater than equal, all these particular things you can check over here. Based on this particular naming convention, if you follow, you will get the data. Now sometimes if you want to get the data and that data may be complex, the query may be complex, and you may not be able to achieve using this particular syntax to create those particular methods. So for those type of case, you can also go ahead with the JPQL. And if you are not able to go with the JPQL as well, at that time you can also go ahead with the native SQL queries also. So for those type of case, you just have to pass the @query annotation over here. So whatever we created the method over here, right? So that particular method that you create, suppose in our case, this is the method that we create, that is find department name ignore case. And if you are not able to get that particular, it's complex something, then you can annotate this particular method with @query over here, spring framework data.jpa.repository, and in this query you can pass your entire query over here. If it's JPQL query, just pass the JPQL query, and wherever the input parameter is there, you have to pass question mark 1 for the first parameter, question mark 2 for the second parameter. And if it's the native SQL query, then just pass the query over here, and there is a native query equals to true value available. So just pass this value, that native query equals to true. That means after that, this particular query, whatever you pass over here, SQL query, will be treated as the native query and you will get the data. So this is also you can use to get the data. Either directly use the method names. If not possible, go with the JPQL. That also, if you feel some difficulties in that, you can always go ahead with the SQL queries natively also. So this is the documentation for it. I will link that in the description below so you can check this out. There are a lot of things available and it's very easy to implement. Here you can see that it's the native query, right? It's done select queries, question mark 1 for the first value, question mark 1 for the second values. Okay, here you can see that it's defined like native query equals to true. So you can always get the data. Now here we added all the APIs over here. Okay, now what we'll do is we will add the validations for all our APIs that we have created. So what we can do over here is, suppose we have 3 to 4 fields that is coming as the input parameter for our APIs, right? To save the data or to update the data. And we can add the validations like, okay, I want my department name always to be available. Okay, without my department name, that particular JSON data, particular request body, that whatever we are getting from the client, that should be invalid. That should be bad request. So that means every time that particular thing should be available. we can add a lot more different types of validations when we are getting the data as the input as the JSON format to our APIs. So let's see how we can add those particular different validations. So all these particular validations we can add using the Hibernate validation. So for that, we need to add the dependency for it, and we need to annotate our entities to validate all our requests. So let's go ahead and do it. So we'll go to the pom.xml file and we need to add the dependency. So this is the Spring Boot starter validation over here. So let me just add it over here. You can see that Spring Boot starter validation. This is the plugins that we have added. Let me just do Maven install again over here. And with this particular dependency, if you go to this particular starter, here you can see that it is using Hibernate validator over here. Okay, so this particular thing that we are using over here to do our validations. Now how to add the validations? So suppose let's go to the department entity over here, and what I want is whenever I'm getting the data as an input from the JSON, I want my department name always, because my department name is very important. I want to save my department with my department ID auto generated and with the department name. If I don't have address and code, that's fine, but I should be having department name. So what I will do over here is I will add the annotations over here so that the validation can happen. So what I'll add the validation is not blank. Okay, here you can see that it is from the javax.validation.constraints package over here, and with this particular not blank, I will add the message over here, like what particular message I should display when this particular validation fails. So I'll just say please add department name. So this is the particular validation that I have added over here for this particular department name. Now if you go to the controller and in this particular post mapping, this is where that we are getting the data. So this is the place where we are getting the request body. Now whenever we are getting the request body over here, we need to validate that. So for that we will add @valid annotation over here. Okay, that is from javax.validation. So just add this. Okay, sorry. So add this annotation that is from the javax.validation over here. So now whenever the request is coming over here to save the data from the post mapping, that particular request, that JSON body as coming as a request body will be validated against the annotations that we have defined over here. There are a lot more different annotations available for the validations. So for now, let's test this out. Okay, so let's run this application, and my application is started. Let's go to the Insomnia, save department, and if I hit send over here, you can see that my data is saved. Now what if I am not passing this department name over here? Okay, and if I hit send, here you can see that we got the error, that is 400 bad request. And if you scroll down over here, you can see that we are getting the default message that is please add the department name. This is what we added over here, right? So that means this particular validation is happening. Okay, and you can see that we are getting all the different values, that is object name is department, field is department name, rejected value is null, so it was passed null, so this particular value got rejected. So there are a lot more different validations available. Okay, let's see that what are the different things available. There is not blank available. Suppose if you want to check the length, okay, and then you can add the length over here, and inside this you can pass max value, and you can pass min value over here. Okay, and you can also pass the message. You can check the size as well. In this size also you can pass the max value and min value over here. You can check for the email validation, that this is a particular email field over here. You can also check if this particular, if there is an integer value or long value. You can also check if that particular value is positive, that particular value is negative, or you can also check positive or 0. So positive and 0 is allowed with @ negative or 0. Negative and 0 value is allowed. If there is a date field, you can check that particular dates are future or particular date is future or present. Similarly, you can check for the past dates and past or present also. So you can see that there are a lot more validations available, and for all this particular validation, either you can pass the regex. For the email, you can pass the regex expression to match that particular regex expression for email validation. For length size, you can pass min max values. For the different positive negative values, we can validate future dates, past date also we can validate. So these are all the different types of annotations we can use to validate our input request, that is JSON data. So you can check all this particular out, and you can add the annotations based on the fields that you have and based on the validations that you want to add for that particular fields. So we are just using not blank over here now, but these are a lot more that you can use. I'll just comment it out for now, and I will add the code in the GitHub, and I'll share the link with you so you can check this out. So these are all the different validations. Now what we can do is we can add the loggers in our application. So all the applications should have the loggers, right? Currently you can see that we have not added any of the loggers, but we can go ahead and add the loggers. It's very easy in Spring Boot. Currently we will just add the simple loggers over here, but that particular loggers can be extended to file based loggers. Like you can save that particular loggers in a particular file. You can add the rolling based file logging functionality, like for every day you can create the new files, or based on a particular size limit you can create the different files. All these particular configurations you can add using the application.properties file that we have. So you can check all those particular things. It's very easy, but for now let's add the simple logger over here, and we'll see how we can add the logging over here. So Spring Boot comes with the SLF4J logging library within the system with all the Spring Boot starters available. So let's go ahead and use that. If you want, you can use a logback or log4j with SLF4J. So there are different libraries available. If you want to add those, you can add that particular libraries in the pom.xml file and you can use. But if you are directly using SLF4J, you don't have to add any of the libraries. Those are directly available and you can directly use it. So let's add in the department controller over here. So for the loggers, what we'll do is I will add the logger over here, that is private final logger class. Okay, this logger I'll be adding from the org.slf4j, the first one, and I'll say logger equals to logger factory dot get logger, and here we need to pass the class name, that is department controller dot class over here. So here you can see that this is a simple logger implementation that I added, that I'm using SLF4J implementation, and using from the logger factory I'm getting the get logger for the department controller class. Now suppose I want to log whenever the particular request comes to this particular save department. So what I can do, I can say logger object that I created, logger dot info, I'll say inside save department of department controller. Simple over here. Okay, so I'm just adding one of these particular loggers over here. Let me add the same for get departments also, inside fetch department list of department controller. So similar types of logger you can add in all the particular service and repository layers, and these particular loggers will be helpful for debugging our applications, right? So it's just a simple logger that we have added. Let's restart the application. And now when we call the save department, hit on send, you can see that we got 200. Okay, and if you go over here, we also got the log as well. You can see that particular entire, which particular thread it was, which particular class it was, and what's the log message over here. So you can see that we are getting the logs as well. If you go to the get department and if I hit send, you can see that we got the logs for that also inside fetch department list of department controller. So we simply added the loggers over here. Okay, so logging is implemented over here. Now we can create the different policies how we want to aggregate the logs, either in the console, either in the file, either we want to create the rolling policies. All those different configurations we can add in the properties file. So if you go to the documentation, you will get everything, but this is how you should, or you will be implementing loggers in your Spring Boot application. Now as we are working with the Java application, we tend to create a lot of POJOs, right? So we'll be creating the POJOs, we'll be creating the properties, and for all those properties we'll be creating the getter setters, constructors, toString methods, and all those different things. Now creating all those particular different things is easy, but your code is not looking good, right? Because if you see that particular example of our department also, for the particular 3 to 4 fields that we have created, for this particular 4 fields, we created getter setters, we created the all arguments constructor, that is constructor with all the arguments with the default arguments, two string methods. You can see that your code is around 82 lines, but at the end you just need this particular 4 fields over here. Now we should be getting rid of all those particular things, right? Because we don't need it. So for this particular thing, there is a library available that is called Lombok. Now Lombok allows us to remove the boilerplate code from our Java applications. So what we can do is we can remove all this particular getter setters and everything, and we can use Lombok, and that particular plugins will add all these particular methods at the time of compile time. When particular compilation happens, all those particular methods will be created. So we don't have to see in our code, but that will be available. So let's see how to implement that. So if you go to the Spring initializer that we had already, right? This is a particular project that we had already opened. If you go to the add dependencies and if you search for the Lombok, here you can see that Java annotation library, which helps to reduce boilerplate code. Let's add this particular dependency. Go to the explore and copy paste the data from this particular pom.xml file. If you see over here, this is the particular dependency added. So let's copy paste this particular dependency, go to our pom.xml file, add this particular dependency. And once we add this particular dependency, we also need to tell the Maven plugin that we are using Lombok. So copy paste this also, okay? This entire plugin, this plugin we will copy paste. So we are excluding Lombok over here. Now once you add the Lombok, for your IDE to know that you are using Lombok, you have to add the plugins in your IDE. If you are using any of the IDEs, either IntelliJ IDEA or STS or Eclipse or VS Code, all those have this particular Lombok plugin. Just go to your plugin sections and search for it. I'll show you for the IntelliJ IDEA. If you search for the plugins over here, and if you search for Lombok, you can see that I've already installed, so it's coming over here. Okay, you can go ahead and install it. It will be available in all the IDs. Now this particular thing is only required when for your development activities, but when you are running this particular application directly using the command line, that particular thing will compile and the particular jar file will be created. So it will work directly in your production servers as well. So there shouldn't be any worry about it. Now let's implement Lombok in our entities. So let's go to the department entity over here. Let's remove everything, all the getter setters, all the constructors, toString method, everything. Okay, simple. We have 4 fields over here, that is department ID, department name, address, and department code over here. Now to make this particular department to use Lombok, I just need to add @data. You can see that it is from the Lombok. So if you just add data over here, and if you open this annotation here, you can see that this particular data is equivalent to @getters, setters, required args constructor, toString, and equals and hash code. So all these particular methods will be created for us. So we don't have to add any getter setters and everything. And if you just want any getter setters, then you can just go ahead and use getters and setter. Okay, if you don't want setter, just remove it. Just the getters will be available. But for this particular entity, that is department, we need everything. So I'll just annotate with @data over here. Alongside all the getter setters, hash code, equals method, and toString methods, I want a default constructor as well, that is no args constructor. So there will be default constructor created with this. And if I add all args constructor, the constructor will be created with all the arguments. Now if I add @builder over here, okay, you can see with this particular builder, an entire builder pattern will be implemented for this particular department service. Now if you don't know what is builder pattern, that's fine, you don't have to worry about it for now, but just understand that if you want to implement this builder pattern with this particular @builder annotation, you can do it. In the later part of the video, I'll show you how we are using this particular builder pattern, so stay around for that. But we can add this particular annotation, so it will start working. Now if we run this application again, everything should work smoothly. No compilation error or nothing should be happening. So here you can see that our application has started successfully. And if we go around to save the data, we should be able to save. And if you go to the get department, we should be able to get the data as well. So everything is working smoothly. We just removed all the boilerplate code that we was available in our application. So this is a really good plugin that you should be using in your applications. So let's talk about the exception handling in Spring Boot. Now currently if you see our application, okay, let's take one of the example over here. We'll take the example of get department based on ID over here. If you go to the insomnia, let me save one of the department. Okay, I've saved one of the departments. If I go to get department, and if I take this, I'm getting all the departments, and if I pass one over here and if I hit send, you can see that I'm getting that particular department. But if I pass any of the ID for which that department doesn't exist, you can see that I'm getting the error over here. And here you can see that this particular error response have a lot of values over here, right? Timestamp, status, error, trace, what is the entire stack trace over here. Okay, here you can see that there's a lot of details over here, right? And you can see that what was the message, no value present, what was the path, everything. But actually I don't want all these particular details, right? I want only particular relevant details to show as an error message. So whatever we want to send the data in the UI, we can send the data, and based on that particular error message and status code, we can handle all those particular stuffs in the UI. All these particular stack trace and everything, if we are logging in the backend, that's fine. But I don't need that particular things to pass in the UI. So let's see how we can handle such type of scenarios and how we can send the data back as the error response. So what we will do over here is, currently we executed this particular API, that is get mapping fetch department by ID. So for this particular thing, let's implement the error handling. We'll be creating here custom exception over here, and we will throw that particular custom exception and we will handle it. So let me just create that. Let me just stop the server. Let me create one of the package over here. Okay, I'll create the package error over here, and I'll create one of the custom exception that I'll say department not found exception. This particular department not found exception will extends exception over here. Let me override all of the methods over here. Okay, I'll do exception with string message, exception with string and throwable with just throwable, and exception with string, throwable and suppressions. Okay, so I'm just overriding all these particular methods over here in this particular class. Okay, so we just defined one of the custom exceptions. Now we will throw this particular custom exception when there is no data present. We will say department not found. So let me go to the service layer, because that's the particular layer that we are getting the data. If you go to this fetch department by ID, right, this is the particular method that we are getting the data, and here you can see that we are directly getting this particular data. But if there is no data present, then we have to handle it over here. So let's change this particular file over here. Now here you can see that we are directly returning it. So first let's change that particular thing. Okay, this particular find by ID is returning the optional of a department. So let's first get that particular value. We'll just say optional of department over here. We'll say department, and we'll remove this particular get over here. Simple, right? We are getting the optional of department from this find by ID method. Now what we will do, we will check if this particular department, whatever we are getting from the database, is present or not. If it's present, that's fine. If it's not present, then we should throw the exception, that is department not found. So what we'll do, we'll just say over here if not of department dot is present. Okay, if department is not present, then we'll say throw new department not found exception, and we'll pass department not available. And then if you have found the department, we will just say return department dot get. Simple over here, right? Now here it is saying that we should add the exception to the method signature. So let's add this. Here you can see that it's asking us to add in the entire hierarchy as well. So we'll just add it. So here you can see that it would have added in the service as well. And if you go to the controller, let's see if it's added or not. Yeah, you can see that. So here also let's add to the method signature for now, okay, for the simplicity. But we can handle all such kind of exceptions at the controller layer, and we can throw different kind of messages based on those exceptions that we have. So what we did over here, we just added one of the exceptions over here, and we added a meaningful message over here. So let's see how it is working now. Server started. Currently, at last time when we saw that, you can see that the message was no value present. Now if I save the data and if I go back to the department and if I hit send, you can see that we still got the same error, same big stack trace and everything. But at the end, you can see that the message was department not available. So this was the message that we added. But still we don't want this. We want to clear it out, the entire response. We want to have a meaningful response. So let's go ahead and implement that as well. So what we have to do is now, whenever there is an exception occurring at the controller layer, we have to fetch that, or we have to identify that this is the exception thrown, and whenever that particular exception is that, what we have to send back the data as a response, that we have to configure over here. So what we'll do, we will create one of the class over here, and that class will be responsible for sending all the response back based on the exception that has been thrown. So for that, let's create one of the class over here. In the error only, we will say REST response entity exception handler. Okay, so this is the particular class that will handle all the particular exceptions that we want to send back as a response entity, and this particular class will extend response entity exception handler. Now whatever the class that you are creating to handle all your exceptions, okay, that particular class should be annotated with @controller advice. Now this particular controller advice, currently we are adding for all the controllers that we have, but if you want to add this particular controller advice for a specific controller or a specific base package, that also we can do. So for those particular controllers and for those particular base package only, this particular advice will run when there is an exception occurred on all those particular controllers. So currently what we did, whenever there is an exception in my controller and that particular exception has been thrown, this particular controller advice, this particular exception handler will handle those kind of exception, and it will create a response for that particular exception, and it will send back as the response object. So here we define that this particular class will be the controller advice, and we'll also define this particular class will send the response status. Okay, now we have to create one method, and that method will be responsible to handle that particular kind of exception. So currently we created department not found exception. So we will create a method that will handle that particular exception itself, and whenever that particular exception has been thrown, what we want to send back as a response, that we will give over here. So let's create the method over here. We'll say public what I want to send over here. Okay, so let me just create one of the entity class or Pojo class, whatever you want to tell. Okay, so I'll just say error message over here. This is the class that I'm going to create, and I'll say department not found exception is the method name. Let me just create this particular class over here. First I'll go to the entity and I'll create this particular class. Now this particular class we will be sending back. So what data I want to send back, that I want to define over here. So I want to send HTTP status over here. First, what is the status? 200, 500, 404, whatever. So that I want to send, and the other thing that I want to send is the error message. Okay, these two things. Now this particular class should have data setters and two string methods and everything. So let me annotate with @data using Lombok. I'll create the no argument constructor and also create the all argument constructor over here. So simple over here. We created a Pojo class over here, okay, with two of the properties. And this particular, let me just import the package. Now this particular method will take department not found exception as the input parameter, plus it will take web request as the input parameter, and we have to annotate this particular method with exception handler. So we'll just define exception handler and what type of exception this particular method is handling. So we'll say this is handling department not found exception dot class. So now it's pretty much clear over here that this particular method is handling this exception and it is taking department not found exception as the input parameter plus web request as the input parameter. Now we can create that particular error message as the response and we can send back. So let's do that. So we'll just say error message. And one more thing to note over here is that this particular error message we need to send as the response entity. So I'll just wrap around this particular error message as the response entity. Here I'll define error message equals to new error message, and this particular error message I'll give http status dot not found, that is 404. okay, plus I'll pass the message I'll get from the department not found exception dot, okay, this is the exception over here, this is the name of the variable, so exception dot get message. Okay, so we created the class over here. Now we need to return this. So we'll say return response entity dot status equals to http status dot not found dot body equals to, in the body I'll pass the message over here. Simple thing that I've done over here. It's nothing too complex over here. We created the method. That particular method is handling department not found exception over here. It's taking department not found exception as the input parameter plus the request as the input parameter. We are not doing anything with the request for now, but in case if we need anything from the request, we took over here. We created this error message object over here, and in this particular error message we are passing http status not found and whatever the message it is, and we are returning this particular message wrapping around in the response entity. Simple over here. Now everything should work over here. Whenever the request comes to this particular department controller, and this particular department controller will throw that department not found exception, it will come around to this particular REST response entity exception handler. Because we added the controller advice, this particular controller will return the message as the response status, and this is the particular method that will handle that particular exception. If we have multiple exceptions, we can create the different methods for those particular types of different exceptions, and we can also use the same particular method for different kind of exceptions as well. So let's run this. Okay, here you can see that my application has started. Let's go to Insomnia, and earlier this was the error message that we were getting. Okay, now let's click on send and let's see what's happening. And here you can see that the entire error message is changed. Earlier it was having 500 internal server error, but that's not internal server error, that's data not found, right? So we just gave 404. You can give any of the status according to the requirement over here. So we give 404 over here, and we give the status as well, that not found, and the message as well, department not available. So this is how we can handle exceptions in Spring Boot for all our REST APIs. So now let's do one thing over here. Currently we are storing all our data in the H2 in-memory database. So by now I'm hoping that you are able to understand the entire flow of all the REST APIs that we have created, and you have gone through all the particular codes that we have created till now, and you are well versed with everything that is done. Now let's go up the notch and let's use the actual database. So currently what we'll be doing is we will convert our H2 database to use the MySQL database. So for that, what you have to do is you have to go and install the MySQL database in your machine. If you Google around also MySQL database download, you can just download that particular database. Just go to the MySQL downloads over here. Just download the particular database and install in your machine. I have installed MySQL Workbench over here. Just search for that as well, okay? If you search for MySQL Workbench, just download this particular thing in your machine and install it. I'll show you. Okay, I'm using MySQL Workbench. So let me just open this particular thing. You can use any of the database that you want, but we will go ahead with the MySQL over here. And this is the interface over here. You can log in over here. My database is working on port 3306. Okay, over here, and you can see that these are the default schemas available, default database available in my server. Now what we'll be doing is we need to change the entire properties, entire configuration. So if I go to the application.properties file, here you can see that these are the configurations that we have added for our H2 in-memory database. So that is database URL, username, password, and all those things. So we need to change it to use MySQL. So let's add the configuration. I will keep this particular configuration for you guys and I'll comment it so you can refer it. I'll add the new configurations over here. Okay. So let me just comment it out over here. Okay, and let me grab the new configurations. Here you can see that I just added the configuration over here, that is spring data source.url, the same over here that we have used. And instead of H2 in-memory database, I just added jdbc colon mysql colon / localhost colon 3306 / dcb app over here. Currently I don't have dcb app schema created, but we will create it. Okay, and my username is root, password is admin over here. And I changed the driver class name to use MySQL driver over here. And I just added jpa.showSQL equals to true. So whenever any of the query is executed, the query will be printed in the logs. So I just added that. If you don't add, the queries will not be printed over here. And here spring.jpa.hibernate.ddl auto update I have added. So whenever there is an update in the entities in our application, that particular entities will be updated in the database as well. So this is the configuration that I have added over here. The other thing that we have to do over here is to add the MySQL driver in our application. So earlier, if you have remembered, we added the H2 driver. If you go to the form.xml file, if you scroll up over here, you can see that we added the H2 database over here. Now we need to add the MySQL. So let me grab that and add it. I am adding it over here after H2 only, so it's more visible. Here you can see that I just added MySQL connector for Java. And group ID is MySQL. Let me just refresh my Maven changes. This is the one change that we did. The other change we did is in the properties file that we added this particular configuration and we commented out this H2 configuration now. That's it. No other change. Now the application will work on MySQL. The other thing that we have to do is we have to create this particular schema, right? So let's grab this name. Let's go to the MySQL workbench and let's create the new schema. I'll just do create schema. I'll give this particular name. And I'll do apply the changes. And here you can see that this particular DCB app schema is created. There is no tables available, nothing available. Okay. Now let's go to the application and let's start our application. You can see that application is started. Now if I come here and if I refresh my database, here you can see that my department table is created and Hibernate sequence is also created over here, as we already added generate auto sequence, okay, in our entity. And you can see that there is no data available in my database. Now let's go to the Insomnia and let's save any of the departments over here. I'm saying IT department over here, IT Ahmedabad IT06. Let's save it. And if I come over here, you can see that that particular data is saved to my MySQL database over here. So pretty cool, right? We just added a few of the configurations and my entire database has been changed now. So let me add a couple of more data over here. I'll do CE 07. I'll just add EEE. Electrical department is in Bangalore. EEE 01. You can see that 3 records I have created over here. If I do get over here, I'll be getting all the data. And if I go to the MySQL database and if I run this particular query, you can see that we are getting all the records over here. Now all our operations will work on this particular table. So that's how you'll be able to change your database as well. So do change this particular database, and if you are familiar with any of the other database also, try to use that particular database and add the configuration accordingly. The only thing that you have to take care in mind is whatever database that you are using, you have to use that particular driver for it and that particular driver name that you have to give in your application.properties file. So that's it. Now let's talk about the unit testing over here. Okay, every application should have or should do unit testing for that particular applications or for all the functionalities that we have. So here we will understand that what unit testing we have to do and how we can do all the unit testings. Unit testing you can do for your entire application. That's an integration testing that we call, that you will be testing your entire end-to-end flow. So whenever you hit any of the endpoint, how that particular endpoint is behaving, that you can test entirely. Okay, the other thing is you have to test all your different components as well. So suppose currently we have a repository layer, we have service layer, we have controller layer. So you can test all those 3 layers differently as well, or you can test all the 3 layers at the same time using the integration test as well. So here what we'll be doing is we will be testing all the 3 layers, that is repository layer, service layer and controller layer. So for this we'll be using the JUnit 5 over here and Mockit over here. So these are the 2 libraries that has been added to our Spring Boot application by default. So in the earlier starting of this particular tutorial, we saw that it was added the Spring Boot starter test dependencies over here in the pom.xml file. Let me just grab it again for you guys. Here you can see that this particular dependency was added, Spring Boot starter test. This particular test dependency have JUnit Jupyter, that is JUnit 5 and also Mockit over here. Okay, so we will be using this particular Mockito and JUnit to test all our components that we have created. Now let's understand the concept of mocking in unit testing. So wherever you see, you will be seeing that all the beans or all the different data will be mocked for doing the unit testing over here. Why mocking and why we have to do that? Okay, so consider you are testing the controller layer over here, right? So from that particular controller layer, you will be calling the service layer as well. So you'll be calling few of the methods for service layer as well. Now you are just testing the controller layer, not the service layer. Okay, so you are not considered about how the data has been flowed, how the service layer has been working also. You just want to test your controller layer, but your controller is still dependent on the functionalities or the methods available in the service layer. So what you can do is you can mock those particular things. You can just tell the system like, okay, whenever there is a call to this particular method or particular service layer, give me this thing directly. Okay, don't go to that particular service layer. So this is called a mocking. So you're just mocking the functionality available in that particular service layer. Let's take the example of a service layer. And in this particular service layer, you can see that there is a fetch department list method available and which is sending the direct list over here. But I don't care about how service layer is working, okay, how service layer is getting me the data. I just want to test my controller layer. So whenever there is a call to this particular service layer for this particular method, I will just say that, okay, whenever there is a call to this particular service layer and this particular method, give me this object. Simple as it. So it applies for the other things as well. If you are working with the service layer and from that particular service layer, there is a repository layer call over here. Okay, so it's interacting with the database, but you don't want that. You're just considering to test your service layer. So for that repository layer also, you will be mocking all the data. So for that particular layer, you are not testing anything. And the same thing happens for your repository layer as well. When you are using your repository layer, ideally you don't want to save the data. You just want to mock that you saved the data. Okay, or you are getting the data from the database. Now let's implement unit testing in our application. So if you see over here, if you go to the project structure over here, and if you go down over here, you can see that we have a test folder and we have the same package information over here. Okay, that's the same package information that has been added for all our particular classes, for our main classes. Okay, and if you go over here, there's already one test case created, that is Spring Boot test, and for loading the context over here. We don't want it for now, so I'll just remove it because we'll be implementing our own test cases. So let's just remove it for now and let's focus on our own test cases. So now we will start with our service layer first. Okay, we'll go with the service layer, then we'll go with the repository layer, and then we'll go with the controller layer. Okay, and for everything we'll be doing the mocking over here. So the simplest way to create the test case file will be for each of the layers that we have. So for the department service, what we can do is just go to this particular department service, go to generate, and here you can see that you can create the test class over here from here itself. If you create the test class, you will get the lot of different options like which particular test class you want to create. You can create for everything over here, or you can create for particular as well. And here you can see that it will be creating a class department service test in the same package itself over here. And here it's telling that you can use any of these particular generator methods as well also over here. Now you can also go ahead and create the package in your test folder and you can create the class directly itself. But if you are using the IDE, we should use the IDE to do all our stuff. So let's just create from here as well. If you're using IntelliJ IDEA, you can create from here. And if you are using STS also, there is an option to create the test case from your main classes. So you can go with that as well. So let me just use this particular generate function and create the setup method. And that's it. We will create our other methods by our own. So let's go ahead and click on OK. And here you can see that department service test class is created. And if you go over here in the test package over here, you can see that this particular service package was created and new file was created inside that particular service package. Now to tell the Spring Boot that this is a particular test class, okay, we need to annotate with using Spring Boot test over here. So now Spring Boot will know that this is a particular test class and we can add all the things over here. Now here what we'll be doing is let's go to the service class and we will implement this particular test case over here for this particular method, that is fetch department by name. So whenever we'll try to call any of the department over here, we should return the department by its name, whatever that we are providing over here. So let's implement it. We'll go to this particular class over here and let's create one method for test case. So I'll say public void, and always try to give the name of your test case methods very unique. So from that method name only you will be able to identify what this particular test case is doing. Okay, though it's a long name, that's fine. Okay, so I'll say when valid department name, then department should found. It's a pretty long name, right? But that's fine. From here we'll be able to identify what this particular test case is doing. Now in this particular method we need to find the name of the department and we need to call that method as well from the department service. Okay, so we have to use the department service, so we need to auto wire that particular class. So we'll just use private department service over here and we will use auto wire, and whatever the method that we create we should annotate with @test. So this will be used as the test function over here. Now let me just define string department name equals to IT. Here I'll define, okay, department found equals to, we need to call department service over here, department service dot fetch department by name over here, and in this particular fetch department by name we need to pass department name. So this is a particular call that we created. What we have to do is we have to validate against it. Okay, like whatever the name that I'm passing, okay, and whatever the object that I'm getting back, because this fetch department by name is returning the department object and it's saved in the found. So that particular department name in this particular found and this particular department name, if both are equal, then my test case is valid. So I'll just say assert equals, okay, and here assert equals will take two parameters. Okay, first I'll pass department name and second I'll pass found dot get department name. Now this particular assert equals will match. If both are equal, then my test case is passed. If both are not equal, my test case is not passed. The other thing we need to always take care is we need to write the test cases for all the scenarios, all the positive scenarios, all the negative scenarios as well. Then only our entire code coverage will be completed. Now this is just the happy scenario that I'm doing, but we can always go with the negative scenario, like when invalid department name, then department should not return. So in those type of cases we should use assert not equals or assert throws. Okay, so these are the different methods available. You can just check it out and we can validate against the data that we are sending back. Now the other thing we have to take care of is, if you go with this particular fetch department by name, this particular service is calling again the repository layer, right? So we already talked about, like, we just want to test our service layer. We are not considering about how that repository layer is working. So for this particular thing we need to mock it. So let's mock that particular layer. If you go to this particular fetch department by name, let's go to the implementation for it, and this particular fetch department by name is calling department repository and find by department name ignore case method over here. Okay, so we need to mock this over here. So let's go to our test class and let's mock it. Now if you see this particular setup method that we already added, right, and here you can see that there's an annotation before each. What it will do is this particular method will be called for each and every test case added to this particular class. So whenever we run this particular method over here, for that particular method this particular setup function will be called upon. There is another annotation that is before all. This particular, if you add this particular annotation to any of the class, that particular function will call before executing each and every test cases once. So if you have 5 test cases, for this particular class, only one time that particular method will be called for executing all those particular 5 test cases. Before each will be called for each and every test cases. For if you have 5 test cases, for 5 times this particular method will be called. And there are also different annotations like after all and after each. Those type of annotations will is used to clear it out all the data that we have already created. So you can use all those particular things as well over here. So let me just use before each function over here. Now I need to mock it over here. Okay, so let's mock the data. Now what we are mocking, department repository. So we need to create the object of it, private department repository, and we'll use mock bean over here. Okay, from the mockito. So this particular bean will be mocked. Now we need to tell this is mocked. Now when you call this particular method, what you want. So let's do that particular configuration. So first of all, what I need the department object that I want to return. So let's create that department object first. Department equals to. Now here I can create the object using the constructor as well, or I can use the getter setters also to set all the values in my department. But in the starting of the video, when we were using the lombok, when we were implementing the lombok, at that time what we did, we added the @builder annotation to our department class. Not this one. If you go to the entity, you can see that we added the builder annotation over here. So that means this is providing the builder pattern. So what is builder pattern? Builder pattern is used when you have multiple properties available and you want to use the different sets of properties always to create the object. Suppose if you are creating the department object and if you have 10 properties, then with the help of 2 properties also you can create the object. With the help of 5 properties also you can create the object. So it's not defined, and based on that particular thing you can create the object. Now if you go with the simple approach to create the object using the constructor, then if you have 10 arguments, you have to pass all the 10 arguments. Or else what you have to do is you have to create the different constructor, lot of different constructor for all the different arguments available. Okay, that's really boring and really tedious. Not everyone likes that. You should not do that. So it's a builder pattern. Whatever data you want, pass the data, and for that particular thing, that a particular object will be created. So we'll be using this over here. Okay, so we'll just get the demonstration also how we can use the builder pattern as well to create our objects. You can use any approach. So let's go to our test class again, and here I'll say department dot builder dot. Now we can set all the values over here. You can see that department name, department code, department ID, department address. So let's set all the values. I'll say department name as IT dot department address as Ahmedabad dot department code as IT06 dot department ID as 1L, one long value, dot build. So this particular object will be built. You can see that it is much neater to create the object this way, right? Now the main thing, when you call this particular fetch department by name from the repository layer, from the service layer to that particular repository layer, you need to pass this particular object over here. So what we'll do, we'll just say mockito dot when, means when you call department repository dot find department name ignore case. So when this particular method has been called, so it's IT over here, I'm defining that I want data for IT dot then return department. It's simple. So whenever you call this particular method, I want this particular department as the value back. Simple as it is. Okay, and here you can see that when this particular method will be called, for this particular method this setup will be called before that. So this particular mock bean and the mock method will be always available for calling over here. So now let's test this out. So if you run this over here, you can see that this particular test case is passed successfully. So this is the one thing that we did over here for our service layer test. So you can add all the different methods available over here. You can test everything over here. Now a couple of more things over here that I want to share is, if you see this is the particular name of your test case that has been shown over here, and it's the name of your method. It's nothing wrong with it. Okay, now you want to add something better for understanding when the report is created for your unit testing, you want some better name over here. Okay, so for that what you can do, you can add the display name over here annotation. Okay, this is the display name annotation, and in this you can pass get data based on valid department name, something you can give which is valid over here, and when there is a report generated with that particular name you can identify what's happening. Let's run this again and let's see what's happening. And here you can see that this particular test case is running, but if you can see the name over here, it's get data based on valid department name, so it's more readable when the report is generated. Now suppose you have multiple test cases available and you want to disable any test case. Okay, then with @disabled annotation you can disable that particular annotation over here. So this particular test case is disabled. So when the entire application, when entire test suite is running, this particular annotation with this particular method will be skipped. So this is all about the unit testing for your service layer. Now let's go ahead and do for the repository layer. Now testing the repository layer is little bit tricky over here, right? Because it's your database. You don't want to store any junk data while you are testing anything, right? That's the one thing over here, and that's very important thing. What we can get over here in Spring Boot is you can use @data test annotation for testing our repository layer. What it does is it will, whenever you are trying to persist any data in the database, that particular data will persist into database at the time of that particular execution, and when that particular method is completed, that data will be flushed out. So that's the one advantage that we are getting when you are using the @GPA test over here. The other thing that I have seen is, or the other thing that you can implement is, you can run that entire unit testing in the different database itself, a testing database that you can create. Either you can go with the in-memory database for testing that particular thing, or you can go with the containerized database. That's all the advanced topic over here, but let's focus on how we can do the testing for the repository layer with @data test over here. Okay, currently whatever we do over here, that will be persisted for the execution of that particular method, and after that particular execution of that method, that particular things will be deleted. So we'll check in our database also what's happening. We will try to add some data or try to get some data, and that particular data will be deleted. So let's do that. Let's create the test for the repository layer. The same way we did the last time, we'll go to the repository, department repository, and we will try to create the test over here. We'll use the setup method, and that's it. And here you can see that in the test folder over here, new repository package is created and your file is created. And this particular department repository test, we will annotate with data test over here. So a couple of things we'll be needing over here. As we are doing the test for the department repository, we need the object for it. So we'll just do private department repository, and we'll auto wire it. And the other thing we need is the entity manager. If you're using the entity manager, that's the default entity manager, that will still save and process the data. So there is a test entity manager available for the JUnit and Mockito. So we will use that. So we'll just say private test entity manager over here, and we will auto wire the same. So yeah, you can see that this particular test entity manager is part of JPA itself. Now in this particular example, what we will implement is find by ID. So currently if you go to the repository layer or in the JPA repository itself, there is a find by ID method available to get the data based on the ID itself. So we have to implement that. So let's go ahead and implement that. Now this particular layer, whatever the data that we have, that might not be having in the database. So we need to store that particular data. So let's do that. In the setup function, what we'll do, we'll create the department object. Department equals to department dot builder dot department name. I'll say complete new department. Let's say mechanical engineering department. Okay. Dot department code, I'll say mechanical engineering 011 dot department address, I'll say Delhi dot build over here. So this is the object that I want to persist. So what I'll do, we have entity manager, right? So we'll just use entity manager dot persist, and I'll pass department over here. So this particular data will be persist before I call my actual test case over here. So let's create the test case over here. So I'll just define public void when find by id, then return department over here, and I'll annotate with @test over here, so this will be in the radar. Now I'll say department equals to department repository dot find by id 1l dot get, simple over here, and we will do assert equals department dot get department name should be equals to this one, mechanical engineering. So this is a simple thing over here, and if you go to the database, you have 3 records available, that is IT, CE and EEE over here. And here what we defined before each function means before calling each of the test case, we are saving that particular data into the database. It's mock, okay, and we are persisting it. So whenever the execution is completed, this data will be deleted. So let's run this test case. So here you can see that execution is completed, the test case is successful, and if you go and see the database, there is no new records available. You can see that we were able to test our repository layer without doing any changes to our database itself. So this is the basic approach to test our repository layer, but ideally I have seen many things like creating or running the entire unit testing for your repository layers while connected to the database in the entire different database, or running your test database in the different container, run it, do the testing, delete it. There are a lot of different approaches available. You can just go through the internet, you will find a lot of different approaches to do this kind of testing, and you can implement what is more feasible in your application. But ideally this is how you should be doing your unit testing for your repository layer. Now this is done. Now let's go ahead and implement the unit testing for our controller layer. Let's create the test class for our controller layer. Let's go to the controller. This is our department controller, and let's create the test class for this. I want this particular to be created for save department and fetch department by id. Okay, let's do for these 2 things over here. Click on OK, and you can see that this particular 2 test cases are, the 2 particular methods are already been added. We just have to do implementation over here. Now to test the controller layer is little bit different. The controller layer is been called when you hit any of the endpoints. So for here also we have to hit our endpoints, and we will see how that particular endpoint is behaving. So for that we'll be using the web mock MVC. So let's go ahead and do that. Instead of doing the annotation like Spring Boot test or data JPA test, those were specific to what it was doing, we added according to the need. Here this is our controller, so we need to test our endpoints, so we need to create the context itself. Okay, so we can do @web MVC test, and I want to test my department controller, so I'll just define it over here. So for this particular class only my mock context will be created and we can use it. Now as we are using the endpoint, we have to use the web MVC over here, right? We are using the web MVC. We need to mock that particular MVC. So what we can do, private mock MVC, and here we will do @autowired over here. Now the other thing that we did in the service layer itself, like mocking the bean. So from the service layer we were calling the repository layer, so that particular repository layer we mocked it. So from the controller layer we are calling the service layer, so we need to mock service layer. So let's do private department service, and we will use mock bean. Now let's create one of the department object as well. I just want private department object as well. So this particular department object I will create from here. So let me just do department equals to department.builder dot department address as Ahmedabad dot department code as IT06 dot department name as IT and dot department ID as 1L, that is department ID as 1, and dot build over here. So this is the object that I have created. Now I will be using this particular object in my test cases over here. So let's go ahead and implement that. So we'll first implement the save department test over here. Now for this particular save department, I'll be calling the save department method of a service layer. Okay, so for that we need to use the mock bin over here. Okay, we need to mock it and we need to call that particular method. Like whenever there is an input for this, I want output for this. So if you go to this service layer itself, and for the save method, here you can see that for the save method, it's taking entire department as the input parameter and entire department as the output parameter. So we need to do that as well. So let's go to the department controller test, and here we need to do that. So I just created the output object. Okay, this will be the output. So let me just create the input also. So let me just copy paste it, and here I'll say department input department, and for the input department we won't be having the department ID. So this is my general object over here. Now we need to mock it. So I'll just say mockito dot when there is a call for department service dot save department, this particular save department will take input, this one input department dot then return department over here. So this department is this particular department that we created, which will be persisted data. Okay, when the data is persisted, we'll be having this department ID added. So you can see that that's the difference over here in my input department and output department. Now we need to call the endpoint over here. Okay, so what we'll be doing is we have to do mock MVC dot perform action. So what I want to perform is the post request. So for that, what I need to do is mock MVC request builders dot post method over here. Okay, and inside this post I need to pass my URL. Dot content type would be media type dot application dot JSON dot content. Now this particular content would be your JSON data. So let me just add that data. I'll go to the postman. I have to update this data. So let me just go ahead and first of all update the data over here. Ahmedabad IT06 and IT over here. So let me just copy it and paste it over here, and after that and expect what I'm expecting out of it. Okay, I'm expecting mock MVC result matchers dot status dot is okay. So I should be getting the 200 okay result over here. Okay, and here you can see that I need to add the exception to method signature. Let's add it, and this is done. Now here you can see that this particular mock MVC, whatever the operation that you want to perform, it's correct. Whatever I'm adding over here, I need to pass the post URL as well. So my URL is, let me go to the department controller, and my URL is /departments over here. Okay, so let me add /departments over here. So this is the final method. Now couple of more things that we can clear it out over here. You can see that the name of this particular static classes are too big over here. Okay, so let's do the static import for this, so it's more cleaner. Okay, so I'll just do Alt or enter over here, and here you can see that's add on demand static import for this, lot more cleaner. Okay, let's do for this as well. You can see that it's a lot more cleaner over here. So this is the particular method that has been created. Now let's test this out. Okay, what it will do, it will try to hit this /department service, and whatever the data it is, input parameter, this is the one, and output it is testing that all the requests is okay over here. And whenever there is a call for this particular department service dot save department, this is the mock that we have done over here. So let's run this. And here you can see that save department is successful. No extra data has been saved. Everything is mock. Now let's implement the another method as well, that is fetch department by ID. So for this also, what we'll be doing is we'll be using the mockito dot when, and we'll say department service dot fetch department by ID. Here I'll pass 1L dot then return, then run department object over here. Okay, and add exception to the method signature. Okay, simple. Now here we need to perform the get operation. So here we did the post operation, here we'll do get operation. So we'll just say mock mvc dot perform. We can do get, we pass the URL over here, and URL would be the same. Let me copy paste it. /1 I'll be passing, okay, because the return object is this one and the department ID is 1. So I want this particular object back. Dot content type would be media type dot application JSON dot and expect status dot is okay over here. And let's do one more thing, and expect, and here let's check the JSON values as well. So whatever the JSON data it is should match with the data that we have over here. Same thing over here. Okay, it's simple. I'm just giving you the idea so how you can do the testing as well. Okay, how you can match all these values. So whatever the JSON data it would be, I'll say dollar dot the name of the value. So if I go to the department entity, I'll match with the department name I have. So let me copy paste it, go to controller, which should be dollar. Okay, dot value to department dot get department name. Okay, simple. I'm matching that. It should be okay result, and the department name that I'm getting should match with the JSON's department name. Okay, so let me run this again, and here you can see that it's successful. Okay, so you can see that we were able to implement the unit test cases for all the different layers, and we also saw how we can add the unit testing for the different layers based on the different functionalities, how to handle the controller layer, how to handle the service layer, and how to do the repository layer as well. Now let's see how to add the configurations in your configuration property files and how we can use that in our application. So suppose considering any of the data that you want to add in your configuration files, okay, for any reasons, add that in your configuration files and how we can use it. So let's go to the property files over here. You can see that we are adding all those particular configurations over here. So how Spring Boot is using all this configuration from this particular configuration files, and suppose if you want to add your own configuration, how we can use it. So let's check how we can do it over here. Okay, so let's see, I added any of the key value pair. So I'll just say sum.config, and let's give the value as some configuration data. So this is just a key value pair that I've added, and I want to use this in our application. So let's use it. Let's do it simple over here. So we had a hello controller over here. Okay, and from here we were passing this particular message over here. Okay, this was hard coded. So let's take this particular message and put it in this particular file over here, and I'll just say welcome dot message over here. Simple thing that I'm doing. So whenever you want to change this particular welcome message, you don't have to change the code, just change the property file and you're good to go. So this kind of configuration generally we should be adding. Now let's go to the controller layer, hello controller, and I want to send it back from here. So what we can do is, let's create one of the property, private string welcome message over here, and I want to use that particular property from that particular configuration file. So I can use @value over here, and in this particular value annotation I need to pass that particular. So let me just copy this value from here, that is welcome message over here. Okay, and if I go to this controller, I can give using dollar braces and welcome.message over here. So this particular value will be fetched from the application.property file and will be attached to this particular variable, and we can pass this variable return welcome message. So you can see that we removed the hard-coded value and we added in the property file. So we can directly get the values from there. So you can see that it's very easy. Now we are directly getting this value as we added in the application.property file. That's the default file available. If you are adding the values in the different files, then you can add the property source values over here, like from which particular property resources you want to fetch that particular values. That also you can define using the @properties resource annotations over here. So let's run this application and see how it's behaving. Okay, let me run this and we'll call this particular API. Let's run this application and we'll call this particular endpoint. That's the default endpoint over here. Okay, you can see that application is started. Let's go to the browser. Let's hit localhost 8082 slash. Here you can see that we are getting welcome to daily code buffer. This value we are getting from the application.property files. Okay, so this way you can add any of the configuration values in your properties file, and using the value you can get all the values back. Now Spring Boot has a support for YAML configuration file as well. So currently you see that we added all the properties in our application.properties file. That's the properties file defaultly added or defaultly created from the Spring Boot application. There is a YAML file also created, either application.yaml file or application.yml file, and in that also all the configurations that you can add. That's a default supported by Spring Boot application. Now why we need a YAML file? Why we should be opting for a YAML file? The first thing is YAML file is a more human readable format, and the other thing is it reduces the duplicate values over here. So currently you see that the database values that we have provided over here, that is spring.datasource.url, spring.datasource.username. You can see that half of the part of this particular key is been repeated. So that is not a good way to do our configurations. What YAML provides us is a human readable format where we can remove the redundant part and we can give the configuration in a proper indented format. So we'll see how we can do that, but I can say that it's a really good format and it's widely adopted as well. So if you see any of the other technologies as well, most of the technologies will be using the YAML configuration itself. Either you go for Docker, Kubernetes, OpenShift, or the AWS configurations, anything. If you see currently, YAML is the way to go. So I prefer YAML, and that's why I have included this particular topic, that how we can go ahead with the YAML configuration in Spring Boot and how we can create or how we can change our current configuration also to Spring Boot. So let's see that. So what we can do over here is, at the same point where our application.properties were created, here we can create our application.yaml file. Before that, there are different plugins available to convert your properties file to your YAML configuration as well. There are plugins available in IntelliJ IDEA also, Eclipse also, in VS Code also. So if you want to convert, you can use that as well. There are different online tools available where you give your properties and it will convert that to your YAML configuration. So you can choose any of the one, whichever is comfortable for you, you can choose. Here I'll show you how we create it. Okay, so let me just create the application.yml file. I'll create a new file and I'll say application.yml. You can use YAML as an extension or YML extension, whatever you like. So currently if you see, to give the server port over here, it's like server.port equals to 8082. But in the application.yml file, you can give server colon port colon 8082. So this is the configuration, and the indentation is very important over here. So it has to be the correct indentation. Okay, now let's go ahead and copy paste this entire configuration. Let's go to any of the online tool available. We'll say properties to YAML. Let's use any of the tool. Let's add my properties, convert, and this is my YAML configuration. Let's copy paste and add it over here. Okay, and let me comment everything over here. We are not using the application.properties file now. Commented everything. We'll be using application.yaml. Here you can see that it's much more readable. Here we can identify server.port, and from here you can see that there is no redundant text available. Okay, this is spring.datasource.driver class name, spring.datasource.password, spring.datasource.url, spring.datasource.username. The indentation is very important, and for here spring.jpa.hibernate, .ddl auto, spring.jpa.showsql, and this is the welcome message, whatever we added over here. So this way we can add the configuration in YML file. And so let's run this. Okay, so let me run the application. Here you can see that my application is started. Okay, now it will be getting the data from this application.yml file. If I go ahead and hit this particular URL, you can see that everything is working the same way. Now let's see what is profile in Spring Boot. Now consider we have application, like consider this application, okay? This is a application where we are saving the department. So it's a department service that we created. Now this application has to be executed or has to be deployed in our dev server, QA server, stage server, production server for all the different environments. So for all those particular different environments, we will be using the different configuration properties. Let's take the example of the database only. So we'll be having the different database. So the database configuration properties that we added over here has to be different for all the environments. So how we can achieve that in Spring? Using the profiles over here. So what we'll do, we'll create the different profiles for our dev, QA, prod servers, and we will add the different configurations for it. And when we deploy our application, we will give Spring that deploy my application using this particular profile. Let's create the profiles in Spring over here. So now as we have created the YAML configuration, we'll go ahead and create the configuration in YAML itself. Now in the YAML, what we can do, we can create the multiple documents in a single file itself. So we will be going ahead with that particular approach. Otherwise, what we can do is we can create the different configuration files for the different environment. Suppose your profile name is dev, then you can create the application-dev.yml file. If your profile name is QA, then you can create application-qa.yml. For the prod, you can create application-prod.yml file. Else, you can add all the configuration in a multi-document in a single file itself, that is application.yml file. So we'll be going ahead with that particular approach. So let's add the configuration for that. Let me create the new document. We can create new document using 3 hyphens over here. So this particular part is one document. The below part is another document. Now in this Spring, we can define Spring profiles over here. And here I'll define this particular profile is dev over here. So for my Spring dev profile, this is my database details and everything. So let me create multiple profiles over here. Okay, I'll say that this is my QA profile. And I'll say this is my prod profile over here. And I'll say my prod profile is using DCB app-prod database. My QA is using DCB app-QA database. And this is the using same database over here. Now ideally all these configurations will be different. Here also we added the database different over here. Okay. Now how to tell Spring which profile to run? So for that we need to give default active profile over here. So let's give that. So we can add Spring profiles active over here. And let's say my active profile is QA. So currently my application should be running with this profile over here. So that means I should be having this DCB app-QA database over here. But I don't have currently. Okay, I have only one database. So if I start this particular application, it will fail. Okay, let me just restart the application and it will fail. And if you see over here you can see that application failed to start. Okay, but if you go to the top in the logs, here you can see that the following profiles are active, that is QA. So my application started using the QA profile, but the database was not available, so it failed. So let's create this particular database. Okay, so I'll just create QA and prod both. So let me create schema, that is DCB app QA. And let me create the prod schema as well. Okay, so let's do this as well. Okay, now you can see that DCB app one schema, DCB app-prod and DCB-QA. So 3 database we created for 3 different profiles over here. And currently you can see that for the DCB app QA, there is nothing available, no tables available. Okay, and let's start this application. And here you can see that my application will be again started on the QA profile and application started as well. And here if you come over here, if you refresh it, you can see that the table was created in this particular database. And if I try to execute the query, you can see that there is no data available. And if I save the data, you can see that the data has been saved in this particular QA database. So my application is running for QA now. Okay, so it's running with QA profile. So we created multiple profiles and we are running with multiple profiles. But this is not how you will be deploying your applications in production, right? You will be creating your jar files and you will be deploying it. So let's see how we can do that as well. So in the earlier videos also we saw that how to run our Spring Boot application from the IDE as well and from the command as well. Now let's see how to deploy, actually how the application will be deployed in production environment. So for that we have to create our applications. Okay, we have to create our jar files. So let's go ahead and do that. Ideally we will be giving one specific versions to our application. So for that let's go to the pom.xml file, and if you go to the versions over here, you can see that my version is 0.0.1 snapshot, which is not correct. Let's say we are deploying the application with version 1 over here. Okay, so let's say we will give 1.0.0. This is the first version that we are deploying, okay, in production. So we give this version. So my jar file will be created using this particular version. So let's go to the terminal, okay, and let's create the jar file. So with the mvn clean install command, we will be creating our jar files. Clean will clean the target directory and install will create the package. There is a package goal as well that will create the package. There is a deploy goal as well that will create the package and deploy to the maven repository. So you can choose any of the goals available according to requirement. So this will execute all our test cases as well. Okay, you can see that it started executing all our test cases also. So until and unless all the test cases are executed, our build won't be generated. So that means all our unit testing is successful and we are ready to go ahead with the deployment. So here you can see that we added 4 test cases and everything is successful, and after that our build was created. And if you go inside the target directory and if you do this one here, you can see that this is my application, that is Spring Boot tutorial -1.0.0.jar over here. Now we can deploy it. We will be able to deploy this directly because as we are using Spring Boot, we don't need any servers. Embedded server is inbuilt in our particular jar file. So that entire thing will deploy to that particular embedded server. So how we will run this is using java -jar command. Okay, and after that we have to give which particular jar file that we want to run. So I want to run Spring Boot tutorial -1.0.0.jar file. And after that, for which particular profile I want to run this particular application. So I want to run for prod. Okay, so let's do that. Otherwise, if I don't pass any of the information over here, by default it will run with the QA profile, because we have given over here that my default profile is QA, active profile is QA over here. So that will run with the QA profile. But if I want to override that value, I want to run this in my production with the production profile, then I can override this value using the arguments over here. So let's pass the argument, that is spring dot profiles dot active equals to prod over here. So this is the argument that I'm passing and overriding the values over here. So let's run this. And here you can see that my application has started, and here you can see that my following profile is active prod. Okay, so my application is started with the prod profile now. And if I go over here to the MySQL database and if I go to the prod over here, you can see that the table is created for this prod. And if I see if there is any record, there are no records available. So let's add the records to this also. If I execute this save department API, this particular department is saved, and if I execute the query, you can see that I'm getting my data in prod. So this way I will be able to deploy my Spring Boot application with different profiles. So this is how you will be differentiate the different properties and different properties for the different profiles, and you can leverage this to deploy your applications in different environments. So currently if you see, we just added only database source and the welcome message over here. We can do this for all the properties over here. So just go around and explore this profile as well. Now let's see what is Spring Boot Actuator. Now whenever we deploy any of our application into any of the environment, that is production environment, we have to monitor our application, how that particular application is performing. Is the application healthy? What are the different beans created? What are the different objects created? What is the memory utilization of our application? all this we want to monitor. So Spring Boot actuator provides us this particular functionality to manage our application health and all those different matrices. So let's see how we can do it. So for this we have to add the dependency, that is Spring Boot actuator. So let's go to the pom.xml file and let's add the dependency. So this is my pom.xml file. Let's go ahead and add the dependency for actuator. We'll go to the dependency and here I'll add Spring Boot starter actuator dependency. And if you go to this particular file, what's included is, you can see that Spring Boot actuator auto configuration has been added. So all the auto configuration has been added by default and it is using micrometer core to do all the matrices over here. So after adding this dependency, we have implemented the configuration to manage our application with the default configuration. So let's see what we have defaultly configured. So let's run this application and let's see what default we have. So here you can see that our application is started. Let's go to the browser and here you can see that our application is running. So to go to the help points, actuator help points, if you go to the console logs as well, here you can see that there are two endpoints has been exposed at the path /actuator. So let's see this path. So I'll add this particular path and here you can see that there are two endpoints that is been added to here, that is health over here and info over here. So let's see that. If I open the health over here, you can see that we are getting status is up. So this particular health endpoint will give what's the status of our application, what's the health of our application. So currently the status is up, so my application is healthy. And now let's see what info is giving. Currently nothing, okay, but the endpoints are available. Now there are a lot more endpoints available that are by default disabled because it's an auto configuration done by Spring Boot. You can enable it whatever you want and you can disable it whichever you don't want. So by default Spring Boot thought, okay, these two are important, so they enabled those things. The rest of the things are disabled. Now let's see how to enable it. Okay, so let's go to the application. So now let's enable all the different endpoints over here. So for this we need to go to the application.yaml file and you can see that my default profile is QA. Let's add in the QA for now. Okay, so I'm just adding this particular configuration, that is management.endpoints.web.exposure include all. So enable all the endpoints. You can expose all the endpoints for the JMX as well. So there are two types of options available for the web and JMX. You can choose either of the one. Currently we are just going for the web just for the simplicity to see how the actuator is working, but there are a lot more things that you can do. So this has been enabled now. Okay, now let's run the application and see what all things are available. So here you can see that my application started, and if I go to this particular logs, you can see that there are 13 endpoints exposed beneath the /actuator over here. So let's go ahead and see that. So let me just refresh it, and here you can see that there are 13 endpoints available. Okay, so you can see that beans available, cache available, health, info, conditions, config properties, environment variables, loggers, head dump, thread dump, metrics, what are the scheduled tasks, mappings, everything is available. You can see all those particular values. So let's see the different values. Let's see the environments. So here you can see that these are the different environment values available. Okay, some of these values are default set by the Spring Boot auto configuration, and if you add new values, that will be added, that you all can see over here. All these particular endpoints has to be secured because no one should be able to access this endpoint, so it should be behind your Spring security. So that also you should implement. All these particular endpoints should be behind your Spring security. Currently we are not doing anything over here, so let's see all the values. So this is the environment. Let's go ahead and see the config properties. Here you can see that these are the different configuration properties added, and here you can see that it will also show from where this particular config properties has been added. So we have created the application.yaml file, and at this particular line number, this particular value has been added, that is show SQL. Here you can see that exposure endpoint, this is coming from application.yaml file from this file, and all the other values will be added by the default configurations as well. Let's see the beans as well. Here you can see that these are the different beans added to our application. Okay, Let's see if there is any cache. There is no cache manager added. Okay. Let's see the loggers. Okay, you can see that the log levels for each and everything. So there are a lot of endpoints available. You can get the thread dump as well. Okay, all these values available. Now all these values you can expose over the JMX also, and you can monitor everything using the JMX as well. So there is a Spring admin available. You can use that Spring admin to utilize all these APIs and create the entire dashboard as well. So there are a lot more things and a lot of features available within the Spring framework as well to utilize everything. So just go through the documentation and you will get a lot more idea about Spring Actuator as well. Now if you want to override any of the APIs available, that also we can do. Consider info is not providing a lot of details over here. You can add a details in the info endpoint as well. And if you want, you can create your new endpoint as well and you can expose over here. So let's see how we can do it. So let's go to the application and let's create the endpoint. So in my application, let's create the package over here that will say config, because we are adding the configuration. And let's say we are creating one of the class that is feature endpoint. So we are just creating one of the management endpoints from the actuator that will say which all the features are enabled for this particular application. So from that we can directly identify which features are there in this particular environment, which features are there in this particular environment. We can get the idea. So let's create the endpoint for that. So I'll just say feature endpoint class. I will annotate this particular class with @component. So this is in the Spring's radar now. Now to create this particular feature endpoint as the endpoint for the actuator, we have to annotate with @endpoint. Here you can see that this particular endpoint annotation is the part of Spring Boot actuate. So let's create the endpoint over here and we can pass the ID over here. ID equals to, let's say, features. Now let's create this particular functionality. What we will do, we will create one map over here that will have the data like which particular feature is enabled or disabled. So let's do that. We'll just do private final map. Map is of type string, which particular feature it is, and that particular feature details that we can add over here. Okay, so for that let's create the feature class, and for this I'll say features map. Okay, equals to new, I'll say concurrent hash map. Okay, so this particular object is created. Let's create this feature inner class. Okay, so we just created the inner class over here and let's make it static. Inside this, let's create the different properties. We can create different properties and we can show all the properties over here. For now, let's create only a single property that says it's enabled or disabled. And I'll say here private boolean is enabled. Okay, this is one property and I want getter setters for this property. So I'll just say @data using Lombok to add the getter setters. I want no arg constructor. I want all args constructor simply. Okay, so I just added all these particular things so I can add all the data in this feature map. Now let's add this particular map using the constructor. So let me just create the constructor over here, and inside this constructor what I'll do, I'll say feature map dot put and I'll say department feature. Okay, I have a department implemented, so let's say department feature is implemented, and here I'll say new feature, we'll say true. We just added is enabled field as a true. This particular feature is implemented. Okay, so now let's add multiple values. Let's say that after department we will be creating the user service as well to save the user, but currently that is not implemented. We will be adding the authentication as well, but currently that is not implemented. So we just added all these particular values. Now let's create the endpoints. So for the endpoints we need to create the method. So we will just say public and it will return the map, and this map will be of string and feature. Okay, so what we are doing is we are trying to send this particular feature map back when it calls features. Okay, we'll say return feature map. So what we are doing is we created one of the endpoint that is features, and that will send back the list of features available inside this particular application. So this is the one endpoint that we added. Now this particular features will be the get operation. Okay, so we want to read the data. So for that we need to add read operation over here. We can create the write operation also, and we can create the delete operation also. Delete operation for deleting, write operation for saving the data. Now let's create one more endpoint to get the details of that particular feature that we are selecting. So let's create that as well. We'll say public, which will return feature object, and we'll say this is a feature endpoint, and which will return feature map dot get whatever key you pass. So for that we need to take input also. So we'll just say we'll be taking input as a feature name over here, and this particular feature name we have to pass in this particular get method. Now this is also read operation. Okay, we are getting the data, but one thing where we have to add over here is that this particular feature name is a selector, so we need to select that particular value and pass over here. So for this there is a selector annotation available. So we created the two endpoints over here that are get operations to get the list of features and to get the features in our application. Now let's run this and let's see what's happening. Okay, let's run the application. And here you can see that my application started, and now here you can see that earlier there were 13 endpoints. Now you can see that there are 14 endpoints because we created the new endpoint over here. Okay, so let's go ahead and refresh my actuator over here, and here you can see that this is the features that we added new over here. So let's go to this features endpoint over here, and here you can see that these are the features that we added, right? Department feature, user feature, authentication feature, and we also told that okay, this is true, false, and these are the different attributes that we can add. Now there was also one more endpoint that we created, that is feature slash selector. So if you pass any of the feature name, that will be called. So for this particular features, if I pass department feature over here, let's select this department, and if I pass this particular department value, it will get the details of that particular department. So currently we have added only one attribute, so it's showing the one attribute, but if we have multiple, if you want to describe what this particular feature is, we can add all the details and we can show it over here. So this is how we can implement the different actuator endpoints, and we can utilize this particular functionality. Now suppose there are a lot more endpoints available, and if you want to exclude that, if you want to not expose those particular values, so let's see how we can do that. So currently if you see that there are environments and beans available that shows all the information about our application, like what are the different environments added, what are the different beans or objects created. So let's hide those things. So for that what we need to do is we will go to our application.yaml file. Let's go to the application.yaml, and these are the management endpoints that we have exposed. So here you can see that we included everything. Now we can exclude also. So here I can say exclude environment endpoint and exclude beans endpoint. I need to give in quotes. So I'm excluding these two endpoints over here. So let's run this application again. And here you can see that out of 14, only 12 endpoints are available. These two endpoints are not available. And if I go ahead and refresh my application, you won't be able to find any beans over here. Okay, or not environment as well. So this way we can disable the endpoints as well from the actuator. So this was all about the Spring Boot over here. Okay, we cover a lot of topics over here. So if you are aware about all these particular things, then you are good to go to create the production grade application. So there are a lot of different things that we covered over here. We saw the different annotations available in the Spring Boot and how we can use those particular annotations. We saw how to create the different endpoints available, and we also saw how to save all those particular data in the database. We also saw how to use multiple database as well to change the database and all those particular things. We also saw how to change the configuration using the configuration.properties files. We also saw how to do the unit testing of all our components that we created. We did controller testing, service testing, repository testing as well. We did the profiles, how to deploy our applications in different environments using the different profiles as well. We also see how different actuator endpoints are available. We also converted our properties to the YAML configuration that is widely being used. So this is a lot of things that we covered, and if you know all these things, you will be a really good Spring Boot developer, and you can always learn advanced topic going through the documentation for this. Now, if you've already gone through the Spring Boot tutorial, then it's probably like you need to understand in depth about the Spring Data JPA. Now, in that particular tutorial, we covered the brief about the Spring Data JPA and we created few of the APIs. In this tutorial, we are going to deep dive about all the topics available in Spring Data JPA. Now, what we are going to cover in this particular tutorial, we are going to cover how to map a particular class to a particular database table, how a relationship is been created using the particular one-to-one mapping, one-to-many mapping, many-to-one mapping, and many-to-many mappings. So we'll go through all the different types of mapping relationships available in JPA. We'll also understand what is JPA and why we need JPA. And we are also going to see a different annotations available that will help us to create more robust applications, like how we can add the native queries, how we can add the GPQL queries, how we can add the embedded classes in our entities. All those different things we are going to see over here. We are also going to see how we can create the unidirectional and bidirectional relationships. We are also going to see how we can add different constraints and how we can match our entity with the exact table that we have in our database. So there is a lot of things that we have to cover in this particular tutorial. So I suggest you to do practice while I'm going through the tutorial. Now, when we are working with the Java applications and we have to connect to the database, what we do is we use JDBC. So JDBC is an API provided by Java, so we can connect with the database. Now, the problem here is Java works on the concepts of objects and classes, and database works in the concepts of tables that will be having rows and columns. Now, how to match together? Now, in the traditional way, if you're using the JDBC, what we'll be doing is we will be getting the data from the database that will be in the table. We are getting all the records and we are converting them in the objects or the classes that we have. So that's the conversion that we are doing. But ideally, we should not be doing those conversions. There has to be a system where it defines that this particular class or objects represents this particular table in the database. Now, for these reasons, there are different frameworks available that gives us the functionality that is called ORM, that is Object Relationship Mapping. Now, what ORM is? ORM defines whatever the classes or objects is defined in your system, in your Java application, that will represent the table in your database. Now, the frameworks like Hibernate, iBatis provides this type of functionalities. Now, what happens is Hibernate has its own implementation of ORM, how the different functionalities, how the different sessions, objects, and how it is behaving and how it is interacting with the database is different compared to how it's in the iBatis, because iBatis will also have its own implementation. If there is any other framework, those particular frameworks will also have its own implementation. Now, when this type of different implementations are there, when we have to change any of the implementation framework, like if I want to change from Hibernate to iBatis, then it's very difficult. So whatever the specification has been used by Hibernate doesn't necessarily to be used the same in the iBatis. So what the Java people thought of, let's create the standard specification, and those standard specification will be used by all the third-party API providers or ORM providers, and whenever we have to switch between those providers, it's very easy for the application developers. So suppose Java provides a JPA specification, that's a Java persistent API specification provided by Java, and all the framework providers like Hibernate, iBatis, and all the different available will be using those specifications and creating their implementation of ORM. So what happens is, if you are using the JPA and if you want to convert from Hibernate to iBatis or from iBatis to Hibernate, then you can convert it very easily. Now, the one important thing is what Java provides is just a specification. So you have to go ahead with the implementation provider. So you cannot tell that, okay, I'm just going with the JPA. If you're going with the JPA, you must be using Hibernate or iBatis or any of the framework, the ORM provider, because JPA is just a specification and you are using that specification via any of the framework provider or any of the third-party provider ORM providers. So this way JPA specification is been implemented and the application developers implement those JPA using any of the third-party framework availables, and switching between them is very easy. So this is all about why JPA was introduced and how Hibernate and all those different framework uses JPA and how we can change whenever we need to change in our application. So now let's see what we are going to build it today. We are going to build a small relationship over here. I'll show you the example. You can see that this is the class diagram that I have prepared, and we are going to build this particular class diagram over here using the Spring Data GPA. Now, what all the things are over here? You can see that there is a student class, there is a guardian class, course, teacher, and course material over here. Now, all these different classes are represented by the tables in the database. So we are going to create the tables based on the classes that we have defined over here. Now here you can see that all these particular different classes defines a particular relationship with each other. So we are going to see what those particular relationships are and how we can define the relationship in the entity so that a particular represented tables are created in the database, and how we can store those data. So here you can see that we have a student class and we have few of the attributes available like student ID, first name, last name, email ID. This particular class have its name and have its different properties available. So that particular class, how it's represented in the database is that particular class name will be represented by the table name. Okay. And all the properties that are there like student ID, first name, last name, email ID, all those particular attributes are represented by the different columns. So there will be different columns, and for all the columns we will be inserting the records over there. All those particular records will be rows created, right? So this is just a simple representation how an object will be represented in a database table. Now this particular student will have a guardian. Who is the guardian for that particular student? So that relationship, how we want to define, we will be defining in our system. Now there is a one-to-many relationship between student and courses, because one student can opt for many courses available. Now there is a one-to-one relationship between course and course material. For every course there will be a one course material object, and without the course you cannot create the course material as well. So there is a one-to-one relationship between course material and course available. Now between teacher and courses there is a one-to-many or many-to-one relationship, you can say, because one teacher can teach multiple courses, and on the other hand you can say that multiple courses can be taught by one of the teacher. Okay, so there will be one-to-many relationship or many-to-one relationship. How you can define in the system, that will represent what you are going with, many-to-one or one-to-many. Now between student and courses, multiple student can opt for multiple courses. So it's a many-to-many relationship. Like many students will be opting for many courses. So this is just the overview of all the different classes that we are going to create and how they are related with each other. So when we create the application, we will be creating all these particular classes and we will define the relationships as well. Now let's go ahead and create one Spring Boot application where we will define the Spring Data GPA and we will connect to our database. So let's go to the Spring initializer over here. Okay, start.spring.io, and let's define the properties over here. I'll define group as com.dailycodebuffer, artifact as Spring Data GPA tutorial, name as Spring Data GPA tutorial, and package name I'll define as spring.data.gpa tutorial. Okay, so this is just a simple package name that I have defined over here. I'll be using the packaging as jar file, Java version is 11, and let's add the dependencies. As we are going with GPA, first thing we'll add is Spring Data GPA. I'll add the Lombok dependency, okay, to reduce our boilerplate code, and I'm going to use the MySQL database, so I'm going to add the MySQL diver, and let's add the Spring Web dependency as well. So suppose if you want to create the REST APIs out of it, you can create the REST APIs as well. Okay, so these are the 4 dependencies I have added over here. So let's generate the project and open in our IDE. So I'll be using IntelliJ IDEA. You can use any IDE of your preference. Okay, let me open IntelliJ IDEA. Open project and Spring Data GPA tutorial. So it's resolving the dependencies. Let's wait for a second. Okay, so this is my project over here. Let's open the pom.xml file, and here you can see that we added Spring Data GPA, Spring Starter Web, and if you go to Spring Starter Data GPA, so this particular Spring Data GPA is using Hibernate as its default implementation over here. Okay, so we are using GPA with the Hibernate implementation. Okay, if you want to change it, we can change it as well. Okay, let's go with the default for now. Okay, so this is our pom.xml file. All the details are there. Now what we have to do over here, let's open the MySQL as well. Okay, I'm using MySQL Workbench 8.0 CE. So this is our database now. Here you can see that we have only default databases available. So what we will be doing is we will be creating one of the database over here, and we will be providing all this particular configuration details in our Spring Boot application so that Spring Boot application can connect to this particular database. So let me go ahead and create the database over here. I'll just go ahead and create schema. I'll say SchoolDB over here. Apply the changes, finish, and here you can see that SchoolDB is created and there is nothing inside this particular schema. Okay. Now what we have to do is, for our Spring Boot application to connect to this particular database, we have to give the properties in our application.properties file. So let's go to the src main resources application.properties, and here we can define the configuration. Okay, so let's add those configurations. Now here you can see that I have just copy pasted the configurations over here, and this is very simple. Here you can see that I have just added spring.datasource.url, the URL of your database, the username and password of your database, okay, and which particular driver that you are using. As we have added MySQL driver and I'm using MySQL database, I have just defined that I'm using com.mysql.jdbc.driver over here, and I just defined spring.jpa.showSQL as true. So whenever we are doing any operation, all those particular queries will be printed in the logs. Now this particular thing, spring.jpa.hibernate.ddl auto, this particular thing I have defined as update. Now this particular thing defines whatever changes that you do in your application, like whatever entities and whatever classes that you define, those particular thing, how it will interact with the database, that has been defined by this DDL auto. So suppose currently if you see that I have added update, so whatever the updates I do in my entities or any of the objects that I'm creating, those updates will be applied to my database directly. So suppose what will happen is, if you have 3 fields available in your database and 3 particular available in your classes as well, and if you add 2 new, that 2 new changes will be applied to your database as well. So there are different properties available for this. Okay, you can go and check that out as well. It is advisable not to use this particular property in the production application, because generally when you are working with the production applications, there will be a different team available that will be handling your database operations, and different scripts you need to create to do all the changes regarding your database, and your application will be different. So this particular thing that I have added over here, just to make sure that whatever changes that we are doing in our application, that is directly been reflected, and you can directly see what's happening in the database when we do any changes in our entities over here. So for that purpose only I have added over here, but whenever you're going with the production, you should not use this. It's not advisable. And whatever particular database objects or database tables are there, how to create the same representative in the class, that we are going to see over here. So suppose any new constraint is been added in your database, how to add that particular constraint in your entity in Java, that we are going to see over here. So you can match all those particular things. So this is a simple configuration that has been added over here. Now let's move ahead and let's create the entities over here. Let's see how to map a class to the table. So with this particular example that you can see over here, okay, these are the different classes that we are going to create and how to map that. So let's start with the student over here. We'll create the student class and let's see how we can map that particular class to the database. So we have student class which is containing student ID, first name, last name, email ID, and the guardian details as well. So let's go ahead and create that. So I'll go to IntelliJ IDEA in the Java folder. Let me create one package over here. I'll say as entity. Inside this particular entity, let's create the class, and I will call this particular class as student. This is the class. Now to represent this particular class to a database, to make our system know that this is particular entity that you are going to create to map to the database, we have to annotate this class with @entity. And you can see that we are using javax.persistent.entity package over here. Now whatever we do in this particular student class, that will be reflected in our database. Okay. Now what we want in this particular student class, here you can see that we want student ID, first name, last name, email ID, and the guardian details. So let's go ahead and add that. So I'll say private long student ID. Okay. Private string first name, private string, last name, private string, email ID, and we need to add the guardian details as well, right? So let's add those as well. Private string, guardian name, email and mobile number. Okay, private string, guardian email, and private string, guardian mobile. Okay, so these are the different fields that I have added over here. Now we need to have the getter setters and the constructors and toString method over here. So let's use the Lombok over here. So I'll just define @data using the Lombok. So all the getter setters and toString and hash code and equal methods will be generated over here. And I need all args constructor over here, and I also need no args constructor over here. Okay, one more thing I'm adding over here is @builder to add the builder pattern for my entity class over here. Okay, so this is just a simple thing that I have created over here. Now this student is a particular class that represents the table using this entity. Now whatever the table that we are going to create will always have one primary key to define the unique identifier for all our records. Okay, so how we can create that? So this particular student ID I want to create as a primary key. So I'll define with @id over here of javax.persistent. So this particular annotation @id will define that this particular field is the primary key over here. Now let's run this application and let's see what is happening. Okay, there's a lot of changes that we are going to do, but let's see what is happening till now. Okay, if you go to the database, okay, there is nothing available over here. Okay, I'll go to the main class file over here and I'll just run this application. And here you can see that create table student. Okay, here you can see that whatever we have defined in this particular student class, okay, that particular update operation happened to our database because student table was not available. So, and in our application we have defined the student entity, so that update happened to our database. So this new table is created. And if you go ahead and check in our database, here you can see that this particular tables, we are getting one student table over here. And if you see over here, these are the columns available: student ID, email ID, first name, guardian mobile name, and last name. Okay, here you can see that whatever you defined student over here, okay, in the lowercase, it created the same table name over here. And whatever the camel casing that you have defined over here, here you can see that using the underscore as a separator, all those particular columns are defined over here. So that's a default format available when you are creating the entities and how those particular entities will be created in the table format. Now this particular table is created, right? Now, as I already told you that when you're working with the production application, you won't be using this particular functionality like DDL auto update. There will be already table created and you need to define that particular table in your entities. Now suppose the name of that particular table is TBL underscore student. How you will define that in your entity? Like this particular student entity is representing that TBL underscore student in my database, because currently if you see that whatever is defined student, the same student table is created. Okay, the column also similar way. So let's see how we can define all those particular things. Now one more thing to note over here is, as I already told you that we are using DDL auto as update. So whatever the update operations we are doing, those particular changes will be happening, and sometimes it may not change the table structure as well. So what we will be doing is, sometimes we will be deleting the table and we will be starting our application so that fresh changes will be applied, so we can see what is actually happening over here. Okay, so let's go back. Let's stop the server and now let's add few of the details. Now what I want to do is, I want to add this particular student entity into my database as a TBL student. I want to represent with underscore TBL underscore student. Okay, so I'll define this using @table annotation. Okay, And inside this table annotation, what is the name of the table? So I'll define as tbl underscore student. Now if I start this particular application, what will happen is new table will be created with the name tbl underscore student, because whatever changes are already there in the database, it will remain the same and the new updates will be added. This particular Hibernate will understand that okay, tbl underscore student is a new table that is not present in the database. So let's create it. So it will go ahead and create it. So that's why I was telling that whenever this type of things will happen, we will delete that particular table and we will start our application to apply all our changes freshly. So this is the way that we have defined the name of the table. Now how to define the columns as well. So suppose let's go ahead and I want this particular email ID as email address, not the email underscore ID. So to define that, we can use @column annotation to define the name of the column. So here I'll define that name of the column is email underscore address. So this defines that whatever the email ID is represented over here, and in the table it will be represented by email underscore address. So this way you can see that we have added the configuration for how our table should be and how our column should be. Ideally, you should define all these particular annotations and all these particular values for each and every field. So here, due to the time constraint, we won't be adding for all the particular fields. Okay. So this is how you can add those particular annotations. Now, whenever you're working with the primary keys, you will be incrementing those particular primary keys and you are going to store those particular values. So in the ideal scenarios, you will be using the sequence generator, using the sequence. Okay. So that particular sequence will be auto generated, auto incremented every time when you're going to store the particular data. So let's see how we can add those particular things. So in this particular student ID, we will be adding the sequence generator, how the sequence should be generated, and in the generated values, how we have to use those particular values. So let's see the annotation @sequence generator over here, and here we will define what is the name of this particular sequence generator and what is the name of the sequence as well. So if you're familiar with the databases, you will be having the sequences created and those particular sequence will be incremented when you want to store those particular values. And here I'll define the allocation size as well. Okay, allocation size is 1 and the name of the sequence is student underscore sequence. Define the same over here, that name of the sequence is student underscore sequence. Now we will define how to generate those particular values for the student ID. So we'll use the generated value annotation. Okay, and here we will define what is the strategy. And here we'll define strategy should be generation type dot sequence, because we are using the sequence to generate the values. And we'll define the generator, that means our sequence. So this is a simple annotation that we have added. What is the sequence generator, and in the generated value annotation, what particular strategy that you want to use. If you're using auto, if you can use identity as well, but we want a particular thing. We have a particular requirement that we want to use sequence. That's how ideally you should be doing in the production application as well. So we have defined that way, that generation type is sequence, and what sequence that I want to use, that whatever I have defined over here. Now based on the drivers that we have used, this particular sequences will be created. Now if you're using the Oracle, the sequence will be created. In the Postgres also the sequence will be created, but in the MySQL sequences are not there. So it will create one of the tables over here and it will increment the values every time when we are doing the insert operations. Now in our table, sometimes we will be having our different constraints as well. So let's define the different constraints. Suppose if you see my email ID over here, okay, this email ID, whatever I defined, should be unique for every student. Okay, like multiple students cannot have the same email ID. So I want to define a constraint for my table that this particular column should have a unique value. So let's add that particular constraint. So to add that particular constraint, we will go over here in the table annotation, whatever we have defined the name. Here you have unique constraints available. Okay, so let's use this and we will do @unique constraints, and let's define the unique constraints over here. You can add multiple unique constraints over here, so that's why it's a list over here. And here you can see that you can define the name of the unique constraint and the column name as well. I'll define this as email ID underscore unique and column name as email address. Okay, simple over here, right? Now as we are adding this particular email ID as unique, I want that particular email ID from student every time, right? So whenever we are adding the new student in the database, I want that particular email ID, because as we have added the unique constraint over here, that means that particular email ID will define that particular student. So in the columns, we can define the nullable columns and non-nullable columns as well. So this particular email ID should be non-nullable column. That means we should be getting that particular value, right? So let's define that. So in this particular column annotation for the email ID, we will define that this particular nullable should be false. That means every time we should be getting this particular value. If you are not getting this value, it will throw an exception over here. So yeah, you can see that we added a lot of things in our entities over here, right? We define the table information, unique constraint, the sequences, how the sequences should be created, how the value should be incremented, and how a column should be defined. It's a nullable column or a non-nullable column. All those things we have defined. These are the general things that will be available for your tables. Okay, so whatever is there, you can define this way over here. Now I will show you what will happen over here when we run the application. Currently you can see that we already have one student table over here, and when we start our application, as we have defined the DDL auto as update, a new table will be created. Okay, I'll show you that in a second. Here you can see that create table TBL student, whatever we defined over here. Okay, so that means a new table is created. So in our database, there is two tables, student and TBL student. So yeah, what all things happen, you can see that it created the table over here with all these particular fields. Here you can see that it altered the table and added the constraint over here, unique constraint that we have defined. Okay, and you can see that it also created the student sequence table over here, and it added the value 1. So whenever we are adding the values now in the database, that particular one will be used to insert the data, and that particular value will be incremented then. So let's go to the database and let's see what happened. SchoolDB, I'll just refresh it, and here you can see that there are two tables created. Student was already there, TBL student was created. Okay, these are the columns, and if you go to the indexes, there is a primary key that we have defined, and there is also a unique key that we have defined over here. Okay, but I don't want this particular two tables over here. So what you can do is just delete those particular tables and restart your application, so that particular only one table will be created. Now let's understand repositories. So let's go to the application. Let me stop the server. Now as a repositories, there are different types of interfaces available that defines the different implementation of different methods that we can use directly for our entities that we have created. Suppose if you want to save that particular entity, if you want to delete that entity, if you want to get all the records available for all those different standard operations, there are different default implementations added using the different repositories in the Spring Data JPA. So let's check what all the different things are available. So what I'll do is I'll create the student repository and I'll implement the different repositories. I'll show you how to extend the different repositories available for our student entity over here. So let me go ahead and create one package over here, and I'll say as repository. Okay, and for this particular repository, I'll create one class, one interface, and I'll say this is a student repository. Okay, now I'll define this @repository. Over here, it's a stereotype annotation, so Spring will understand that this particular interface that we have created is a repository interface. Now, this particular interface can extend different repositories available. So if you see JPA repository, okay, this is the repository available, and this particular repository, if I open this, now you can see that this particular JPA repository is the interface that extends paging and sorting, repository, and query by example executor over here. And this particular JPA repository is using the generics, which is taking T and ID. T is your entity over here and ID is the type of the entity that you have defined. So in our case, T is student and ID is of type long that we have defined over here. Okay, now here you can see that there are different methods available, like find all. Like find all will return the list of T available. So T is student, so it will return the list of students available. Find all method is there. This find all is taking sort as the input parameter, so we can define the different sortings over here. It can save all the data, it can flush, it can save and flush. All these particular different methods are available in JPA repository. Now if you see, JPA repository is extending paging and sorting repository. So let's see what different methods available there. You can see find all and find all using the page. So if you want to implement paging to get the different records available using the pagination type, we can do that as well over here. And this particular paging and sorting repository is again extending CRUD repository. So this CRUD repository is having the different methods such as save method, save all, find by ID. So this will defaultly get you the data based on the primary key that you have defined. You can see it's passing the primary key over here. Okay, so it is also have the method like exist by ID if the value record is available or not, find all by ID, count how many records are there, delete by ID, delete. So you can see that these are the default implementations available for our repository, so we can directly use this particular methods to reduce our efforts over here. And there are a lot of different functionalities extra available that you can use to create the different implementation, custom implementation as well. So we are going to see all those particular things in the later part of the video. So you can see these are the methods available. Let's close these things. Okay, let's define the JPA repository for now over here, and we'll define that it's of type student and of type long over here. Simple thing. Now let's test whatever we have created over here. Okay, so ideally you will be creating the REST APIs and you will be calling those particular repository methods from the REST API. Here what we'll be doing is we won't be creating the REST APIs, we'll be just creating the test class to test this particular repository that we have created to save the time over here. Okay, and if you want to understand how to create the REST APIs and how to interact using this particular repositories, I have created a dedicated video, Spring Boot tutorial, the advanced course. You can go ahead and check that out as well. In this particular video, our main focus is to how JPA works. So we'll be only focusing on the repository layers. Okay, what we'll be doing is we'll be creating the test class for this, and we will create the different test methods, and we will call the different methods available for the student repository and call them. With alt insert, you can go for the generate and you can generate the test class. So I've just defined the simple test class over here, that is student repository test over here, and I will annotate with Spring Boot test over here. Now ideally you should not be testing your repository layer using the Spring Boot test. There is a different annotation available, that is @data JPA test. What this particular thing will do is it will help you to test your repository layer, and once the operation is completed it will flush the data, so the database won't be impacted. But currently we want to impact our database, we want to store our values into our database so we can see what's happening over here. So that's why I'm going with the standard testing over here. Now for this student repository test, we need a student repository. So let's go ahead and create the object for it, student repository, and I will auto wire it. Okay, now let's create one method to save the student over here. So what we will do is we'll create the method public void save student. Okay, and I'll annotate this particular method with @test, so we can run this particular test case. So don't focus on the test cases that we are creating, just focus on what's happening when we are using the repository, how Spring Data JPA works, and how we are going to store the data, how we are going to fetch the data. All those particular things are more important in this particular course. Okay, so to save the student, we need to create the student object with all the values that we have. In the student class, you can see that we have used the builder pattern, so we are going to use this builder pattern to create our object. So what we'll do, I'll just say student equals to student dot builder dot, we are not going to store the student ID because student ID will be auto generated using the sequence that we have provided. Let's pass the email ID. I'll say shabir@gmail.com. I'll say first name as Shabir dot last name as Daudi, and let's add my guardian name as well. I'll just say any name, Nikhil. Guardian email as nikhil@gmail.com. Guardian mobile 234567891 anything remaining. Guardian email, guardian name, last name, first name, email ID, guardian mobile. Okay, and build. So this particular object is built. Now what I want to do is I want to do student repository dot save. What I want to save? This student object. Simple. Okay, so I'm just using the save method of a JP repository. JP repository is again extending the CRUD repository. So you can see that this particular save method is part of the CRUD repository over here. Currently, if you go and check the database, this particular student repository is going to use the tbl_student over here. Currently, you can see there is no records available. So let's go ahead and run this particular method. Okay, you can see that this particular method is successful. Now if you go down over here, you can see that these are the particular different queries that are being executed. You can see that select next val as id val from the student sequence. Okay, so it took the value from the student sequence that we have created, and after that it updated the sequence to the new value. Okay, and it inserted the data into TBL student over here. Okay, so these are the three queries that has been executed over here, and if you go ahead and check the values over here, you can see that we got the values. Student ID as 1, email ID, first name, guardian email, guardian mobile, guardian name, and last name. All the particular data has been saved over here. It's cool, right? With one method, with one line of code, you are able to save the data over here. Now let's create one more method to get the list of students available in the database. So let me just create one more method. Public void print all student. Okay, and this is also I'm going to annotate with test over here. And what I'll do is I'll just define list of student list, and this is from java.util equals to student repository dot find all. Simple over here. Okay, and let me just print it. Okay, let's run this particular method as well. Now as we have only one student available, that particular student will be printed over here. Yeah, you can see that the query was executed. Select all the particular columns from that particular tbl_student over here. Okay, and this is the data. Student list equals to first student, that is student ID, first name, last name, and all those particular details available. Cool. So everything is working fine. Now in this particular student class that we have created, there is an improvement that we can do. So let's see what we can do over here. Now if you see over here, this particular student class contains this particular fields over here, that is guardian name, guardian email, and guardian mobile. Ideally this all details should be in this separate class, because student is a separate class, is a separate object, and guardian should be a separate object, and there has to be relationship between these two. There has to be different relationship available, but ideally this particular data should be saved in a single table in my database. Okay, so let's see how we can do that. So this particular property is available. Guardian name, guardian email, guardian mobile should be in the different class itself. So let's go ahead and create the guardian class. Okay, and this particular guardian class will be having those properties. I'm just removing from here and I'm adding those properties over here. But this particular guardian class cannot be an entity because I don't want to have the different table for it. I want to use this particular properties for my student table only. So how we can do that? We can do using the embed. Okay, we can embed this particular class inside my student. So for my student class to embed this guardian class, this particular guardian class should be embeddable. So I'll define this as embeddable. Simple, right? So this particular class is embeddable. Now I can use this particular class in my student. So let's go back to student, and here I can define private guardian, and this is embedded. Now this particular guardian class should also be annotated with @data because we need getter setters, we need all args constructor, we need no args constructor as well. Simple over here, right? Now as all these particular properties are inside this particular guardian class, can be directly named, right? Email and mobile number, which makes more sense. Okay, but now what happens once we do this? Because as we have the properties in our table, that is guardian email, guardian mobile, guardian name, and here we have defined as name, email and mobile over here, we need to map it together. Okay, so here what we have to do is we have to map this particular attribute to our database that we have, or to all these particular properties. So we need to use the attribute overrides annotation over here. So let's see how we can do this. So what I want to do, whatever the properties are there, this name, email and mobile number should represent to guardian email, guardian mobile and guardian name over here. So let's see how we can do. We can use attribute overrides annotation over here, as we want to override multiple attributes. I'll define the list over here, and here I'll define attribute override over here, and it have name of the attribute and the column name. So let's define those things, and column over here. So the name of the attribute is this one, this name, and here we need to define the column over here. Okay, and in this particular column, this is a column, so we need to define column over here, and this has the name of the column we need to define as guardian underscore name, whatever is over here, guardian underscore name. Okay, cool. Now the same thing we have to define for the rest as well, email and mobile. So let's go ahead and do that. We'll say attribute override, and I will say name equals to whatever the name is email, and column equals to column, and name of the column is guardian underscore email. Okay, one more attribute override, the name of the attribute is mobile. Okay, and column we have to define column equals to column, and inside this let's define the name equals to guardian underscore mobile. Hope the spellings are correct, name, mobile and email. So we just define the 3 attribute overrides, like this particular attribute should define to this particular column name, and this particular guardian we have added as a property in our student. So all good. Now there will be a issue how we define how we create the student object. So if you go to the student repository test over here, you can see that now there is no longer a guardian name available. Let me just comment it over here for now. So there is no issue for now, and let's create a new method, save student with guardian. Okay, public void save student with guardian details. I'll annotate with test over here, and let's define student equals to student dot builder dot build. Okay, so here I need to define dot first name as Shivam dot email ID as shivam@gmail.com, last name as Kumar dot guardian. Now this guardian will take the entire guardian object. Okay, so let's build that as well. So what I'll do, I'll just create the guardian object over here. Guardian equals to guardian dot. Okay, let me go to the guardian and let me define the builder pattern over here. Now you don't have to do this. Okay, I like builder pattern and I like the way it looks, so that's why I'm doing it. Okay, guardian builder dot build email. I'll use the same information. Okay, Nikhil is the guardian. Dot name as Nikhil. Dot mobile as 1 2 3 4 5 6 7 8 9. Okay, some number and build over here, and I'll use this guardian over here, and I need to save this object. So I'll just say student repository dot save student. Now let's run this. Yeah, you can see that it is successful, and here you can see that the select for the sequence, update for the sequence, and insert into table over here. And if I run the query again, you can see that we are getting the record Shivam and all these particular details. So here you can see that we separated out the two different classes over here. Okay, that is guardian and student, but we represented the same in our database over here using the embeddable and embedded over here. So if you have something like this when you are using the inheritance parent-child relationship, you can go ahead with this particular approach. Now let's see the different methods available, how we can create the different methods in our student repository. So suppose we saw that there are only few of the methods available in our student repository, but if you want to create the custom method, suppose I want to get the student's record based on the name of the student. So let's see how we can do that. So in the student repository, student interface, we can define the methods. So I'll just define public, and I'll say my return type is list of student. Okay, and the name of the method that you give over here, it has to be in the format that has been defined. So I can define find, and by what? By by capital, and then you need to define the attribute name. So if you go to the student class over here, and here you can see that it is first name over here. Okay, it is in the camel casing. Here also it should be in the camel casing. So I'll just define over here, and as it's in camel casing, F should be capital over here. Okay, find by first name, and then you need to pass the string over here that will be containing your first name. So I'll just say first name over here. That's it. You just need to give the definition. You don't have to implement it. So I just define one method that is find by first name. So let's go ahead and test it out. We'll go to the student repository test over here, and let's create one more method. We'll say public void print student by first name. I'll annotate together test. And I'll say I just need list of students equals to student repository dot find by first name that we have defined, and I want the records that is having first name as Shivam over here, and let's print it. Let's run this. So we should be only getting Shivam over here, and we'll see what query we are getting out of it. Okay, so here if you scroll down over here, you can see that we got the one record which is having first name as Shivam over here. Okay, only one record over here. Now if you see the query, here you can see that it is doing select from all the particular columns available, and at the last, if you go where student.firstname equals to whatever the value that you are passing over here. So this way you can see that you can create the methods. Now suppose you want to create the methods to fetch the student who's containing first name as some of the characters. Okay, so suppose currently you see that we have just defined that first name is exactly matching that you provide over here. But suppose if you want to get the particular students with some of the particular characters that you want to match, so that you can define using this way. I'll just say I just need list of student find by first name, and I'll say containing, and I'll pass string name. Okay, simple. So what I defined over here is I need the records based on the first name, but it has containing characters. Okay, I don't want to match the entire string particularly, but if we have some of the characters, I want that particular records. So let's go to the student repository test again. Let's copy paste this method. First name, I'll just say containing, and here also I'll just say find by first name containing, and I just need data which contains sh. So let's run this. So here you can see that the query executed. If you go at the last, okay, you can see that the first name like whatever you have defined. Okay, like it's doing the escape characters. Okay, percentage, whatever the name that you are giving, and percentage over here. And here you can see that you got both the records, Shivam and Shabir, both the one. So this way you can create the different methods as well. Let's define one more method. Okay, we'll just say I just need a list of students. Okay, find by suppose last name. We just implemented the method to get the data by first name. Now find by last name, and that should be not null. Okay, simple. I want the records which are not null. Okay, so it will check that last name is not null. We will get those particular records. Now suppose you want to get the data based on the guardian name, so that also we can do. We can just say list of student find by. Now this you need to define based on the attributes. So in the student table there is an attribute called guardian. Okay, so you need to define that find by guardian. This G should be capital, right? And for which particular attribute in that guardian as well. In the guardian I need the data based on the name, so I'll just define name. Simple, right? And I'll just say string guardian name over here. Let's test it out, this method as well. Let's go to the test class and let's implement a method public void print student based on guardian name. I'll annotate with @test. Okay, and let's implement this. I just need list of students equals to student repository dot find by guardian name, and guardian name I'll define as Nikhil, and I'll print this out. Let's run this. You can see that how simple is this, right, to implement all these particular different methods. Here you can see that the query is select all the records, and at the last you can see that where student dot guardian name equals to this. Okay, so with this particular name that we are defining over here, JPA is able to understand what we are saying over here. Okay, and we got both the records, that is Shabir and Shivam, as both is having the same guardian over here. Now if you go to this particular documentation, if you go to the Spring Data JPA, learn, and go to the reference documentation over here and go to the query methods, and here you can see that there is a list available over here. Okay, how you can define your method name. Currently you saw that we defined few of the methods over here in the student repository. Okay, find by first name, find by first name containing, find by last name not null, find by guardian name. And here you can see that the list available how you can define your own method name as well. So if you want to get the distinct records, you can say find distinct by first name, last name, or whatever you want to give over here. And if you want to get the records based on the two values, suppose you want to get the data based on your first name and last name, so here you can see that and keyword you can use like find by last name and first name. So you can define this way like find by first name and last name, I want to get the records, and in the parameter you can define that way. Suppose I want student, okay, find by first name and last name, okay, and here I need to define two values over here, string first name and string last name over here. This y should be small over here, okay, find by first name and last name. And here you can see that if you want to get the records by find by first name or last name, you can define that way as well if you want to match the particular values. And here you can see that how the sample should be, and here you can see that how the JPQL snippet is for that. So how a JPQL query will be represented for that particular thing. We will come to that part, how to add the JPQL queries, how to get the data based on JPQL queries as well. But if you come over here, you can see all the different examples over here, and based on this example you can create your different method names, okay. Here you can see that if you are using any values like find by start date between, find by age less than, all these things you can do over here. You can see that we use this particular one, right, find by not null, we define find by last name not null. You can use the like operator, not like operator, okay, starting with this, ending with this. We use this one containing, right, containing any of the particular characters over here. You can use order by, last name not, last name in, not in this, it's true false. If you have a boolean values, you can go with the find by true, find by false as well, and you can go with the ignore case as well. So you can see that if you define ignore case, both the places when you're matching, the values will be used as uppercase. So this way you can go through this particular article. I will add the link in the description below so you can check that out. These are all the different ways that you can create the method as well. Now the time comes when creating the method name is not enough. You have to create the different method name, and you have to specify the different query as well, right? Like based on this query, I want to get the data. So for those particular cases, you can use the @query annotation, and you can pass the JPQL queries as well. So let's see how we can do that. Let me go to the IntelliJ IDEA and let's create one method over here. What I need, I want student, and I'll just define get student by email address. Okay. Now this is and I'll define string email ID as well. Okay. I want this particular method. So here you can see that I've just given the different name over here, so you're not confused like with this particular default implementation methods over here. I just gave the get student by email address over here. Now here what I want is, as our email ID is uniquely identified, as we have added the unique identifier for this email ID, I want that particular student based on the email ID that I have provided. But I want that data based on the query. So I need to pass the query. I can give that query using the query annotation. And here I can pass the JPQL queries. Okay, if you go to this particular document, you can see that these are the JPQL queries snippets over here. Okay, select distinct and all those things. And if you come over here, what I can do, select, I can define select as from student s. So the JPQL queries are defined in a separate way rather than the native SQL queries. But this is a very simple over here. Okay, so the JPQL queries are defined based on the classes that you have defined, not based on the table names and the table attributes, table column names. This will be defined based on your class that you have created and the attributes that you are using in your class. So you can see that I'm not going with the tbl_student. I'm going with the select as from the student class that I have created, and I want the student where s dot whatever the attribute name. In here you can see that my attribute name is email ID. Okay, so I'll define s dot email ID equals to $1. That is the first parameter. So I'll just define here as this is the JPQL as well. So here you can see that we just defined a simple query over here, that is a JPQL query. JPQL queries are based on the classes that you have created, not based on the tables in the database. Okay, so that's the one thing that you have to take it in the mind. So student is the class that we have created, email ID is the attribute property in my student class, not the email underscore address that has been defined over here. Okay, here is email underscore address, but we are using this particular thing over here, and this should be small email, right? Now let's create a test method to get the data. I'll use this name only, public void print get student by email address. Okay, and I'll annotate with @test over here. What I'll do, student equals to student repository dot get student by email address, and here I'll define the email address. I just say shabir@gmail.com. okay, and I'll print this student over here. Simple thing that I've defined over here. Okay, nothing complex. So let's run this. So here you can see that the query is executed. Select student, all the particular values, and at the end you can see that email address equals to whatever the email address was passed, and here you can see that only one record has been fetched over here. Now suppose if you want to have only one value, suppose let me copy this thing, okay, and I'll just say get student, I'll just say first name. Okay, so I just need the first name by the email address that I'm providing over here. So here I'll define s dot first name, that I just need first name. I'll go to the student, I'll just copy this from here, and I just need s dot first name from the student as where s dot email id equals to parameter 1, that is email id that I'm providing over here. And I don't want as a student, this is the string over here, because I'm just getting the one value over here. So let's go ahead and test this as well. Public void print this, I annotate with @test. This is string, right? So I can directly use string first name equals to student repository dot get student first name by email address, and I'll just define this email address, that is shivam@gmail.com. okay, and I'll just print this. Very simple thing over here. Let me run this, and here you can see that the query was executed. Select only first name as the first column from this particular table where email id was whatever was provided over here, and only one particular value was printed. Okay, so you can mix and match this way, and whatever the way you want to define the particular queries and the way you want to get the data back, you can define in the particular method this way. Now you can see that we have defined a lot of methods over here, right, in this particular repository. Now let's take to the another level. Now you have a very complex objects and you have a very complex query that you're not able to define from the JPQL as well. So Spring Data JP also gives a support for the native queries as well. So you have a native SQL query that you can define using the @query, and you can define that this is a native query and you want the data based on that. So that also we can define. So let's go ahead and see how we can define that. Let's create one more method. Let's take the same example. Okay, let's take the same get student by email address example, but instead of JPQL query, I'll pass the native SQL query. So I just need student from here, this particular method, but I'll just define this is a native one. Okay, and I'll pass a string email ID over here, and @query I'll define. Okay, and the value of the query. What is the query that I'll be defining over here? And then I'll define that this is the native query. Cool, right? Let me define the query now. So the query should be select star from tbl underscore student. Okay, if you go to the database, let's copy paste this query, okay, directly. I don't want this one schema name. I'll define s, where s email underscore address equals to question mark 1. Here you can see that with the @query notation, we provided the value over here, and that value is select star from tbl student, where s.email address equals to question mark 1. That is the first parameter, and we have also defined that this particular @query, whatever the value that we are passing, that is a native query. So that is a native SQL query. Now let's go ahead and test it out. So let me just copy paste this. I'll go to the test and create one more method, public void print this. I'll annotate with the test over here, and I'll say student equals to student repository dot get student by email address native. Okay, and I'll pass the email ID over here. Let's print this and let's run this. And here you can see that we are getting the data over here, and the query is executed, whatever the query that we have defined over here. Okay, so the new query is not generated based on the method name that we are giving, or based on the JPQL query that we are passing over here. This is the same query that we have defined, and the same query is directly executed based on the native query equals to true flag we have defined, and we are getting the data as well. So whenever you have a very complex queries to work with, you can go ahead with this particular implementation to work with the complex queries as well. Pretty neat, right? Okay, so I'll just define this is a native query. Now suppose if you have a multiple parameters that you're passing over here, passing with question mark 1, question mark 2 is not always the better approach. So what you can do is you can go with the named parameter values. Okay, so you'll be defining a particular naming parameter, that particular name parameter that you will be defining in your input parameters as well. So let's go ahead and see how we can do that as well. So let me go ahead and create the same thing over here. Okay, I'll just copy paste the same thing. Instead of native, I'll define native named param. So I'm defining the named parameter over here, and instead of question mark 1 over here, I'll define colon email ID. So this is much more readable, right? And here I need to define that parameter. Parameter is email ID. So here you can see that I'll just define native name param. So it's more understandable for you when I'm sharing the code with you. Okay, so this particular query that I have defined over here, that query equals to whatever the query I have defined, and I have passed the named parameter values, and this is the particular method I have defined, and inside this particular input parameter I have defined that this particular input parameter defines the colon email ID parameter over here. And if you have multiple, you can add the multiple values over here, and you can pass @param for all those particular multiple values that you have. Now let's go ahead and run this as well. Okay, I know this would be a little bit boring for you guys, but I'm trying my best to make it more understandable for you. Okay, so let me copy paste all these details. Okay, and the method is native named query, named param. Okay, so here you can see that this is the named parameter method that I'm calling. Let's run this out, and you can see that we are getting the record. This is the same way. Cool, right? Now the next one is really awesome. Currently you see that whatever the methods that we have defined over here, all those particular methods are to fetch the data. All this particular, as you can see, all the native queries, all the JPQL queries, everything that we have defined are all fetching the data. What if you want to update the data or delete the data? Okay, that also should be possible. So that is possible using the modifying annotation. So let's see that as well. So let me go to the student repository. Okay, and currently you saw that whatever the queries and everything that we have defined, everything is fetching the data. Now let's create one of the method that will update the records. Now the method that I'm defining over here is to update the first name of a student based on the email ID that we have. So I'll just define integer update student name by email ID. Okay, this is the name of the method, and here I'll be passing string first name that I want to update and string email ID, for which particular email ID I want to update the first name. Now as always, we can define using the query annotation. This will have the value, what is the query, and I'll also define this is the native query as well. So the query would be update table name, that is tbl underscore student, set first underscore name equals to question mark 1, where email underscore address equals to question mark 2. So this is a simple update query that I have defined over here. Now to make this method to modify the values in our database, we need to annotate with @modifying. Now as this is a modifying query, as it is modifying the data, there has to be a transaction for it. Okay, so all the particular methods that we want to make it transactionable, so a transaction is created, some of the operation is been performed on it, and that particular transaction is been committed back to the database. That all the things we can do using @transactional annotation. With one simple annotation, a transaction will be created. All the operations like insert, update, delete, whatever that we want to do, we can do all those things, and at the end, after that particular operation is been performed, when that particular method has been completed, that particular transaction will be committed to the database. Ideally, all this particular transaction we will be adding at the service layer when we create a service layer, and we can call the multiple repository layers from that service level to make it entire flow as a transactional. Suppose if you want to insert 3 records inside a 3 different table, you will annotate your service layers method with @transactional. You will call the 3 methods of the repository layer, and once everything is completed successfully, then only at the end your transaction will be committed. Otherwise your transaction will be rolled back if there is any error in it. So that's how ideally the transaction will be implemented. But for now we are adding in the repository layer because we are more focused on the JPA for now. This is the transactional annotation that we are using over here that you can use at your service layer wherever you want to create a transaction. You can create a transaction as a method level and a class level as well. Now let's go ahead and test this particular thing. Okay, so what we'll be doing over here is we will be giving the first name and email ID over here to update the record. So let's go to the test class over here. Let's create one test. I'll copy paste this particular thing, public void I'll annotate this particular method with other test over here, and I need to call student repository dot update student name by email ID. And we need to pass first name and email ID. Suppose I want to update this particular record, that is shabir@gmail.com. So I'll just pass this information that for this email ID I want to update the record, and my first name should be, suppose I'll just say Shabir Dawoodi. Okay, just for the sake of simplicity I'm just adding this detail over here. Okay, now let's run this, and here you can see that update query was executed. Update this table, set first name equals to whatever the value, where email address equals to this particular email address that we have passed over here. And if we execute the query again, here you can see that my first name has been updated with the new values that we have defined over here. So we just saw that we have defined 2 annotations, that is @transactional to define a particular transaction for this particular method, and also @modifying annotation whenever you want to execute any queries that has been modifying the record in your database. The same will be applicable when you want to delete the records as well. So here you can see that we saw a lot of things about the repository, different repository methods, how to create a different methods, how to use the queries, how to use the native queries, and how to modify the queries, how to modify the records using the modifying annotations as well. Now we will see the different relationships available in the JPA. Now firstly, we will check one-to-one relationship in JPA. Now with this particular class diagram, you can see that we have two classes, that is a course class and a course material. And for this particular two classes, that is course and course material, there is a one-to-one relationship, because for one course there will be one course material, and for a course material will be only available for a particular course over here. So this is a one-to-one relationship, and for this particular thing, how a table will be created is like, you can see that for a course that contains a course ID, a course title, and a course credit, and the other course material is having a course material ID and the URL to it. So what will happen is, either of the table will contain a foreign key of the other particular table that we have. So a course ID is a primary key for the course table, so that particular course ID will be behaving as a foreign key for a course material table over here. So let's create these two classes, course and course material over here, and let's see how we can define one-to-one relationship. So let me go to the IntelliJ IDEA, and with this particular entity package, let's create course entity and a course material entity over here. So I'll just create a new class that says course over here, and I'll create one more entity that says course material over here. Okay, let's go to the course and let's define this as an entity, and we'll annotate with @data for Lombok, @allargs constructor, @noargs constructor, and @builder. Just the standard stuffs. Okay, let's do the same for the course material as well. @entity, @data, @allargs constructor, @noargs constructor, @builder pattern. Now let's create the attributes over here. So here I'll define private long course ID, private string course title, private integer credit over here. So these things are defined over here. Now let's define the course material ID and URL in our course material class. So let's go to the course material. I'll say private long course material ID, private string URL for the course. Okay, just a simple thing over here. Now this course material ID and the course ID in the course class both have the primary key, so we need to define the primary key for it, and we need to define the sequence generator and the generated values, how the values are generated. So let's do that. I'll annotate with @ID over here, and for this course ID, let's define sequence generator, and the name of the sequence generator I'll define, sequence name we will define, and the allocation size I'll define over here. So I'll just say course sequence, and the sequence name is course sequence. Okay, and how the values are generated. So @generated value, strategy would be generation type dot sequence, and the generator would be course sequence over here. Let's define the same thing in course material. @ID, @sequence generator. Well, I'll define the name of the sequence generator and the name of the sequence as well, and I'll also define the allocation size, that is 1, and I define course material sequence. Okay, and generated value, I'll define this strategy equals to generation type dot sequence and generator equals to course material sequence over here. Now we need to define the mapping over here. Now between course and course material, the mapping that we can define is course material will consist of a course. Okay, course material cannot exist itself. It has to have a course so that we can add the course material to it. So for that, in the course material, we'll define private course over here. Okay, and for this particular thing, we'll define 1-to-1 mapping. Now this we've defined that this is a 1-to-1 mapping. Now we need to define for which particular column that a foreign key will be applied. Okay, so for that we need to define join column over here. For which particular column that we can join these two particular tables. So here I can define name of the column and I can define the reference column name. So which particular column it is referencing to. So inside this course, it is referencing to course ID over here. And what is the name of the column? That would be course ID. Okay, simple. We just define what will be the join column. In the referenced column name, we define which particular column this is referencing to. So in this course, it is referencing to this course ID, this particular attribute. And what would be the name of that column? We have defined that the name of the column should be course ID. So in this particular course material table that we are going to create, this particular course material table will have an extra column that will be course underscore ID. So that will refer which particular course this belongs to. Now all the standard stuff that we saw earlier, all the things applied here as well. That we can define @ column, we can define @ table, we can define the unique keys, we can define different constraints over here. Everything we can do over here also. But we have a limited time, so I'm considering that you can do all those things by yourself by referencing to what we did in the student class. Everything you can do here as well. So let's go ahead and let's start our application and let's see what are the different tables is created. So I will just run the application, and once the application is successfully started, you can see that there are the different queries created. You can see that table course is created. Okay, course material sequence is created, course material sequence value has been inserted, course material table is created, and the course table has been altered, adding the foreign key over here. And if you go to the database over here, and if you refresh the database, here you can see that course table has been created, course material table has been created, and the two sequence tables are created. And if you open the tables over here, let me open the course table, and here you can see that in the course there are 3 columns over here. That is course ID, the name of the title of the course, and the credit available. And if you go to the course material, you can see that course material ID, the URL of the course material, and the course ID which this particular course material belongs to. So this way we have added the primary key and foreign key relationship between the two tables. So here for every course there will be one course material. That is a 1-to-1 relationship. Now let's create the repositories for our course and course material over here. Okay, so let me go to the repository and let's create the interface over here, and I'll say this is course repository. Okay, and this extends JPA repository, and this is of course, and long is the ID over here, and I'll annotate with @ repository. And I'll create one more, that is course material repository, and I'll extends JPA repository with the course material and long, and this is @ repository. Okay, we just created 2 repositories, course repository and course material repository. Now what we will do is we will test this particular thing out. So we'll create the test class for this course material repository over here, and we will try to save a course material with the one course over here. Okay, so let's generate the test class over here. This is a particular test class that we generated. let's annotate with Spring Boot test over here. And for this particular course material repository, what we need is private course material repository, and I will auto wire it. So this is the particular repository's object that we want to create the different methods. So let's create one method to save the course material with the course. So I'll just say public void save course material. Okay, and I'll annotate this with @test over here. Now let's create the course material equals to course material dot builder dot URL. So what's the URL? I'll just say www.google.com.course, and here we need to pass the course object over here dot build. So let's define the course object as well. Course equals to course.builder.course title equals to, let's say, data structures and algorithm dot credit. I'll say there's a 6 credit for this particular course dot build, and I will pass this course to my course over here. Now let's save this course material. So I'll just say repository dot save course over here. Sorry, course material over here. Okay, simple thing, right? We created the object of a course material over here, and this course material has to have a course for which particular course that we want to save the data. So we defined that as well over here, and we are trying to save that particular course material over here. So now let's run this and let's see what is happening over here. Okay, so let me run this. Blah blah blah, and it failed. Okay, let's see why it failed over here. And here you can see that the error is invalid data access API usage exception, transient property value exception. Okay, object references and unsaved transient instance. Okay, object references and unsaved transient instance over here. For what? Course over here. Okay, what we are doing over here is we are trying to save the course material without saving the course over here, because what is happening over here is we are trying to save the course material, and for this particular course material we have to have a course that is already saved in the database, but it's not. I have not created any of the course over here. What we are trying to do is when we save the course material and we also pass the course, and if that course is not available, we need to create that course as well. To make this thing happen, currently you can see that it's not happening, but to make this thing happen, cascading comes into picture. Once we implement the cascading means what? Cascading means to pass the properties or to pass the permissions to your child elements from the parent to child. Currently you can see that I want to save the course material and I want to persist it, and we have a course that is not persisted, so we will cascade the information. We have different cascading types, so we are passing that information. Okay, I'm trying to persist this particular course object is not available. Okay, no problem, try to persist that as well. So there are different cascading types available. Okay, that's an enum available, so we can define that, and accordingly what we define, this particular operation will happen. So let's go and define that. So we'll go to the course material, and in one-to-one mapping over here we'll define cascade equals to cascade type dot. You can see that there are different options available, that is cascade type dot all, detach, merge, persist, refresh, remove, whatever. So whatever you define, the operation will happen accordingly. For the simplicity, I'll define cascade type dot all, so whatever the operations are there, everything will happen over here. Currently you see that in the course and course material there is no data, there is no course material, and there is no course as well. If you go back to our IntelliJ idea, if you go to the test class, earlier it failed. Now let's run it again. And now here you can see that this is successful, and if you go down you can see that how many queries happened. You can see that first the course was inserted. Okay, after that course material was inserted over here, and if you go to the database and if we run the query, you can see that the course is created with course ID 1, credit 6, title is DSA. And if you come to the course material, this course ID should be used over here. You can see that course ID 1, the URL is this, and the course material ID is 2. So with this particular cascading type information, we were able to do this. Now, once we go back to the course material over here, okay, there is a different thing available that is called fetch type. How you want to fetch the data. There are two types of option available, that is eager fetching and lazy fetching. So what's the difference between that? The difference is, so if you are having a relationship between the two tables, so once you call the data of a parent, so suppose currently when you call the data of a course material, do you need to fetch the course also with that, or you just need the course material only? So based on the application that you have, you can define the fetch type. So when you define the fetch type as eager, it will bring the course data as well when you try to bring the course material. But when you define fetch type as lazy, it will not bring the data of a course until and unless you specifically ask to bring the course. Okay, so in this particular one-to-one relationship, there is a fetch option available. So with this particular fetch, you can define either is a fetch type eager or fetch type lazy. So I'll just define fetch type lazy over here. Now let's go back to the test and let's add the method to print the course materials. So I'll just say public void print all courses. I'll annotate with the test over here, and I'll say list of courses. Sorry, I'll say list of course materials. Okay. Course materials. And I'll say course materials over here. Equals to repository dot find all. Okay, and I'll just print it. Okay, simple method. So let's run this. Okay, you can see that it is throwing the error that could not initialize the proxy for the course. So what I'll do over here is, there's a toString method that is calling the course over here. So I will remove it for now. So I'll just define @toString and I'll exclude course over here. Let's run this again. Now as we have defined the fetch type as lazy, you can see that we are getting only course material over here. We have excluded the course as well from the toString method, so it won't call that particular get course method over here. So ideally, as per the requirement that you have, you can define that what should be your fetch type. Either it would be eager or lazy over here. Now you can see that we define the find all method for the course material over here. Now let's go to the course and let's get the courses available over here. So let me go to the course repository over here and let's create the test class for this as well. I'll add the Spring Boot test over here, and I need to add the course repository as well. So I'll just add private course repository and I'll auto wire it, and I'll have a method public void print courses, and I'll annotate with either a test over here. I'll have list of courses equals to course repository dot find all. Okay, and I'm printing the courses available. So let's run this. Now here you can see that you are getting the list of courses available. Okay, what is the course available? Now ideally when you're getting the courses, you want the course material as well. So ideally when you are getting the courses, you want the course material as well, because then only you'll be identify what's the material for that particular course, right? There is no point of getting two details separately. But how to get the course material from this particular course repository? Because you have created the course material repository, okay, and when you are working with the course material object, you are getting the course material with the courses as well. But when you are working with the courses, you are not getting the course material. Why? Because you have defined only unidirectional one-to-one mapping over here. We don't have any course material references in our course. So you can see that in the course material you have a reference to courses, but if you go to the courses, you don't have any reference to course material because you have only defined unidirectional one-to-one mapping. Now let's see how we can define the bidirectional one-to-one mapping over here. So for this particular courses, you need the reference to the course material, but you already defined one-to-one mapping over here. So what we can do is we can come to our courses entity over here, and here we can define private course material over here, and here you can define this is one-to-one mapping over here. But here you cannot define the joining columns, right? Because you already defined in the course material. So here you need to say this is mapped by some other class, right? So you can tell this is mapped by what? This is mapped by this particular course in this course material class over here. So what you are defining over here is you need a reference of course material in your courses to define one-to-one bidirectional mapping. But that one-to-one mapping to join a column for a foreign key is already defined in the course material. So you are telling that this particular one-to-one mapping is already defined by the courses attribute in course material class over here. So in this course material class, there is a courses attribute that has already defined one-to-one mapping over here. Cool, right? Now let's test it again. Now if you go back to the test over here, and already earlier you can see that we only got the course over here. Now if we run it again, we should get the course with course material. So here you can see that the test case is passed over here, and if we go down over here, you can see that we got the course, also we got the course material as well, right? So we defined bidirectional one-to-one mapping. So we define the reference of course material in the courses as well. So this is how you define unidirectional or bidirectional relationships in any of the relationship types. Either it is one-to-one, one-to-many, many-to-one, or many-to-many relationship. So I just showed you in one-to-one. The same concept and the same implementation goes in all the other three as well. Now let's see one-to-many relationship. Now if you come to this particular architecture that we have defined over here, we just saw course and course material that is having one-to-one relationship. Now if you come over here, teacher and courses over here, that is having one-to-many relationship. One teacher can teach multiple courses over here. So that is a one-to-many relationships. And the reverse would be many courses can be taught by one teacher. So that would be many-to-one relationship. So let's go ahead and first see one-to-many relationship, and then we will see many-to-one relationship. So let me go back to the IntelliJ idea. We already have course and course material classes created. Let's go ahead and create the teacher class as well. So teacher has teacher ID, first name, last name. So let's go ahead and create that. So I'll go to the entity and let's create the Java class is teacher, and I'll annotate with @entity over here, @data over here, with all args constructor, with no args constructor, and build a pattern. Now this teacher has private long teacher ID, private string, first name, private string, last name over here. These are the three fields available for a particular teacher class. You can add multiple, but let's add it only three for the simplicity over here. This particular teacher ID would be our primary key. Okay, and we need to define the sequence generator and generated value as well for here. So I'll just define sequence generator. The name of the sequence generator I need to define, the name of the sequence I need to define, and also allocation size I'll define as 1. I'll just say teacher underscore sequence over here. The same value I'll define over here in the sequence name. Okay, the spelling is wrong. I'll just correct it out. Okay, and I'll define the generated value as well. @generated value I'll define the strategy equals to generation type dot sequence, and generator I'll define as teacher sequence over here. This is a simple thing that we have defined over here. Now what we can do is this particular teacher and course have a one-to-many relationship. One teacher can teach multiple courses. So a one teacher can have a list of courses inside a particular class. So I can define this way, right? If I go to this particular teacher class, I can define one attribute as private list of courses. Okay, that this particular teacher have a list of courses which a particular teacher can teach. So I can define this particular is a one-to-many relationship. As we defined the cascade type in the course and course material, here also we'll define the cascade type. I'll just simply say cascade type dot all for now, simplicity. Now for this one-to-many relationship, there will be two tables. One will be teacher, one will be course. For every teacher, which particular course that particular teacher is teaching, that particular relationship will be having. So you can consider that course table will be having a extra key, foreign key, that is a teacher ID. That particular column will define this course is taught by which particular teacher. So we need to define joining column over here. So we can define joining column, name of the joining column, and reference column name. So what will be the reference column? Reference column will be this particular teacher ID. Okay, and what would be the name of the column? I can say teacher underscore ID, whatever you want to name the column. So this is a simple unidirectional one-to-many mapping over here. Okay, and we have defined cascade type as all over here. I hope this is very clear. This is a very simple thing. We just define one-to-many relationship between two particular classes, that is teacher and course. Teacher can have a list of course that a particular teacher can teach. Okay, so we just define that way over here. Now let's start the application. Okay, and a particular teacher table will be created. Yeah, you can see that my application has started, and you can see that teacher table was created. Okay, and the course table was altered, and a new foreign key was added to that particular course table over here. Simple, right? And if I go back to this particular database, and if I refresh my database, you can see that now course table was having only 3. Now if I run it again, you can see that new teacher ID has been added over here. And if you see over here, there will be new teacher table also created. What's the teacher available? Now let's go ahead and create the teacher repository as well. Teacher repository as the interface, and that extends JPA repository, that is of type teacher and long, and I'll annotate with @repository. Now for all these particular things, you can define all the methods, different methods that we already saw in the prior part of this particular video, right? So for this particular teacher repository, let's create the test class, and I'll annotate with Spring Boot test, and I need private teacher repository, and I'll auto wire it. Let's create the method to save a teacher, okay, with the course. So I'll just say public void save teacher, and I'll annotate with test over here. I'll say teacher equals to teacher dot builder dot build dot first name equals to, suppose Kutab is a teacher, dot last name say Khan, and dot what courses this particular teacher is teaching. Now this particular course is, it is taking the list of courses. Okay, so let me just create one of the course, or you can create one method to add the course to that particular courses list as well. Okay, whatever is feasible you can use that way. Ideally it should be you create one method that adds the course to that particular list of course. For the simplicity, I'll just do a cheating over here. I'll just create a course equals to course dot builder dot build. I'll just say course title equals to, I'll just say DBA dot credit is 5 and build, and I'll just use this course as list dot of courses. Simple. Now let's add the teacher repository dot save teacher. Simple, right? I just created the teacher object over here. This teacher is having a list of courses. I just added one course. Let me add multiple. Okay, I'll just say course DBA, and I'll add one more course. I'll just say Java, it is teaching Java, credit is 6, course DBA, course Java. 2 courses. This particular teacher is teaching 2 courses, so I just defined this way. Now let's run this. So here you can see that it is successful. You can see that one teacher was inserted. After that 2 courses were inserted. Okay, and those particular 2 courses were updated by the teacher ID that we have inserted. So let's go and see this. You can see that one teacher was created, that is Kutub Khan. Teacher ID is 1. And if you go to the courses over here, okay, and if I run this, you can see that this particular 2 course DBA and Java is created, and it is taught by teacher ID 1. Teacher is 1 over here. And if you see this particular 2 courses 2 and 3, for this particular 2 courses there are no course materials over here. Okay, so now this is something that we can take care of, right? Because ideally what we can do is, when you define a course, you should save a course material with it, right? Without a course material, you should not be allowed to save a particular course over here. But currently you can see that we were allowed, right? We were able to save this particular thing. So how to do that? So that is optionality. Optionality means it defines that whatever the relationship is, that it's an optional relationship or a mandatory relationship. So it defines. Currently you can see that by default everything is optional. Okay, there is nothing that is telling us that this is mandatory. Currently when we save the course without adding the course material as well, we were able to save it. So let's see that. So if you go back to our course and course material over here, so if you go back to the course and course material, here with this particular one-to-one relationship, I can define optional equals to false. By default it's always true. So now I have defined over here that whenever you are trying to save a course material is required. It's not optional over here. So let's go back to the course material repository test, and let's try to save the course over here. And we already have one save course material. Let's use the same thing over here. Okay, what I'll do, I will not define the course over here. Okay, and I'll just change the material as, let's say, daily code buffer. Okay, and let me save this. Let me try to save this. And here you can see that we got the error over here. And here you can see that what it is asking here is data integrity violation exception, non-null property reference and null or transient value over here for this particular course. So that means this is forcing us to add the course over here. Okay, so now if I, let me just change the name over here. Okay, I'll just say .NET. Okay, now if I add this particular course back, okay, for this particular course material, then only it will run now. See, here you can see that it is successful, right? You can see it was updated. Now if I go back to the MySQL and go to the course, you can see that new course was added, .NET. Okay, and if you go to the course material, course material was added for it. So this way you can define the optionality for your entities that you have created, which of the particular entities or which of the particular objects and classes are optional or not. Now let's go back to the one-to-many relationship. Here for this particular teacher repository, teacher class, we have defined that teacher contains a list of courses available. That's a one-to-many relationship. Now what will be many-to-one relationship? Many-to-one relationship would be there are many courses available and those particular courses are being taught by any one of a teacher. So rather than defining this way, like this particular class, this particular teacher have a list of course, we can define a particular teacher who is teaching a particular course that we define. That is more readable, more understandable, and that's a guidance provided by a specification of JPA that you should always go for many-to-one relationship whenever possible. So what I'll do, I'll just comment it out for now over here. Okay, I'll just keep this in the code as well so you can refer it out. So what I will do, rather than defining this way, I will go to the course over here, and for this particular course I will define that this particular course is taught by whom. So I'll just say private teacher, and this is many-to-one relationship. Okay, we just reverse it, one to many, this is many-to-one. Now here also we have to define the join columns over here. We can define the name of the join column and also define the reference column name over here. The reference column name would be inside the teacher, this will be teacher ID. Okay, that would be reference, and we'll define with same teacher ID. Now with this particular change, there won't be any change in your database. Everything will remain the same. This is how you represent all your tables in your objects. That's a representation change over here, but the structure will remain the same. And this is still many-to-one unidirectional relationship. Now when we are trying to, now here as well, in many-to-one relationship, whatever you define in over here, you can define cascade type all over here. So whenever you are saving a new course with a new teacher and a new course material, all the things will be saved or all the things will be deleted, whatever is preferable. Okay, now let's create a course with all the particular values. Okay, so I'll go to the course repository test over here. I'll say public void save course with teacher object. Okay, I'll annotate with @test over here, and what I'll define over here is course object course equals to course dot builder dot, what's the title of the course? I will just say Python dot credit is 6, and dot, you can define the course material as well. Let's define the teacher, and for this particular teacher, what I can do, I can create the teacher object teacher equals to teacher dot builder dot build dot first name, I'll just say Priyanka dot last name Singh dot build. Okay, this is the teacher. Now this particular teacher I'll pass to this particular course, that this particular Python course is taught by Priyanka Singh, and now I can directly say course repository dot save this course over here. Here you can see that I'm just doing the save over here. It applies to update, delete, get all data, get a particular data. For everything this applies. Okay, I'm just giving you a very simple implementation over here so you can understand. Now let's run this. So what should happen over here is a new teacher should be created, a new course should be created, and for that a foreign key of a teacher should be assigned to a course. So let's run this, and here you can see that there is an error over here. That's fine, I'll just comment it out over here for now. Okay, because we just removed the reference of the courses over here. So let's do this, save courses with teacher again. Here you can see that the course is created and a teacher is created. Okay, so let's go back. Let's go to the teacher table, and here you can see that new teacher is created, that is Priyanka Singh with teacher ID 2. And if you go to the courses and if you run the query, you can see that new course Python is created and taught by teacher ID 2 over here. Simple thing, one to many and many to one relationship. Now let's see how to implement paging and sorting using JPA repositories. Now, as you are already aware that for every repositories we have implemented the JPA repository, and this JPA repository again extends the paging and sorting repository. If you go to this paging and sorting repository, you can see that either you can implement the find all method or find all method based on the sorting or based on the pagination. You can implement the pagination and it will return the page object with the particular data type that you are passing, particular type of object, and that will take the pageable as the input parameter, where you will define the different page number and how many records that you want for that particular page. And for the sorting as well, that you can define what kind of sorting that you need to implement for fetching the data. So let's go ahead and see how to use this particular default methods and how we can implement the custom method as well. So let me just close this, and for this particular course repository, let's go to the test over here and let's call this particular method. Okay, so let me just create a new method over here. Okay, I'll just say public void find all pagination, and I'll just do @test over here, and here I'll define the pageable objects, and I just say pageable first page with three records equals to page request dot off method. Here you can see that this particular method takes the page number, the size of the page, and the sorting for that particular page. So I'll just define the 0th page, that is the first page, and I want 3 records over here. So I'll just remove this. I'll just remove this as well. Let me create one more object of pageable. I'll say second page with 2 records equals to page request dot off. I'll say second page, that is first, and I want 2 records. I just created this particular object over here. Now I need the list of courses available for this. So I'll just say list of courses available equals to course repository dot find all, and inside this find all I'll just pass first page with 3 records and dot get content. So this is a simple method that I am using find all, where I'm passing the pageable object that you saw over here. Okay, you can see that it is taking the pageable object over here as an input parameter from the paging and sorting repository. Okay, so I'm just using that particular inbuilt method over here, where I've just defined the 2 pageable, first page with 3 records, second page with 2 records over here. First page, that is 0th page, 3 records that I've defined, 3 over here. And this particular object will return the page of courses. From that particular page of courses, I have used .getContent method to get all the contents of that particular page. Now there are more details also available. We can get the different things such as total pages and total elements as well. So let's do that as well. What I'll do, I can define long total elements equals to dot. Here you can see that there are a lot of different methods available. Dot get total elements, you can convert to stream as well. Okay, you can get the contents, you can get the number of elements, you can get the total pages. Okay, all those things you can do over here. So let me just get the total elements over here for now, then I can have total pages as well. Okay, I can say long total pages equals to course repository dot find all first page with 3 records dot get total pages. Okay, and I can define this particular total pages as well. And if you go to the database, currently I have 5 records available. Now let's run this. You can see that there are a lot of queries available. Okay, these all the queries were executed, and you can see that there were a total of 2 pages and the total elements are 5. Why there are 2 pages? Because I've defined that my page should be of 3 records. Every page should be of 3 records. Okay, so that's why I divided into 2 pages, and I want the first page. So first page should contain 3 records. So here you can see that first course, second course, and this is the last third course available. So 3 courses are defined over here. Now if I pass the second value, second page with 2 records everywhere, and if I run it again, I should be getting 3 pages because each and every page should be of 2 records. Okay, here you can see that I'm getting total pages as 3. My total elements are 5, and as I need to have the second page, I will be getting the 2 records of the second page over here. Okay, so this way you can implement the by default find all function using this particular pagination as well. Okay, now let's implement pagination with sorting. I'll just create one more method, public void find all with sorting. Also, this is a test over here. Suppose I want to sort the data based on the title. Okay, so what I can do is I can use pageable sort by title over here, page request dot off. I can say 0th page with 2 records, and sort dot by, I can say title. Okay, simple page request, just like over here whatever defined over here, but here I just added the sorting as well. I can also do pageable sort by credit descending order as well. I can do page request dot off first page with 2 elements dot sort dot by credit dot descending. So this will sort the records by credit in the descending order. I can also define pageable sort by title and credit descending order. Okay, for this I can do page request dot off, can do first page with 2 records where I can define sort dot by title and descending order dot end, again do sort by credit. Simple, right? And now I can pass everything over here. I can do list of courses over here equals to course repository dot find all, and inside this find all I can pass anything. I'll just say pass sort by title over here dot get content, and let's print it out. Okay, and we can run this. So here I just gave you the different ideas like how we can use this particular different sorting, multiple sorting, descending order, ascending order. Okay, and we can pass that particular page request to our find all method, and we can get the data over here. So let's run this, and here you can see that we are getting the data over here. Now we can create the custom method as well for the sorting. Okay, so what we can do over here, we can go to the course repository. Okay, let's create the method over here. What we can do, list of courses over here. Okay, and for this particular list of courses, what I need, find by title, find by title containing, find by title containing over here, and here we need to pass the string title over here and page request. So this will convert all your data to the list, but here you need a page over here. Okay, that you should be getting the page. So whatever the page request that you pass over here, you will be getting the data as a page object over here. So let's check this as well. So we will just call this. Okay, we'll create a new method, public void print find by title containing, and I will just use test over here. Here I'll just say pageable again, first page 10 records. Okay, equals to page request dot off first page and 10 records over here. Now what I need a list of students, list of courses equals to course repository dot find by title containing, I'll say containing D, and first page 10 records over here, and here I'll say dot get content. Okay, I did one mistake over here. This should be pageable. Okay, right, now let's go back over here, and here you can see that the error is resolved now. Let's print it out. Okay, I'm printing the list of courses available with the first 10 records of the first page, and we are just getting the title who's containing capital D. So if I go over here, how many capital D, how many records you should get is DSA and DBA over here. So let's go back and run this over here. And here you can see that we got the records. Okay, we got DSA and we got DBA, nothing else. Okay, so my method is working perfectly fine. So this way you can go ahead and implement paging and sorting using JPA repositories. Now let's implement many-to-many relationship. So with this particular image, we implemented course and course material, that is one-to-one relationship, teacher and course, that is many-to-one and one-to-many relationship. The last one is student and course. The student and course have many-to-many relationship. Many students can opt for many courses available over here. So we already have a student class and a course class over here. Now we have to implement the many-to-many relationship. How many-to-many relationship works is, we already have a student class, we already have a course class over here. Okay, two classes are already created. Now when you implement a many-to-many relationship, there has to be a third new table added to it that represents the mapping between the two tables, that is a student and course. You have a student, you have a course, and there will be a third table that represents this particular student ID to this particular course ID. So multiple student can have multiple course ID, so that particular table will hold the relationship between the two entities that we have. Okay, so there is a third table, new table will be introduced for many-to-many relationship. In the earlier, in one-to-one and one-to-many or many-to-one relationship, there are only two tables associated always and a foreign key was assigned. But here, third table will be introduced over here. So let's go ahead and implement that. We'll go to the IntelliJ IDEA and we go to the courses over here. This particular course is, here we need to add the many-to-many relationship. We already added one-to-one, many-to-one relationship. Here we need to add the other relationship, many-to-many, for the students that we have. As a particular course can be opted by multiple students, so we need to have a list of students available over here, right? So I'll just define private list of students available over here. Now for this particular, we need to define many-to-many mapping over here. Now as for this particular many-to-many relationship, as I told that there has to be new table created, we need to use the join table annotation over here. You can see earlier we used to just use join column annotation. Here we will use join table. So I'll just use join table annotation over here. And in this particular join table annotation, we need to define what will be the join table, what will be the new table, and which two particular column that we are going to refer over here. So let's add those information. So here I'll just define what will be the name of a table. So I'll just say student course mapping over here. And here I'll define what will the join column equals to @join column over here. And for this I need to define what will be the name and what would be the reference column name over here. So what I need to refer to what for this particular student, I need to refer to the course ID. Okay. So whatever the course ID is available over here, that would be the reference column. And what would be the name of the column that I want to define? That is course underscore ID. Okay. This would be your database, what you want to define, and this would be your class property that you have already defined over here. Now this is the joining column that you defined for your student, that is your student will be having the courses. Now you need to define the inverse join column as well, that for your courses what should be for the student. So I'll just define inverse join column equals to @join column. What would be the name? What would be the reference column name? And this would be for your students. So if you go to the students, this student ID would be your reference column name over here. And your table name, your column name should be student ID. Okay, so what we defined over here, that for this particular course and for this particular students that we have, we are creating a new table that is called student underscore course underscore map, that will have two columns, that is course ID and the other is student ID. This course ID will refer to the course ID of this particular class, and inverse column join. Okay, that is whatever I need to define for this student over here. Okay, so whatever you defined over here, the list available for many to many mapping, that would be for your inverse join columns. Okay, so I need my column name as a student underscore ID, and it refers to the student ID of this particular class that I have defined over here. It's really simple to understand, just it looks complicated. Okay, it's really simple. You just define the new table that contains the mapping between the two already created table for many to many mapping, that is a student and a course you have. And as multiple students can opt for multiple courses, you need to normalize those tables to remove the redundancy, and for that you created a new table. That new table contains the mapping between your course and a student. Simple. So this is the definition that we have provided for many to many mapping. That's it. As is a list of students, I already told you earlier as well, when you are working with a list, you can create one more method to add the letter to that particular list. So let me just create a method. I'll just say public add students. Okay, this will take student object, and if students equal to null, students equals to new array list. Okay, else directly I can say students dot add student. Now let's go ahead and test this particular thing out. Okay, let me start the particular application. Okay, and here you can see that if you see create table, student course map is created, where we have two different IDs, that is a course ID and a student ID, two columns available, and it refers to the two different foreign keys. That is a student course map refers to the foreign key of a student ID and a course ID over here. And if you go to the database, if you refresh it over here, you can see that student course map is created over here. So let's try this out. So in the course repository test over here, course repository test over here, let's implement one method. Okay, public save. What we'll try to do is we will try to save a course with a student available. Okay, save course with student and teacher. Public void @test course equals to course dot builder dot build dot course title. What's the course title? I'll just say AI dot credit. What would be the credit? I'll just say 12. Okay. Dot, I need to add the teacher as well. So suppose I already have a teacher, or let's create a new teacher as well. So I'll just say teacher equals to teacher.builder.build, teacher first name Lizzie dot last name Morgan. This is the teacher. Now let's add the students as well. Okay, here I can add the students. Okay, so what I can do, let's create a student as well. Student equals to student dot builder dot build dot first name Abhishek, last name Singh dot email abhishek@gmail.com. Do I need to add guardian? If I don't add, that's fine. I don't want to add it now. This is the student. I can add multiple student as well, but let's add one student only. Okay, so I just added the student as well. So I just created my entire course object. Let's do course repository dot save course as well. So we just created teacher, student, and we just added all the details in our course as well. So let's run this out. Let's see what's happening over here. Okay, and there is an error. That's good. You can see that invalid data access API usage exception, right? Because you can see that transient object exception is there. Why? Because we added the student over here and we have not defined the cascading type. Okay, so let's go back to the course over here, and for this particular students in many-to-many mapping, we can define the cascade type as cascade type.all for now. Now let's go back and let's run this again. Yeah, you can see that it is successful. Okay, and if you come over here, you can see that there is an insert into teacher, insert into course, insert into student as well, and insert into course student map as well. Okay, so let's go and check our records as well. So we added the new course, right? So this is a new course, that is AI. Okay, this AI has been taught by who? Teacher ID 4. So if you go to the teachers, and teacher ID 4 is Lizzie Morgan, that is ID 4. Now which particular student, right? If you go to the student as well, a new student was added, that is Abhishek. Okay, now if you go to the student course map over here, there will be mapping which particular course is been added by which particular student is taking that particular course. Student ID 3, that is Abhishek, is taking the course 7 over here. Okay, so there will be a multiple mappings this way. This will be a many-to-many mapping handled by the third table, that is a joining table over here. So this is a many-to-many relationship in JPA. So here you can see that we have covered a lot of things over here. We covered all the relationships like one-to-one, one-to-many, many-to-one, and many-to-many relationships. We did paging and sorting as well, how to get the data in the pagination form and in the sorted form as well. We also implemented the native queries and JPL queries as well. And we also implemented the named parameters. We also went ahead and saw how to do transactional and how to do the modifiable queries as well using the JPA repositories. So there is a lot of things that we have covered, and if you have any questions related to any of the topic that we have covered, then do let me know in the comment section below. I will try to resolve your issues as soon as possible. Now as you have gone through everything over here, you will be able to create all the particular different operations and handle everything using this particular JPA itself. Now there is an advanced thing also available using the default entity manager as well, that you can go through the documentation and you can create the entity manager object, and you can also do the custom method implementation as well. Here you can see that we did everything using the interface, but you want to do the implementation, custom implementation for all those particular methods, that also you can go ahead and do that. But ideally if you're using JPA, this is my preferred choice as well, because this will reduce a lot of coding efforts, and a standard implementation is given by JPS. So all the particular implementation what has been done, that's a standard format, it's well implemented, and we just have to use those particular methods. So we'll be getting a really good performance as well over here. So security is a very important part of the application that we develop. So whatever the user is using your application, that user has to be authenticated and authorized to use your application. So it's a very key feature of your application. So in this video, we are going to learn about the Spring Security, how we can allow the user to register to your system with an entire complete flow, and how to let your user to log into your system using Spring Security, Auth2 and OpenID. So in this video, what we are going to do today is we are going to create a complete registration flow with login functionality for a user. So we'll start with creating the functionality of registration where user can register to the system using the REST APIs. We are going to create the REST APIs only today, and the same thing that you can implement in your UI application as well. So we'll create a REST API for a user to register to your system, where we will take the first name, last name, email ID, password, confirm password and all those details, and user will try to register to your system. And when user register to your system, user will get an email to confirm that email, to confirm the account, that the details that a user has entered are correct or not. So that particular thing we are going to mimic it today. Once the user confirms its email address, we will be activating the user. We will also add the functionality if the user has forgot the password. So we'll create an API where user can reset the password as well. At that particular time, what we will do, we will confirm its email, that whatever the email a user is entering, if that email is correct and it's available in our system, then we'll send an email with the reset token to change the password. We'll also create the functionality to change the password, where a user will enter its email ID, old password and the new password, and we'll validate the old password and email ID is correct. Then we will be able to change the password as well. And we will also allow the user to log into the system with the registration process the user has completed. So whatever the details user has entered in our system, with those credentials, user will be allowed to enter our system using the Auth2 and OpenID. So Auth2 and OpenID are the standards within the industry where everyone is using that. You would have seen everywhere, like login with Gmail, login with Facebook, login with Twitter, GitHub, everywhere, right? So that kind of implementation we are going to do today with our custom authorization server. So these are all the fundamentals of security, and we are going to implement today. Now, as we talked that we are going to implement a complete registration process with the login functionality with Spring Boot, let's go to the IntelliJ IDEA and let's create a simple Maven project, and in that we will be adding our different modules for registration and authorization server and whatever we are going to implement. So let's fire up the IntelliJ IDEA. Okay, I'll go to the Maven project, click on next. Let me create the folder, documents, Java workspace, Spring Security tutorial. I'll open it, and this is the project that I'm going to create. Let me add the coordinates, com.daily code, buffer, artifact as Spring Security tutorial, version as this, and finish it. So within this, we are going to add our project as a module. So let's create the first project. Let me go to the browser, and here let me go to the start.spring.io. The group ID I'll give as com.daily code buffer, and the artifact I'll give is Spring Security client. I hope the spellings are correct. Client. Yeah, I'll give the package name as client, packaging is jar, Java version is 11, and let's add the dependencies. So I'll add the web dependency, I'll add the Lombok dependency, then I'll add the GPA dependency, then MySQL driver with Spring Web, Lombok, Spring Data JPA and MySQL driver. So I think with this we'll be able to create our application. We will add the Spring Security module later in this video. So let's generate the project and add as a module in our IntelliJ IDEA. So I'm just generating the project over here. I'll go to documents, Java workspace. Okay, now here you can see that the project is showing up. Now let me add the module over here. Okay, inside modules I'll add the module Spring Security client, and I need to change the packaging as POM. Here you can see that my project is showing up, and this is my details. The Spring version I'm using is 2.6.3. Spring Data JP is added. Spring Starter Web is added. MySQL connector is added. Lombok dependency is added. Okay, all the things are added. Let's go to the src main resources and let's change the application.properties to application.yaml. So I'll do refactor rename to YML, and I'll change the property that this should run on server port 8080. Now let's add the another dependency about the MySQL connector and the JPA. What I'm doing is I'm just pasting the details over here. It's pretty simple. Okay, you can see that spring.datasource.url I have mentioned over here. Currently I am using the MySQL in my system, so I have given the path of the MySQL, that is JDBC MySQL localhost 3306, and I'll give the schema name as well. But before that we'll create the schema. Okay, after that I've given the username and password of the my database, and the driver class name I've given spring.jpa.showSQL2, so all the queries will be printed, and Hibernate DDL auto is update, so whenever there is a change in our entities it will be reflected in our database. So this is the standard configuration that we have added in our system. So now let's go to the MySQL and create the schema. So I'll just open the MySQL workbench. Let me connect. So I'll create the new schema and I'll say it's a user registration. Okay, apply the changes, close, and here you can see that the user registration schema is created. I'll use the same in our IntelliJ IDEA. Okay, this is my user registration schema. Now within this particular application we are going to build a complete registration flow first. So for that let's create the different packages that we are going to need. So if we go to the Java, in the client package we'll create the different packages: controller, entity, service, repository, and model. I'll create one more. If any configuration that we have to do, we will add that in the config folder. So these are the standard packages that I have created. Now let's start to build our application. So firstly we'll create the controller, registration controller. Okay, and we'll annotate this with @rest controller annotation. Okay, my controller is ready. Then let me create the entity as well. The entity I'll create as a user entity, and we need to annotate with @entity. Now let's add the different properties as well. So I'll just add private long ID, private string, first name, private string, last name, private string email, private string, password, then private string role. What is the role of a user? Okay, then I'll just add one more: private boolean enabled equals to false. By default the user would be not enabled, disabled. Okay, so these are the fields that I've added. What I'll do, I'll just annotate with @id, and I'll just use generated value strategy equals to generation type dot identity, and I'll use the Lombok to add the getter setters and everything @data annotation. Okay, so my user entity is ready. And one more thing I'll add is in the password I'll just add one validation, that is column length should not be more than 60. Okay, so I'll just do length equals to 60. Okay, so maximum password should be 60 characters. As we are going to use the Bcrypt password encoder, we will be encoding the password in the hash code values using the bcrypt encoder, and we are going to store that password in our database so no one can see the password. So these are the details. Now let's create the service and repository. So first let me create the repository. Within the repository package, I'll just create a Java class and I'll say user repository, and that will be the interface. I'll annotate with @repository, and user repository will extends JPA repository. This JPA repository is of type user and ID is of type long. Okay, now within the service, let's create the service interface and the implementation of that particular service as well. So let me create the class and I'll say it's a user service and it's an interface, and I'll do the implementation for that as well. That is user service implementation. That's a class that will implement user service. Okay, and this will be annotated with service annotation. So my controller is created, my entity is created, repository is created, and my service interface and the service implementation for that interface is also created. So now all the basic classes are created. So now let's go and implement the registration flow. Before that, let's announce the winner of the giveaway of the MX Master 3 mouse, and the winner of the giveaway is whatever the user popped on the screen. So I'll be reaching the user from the comments that they have added in that particular video to get the contact details so I can ship the product to them. So congratulations to the winner, and thank you so much everyone for participating in the giveaway. Now if you are feeling that you have missed out on the giveaway, so don't worry, there will be a lot of giveaways in the future, and if this permits, there will be a bigger giveaways as well. So keep supporting, and thank you everyone for participating, and congratulations to the winner as well. Now let's go to the registration controller and create the REST API. I'll go to the REST controller over here. And here let's create the APIs. Now before adding anything to the registration controller, we need to create a model as well. So let me just first create the model, and I'll just say it's a user model. And here I'll add the same properties that I have added in the user entity. I just need these details. I need password as well. And there should be matching password as well, right? When you are creating the form, you will be adding the matching password as well. Annotate with data, no args constructor and all args constructor. Okay, so my model is ready. So let me go to the registration controller and let's create a method. Public string register user, and this will be @post mapping to slash register user. I'll just keep it register, that would be better. And I'll be taking the request mapping as well. So I'll just take request body, and this request body is nothing but your user model. Now at this point we need the user service object as well, because we are going to call the user service, and from that particular user service we are going to call the repository. So let me just create the object for that. Private user service, and I'll just auto wire it. And I need the user object. The user is com.dailycodebuffer.client.entity. This one. User equals to user service dot, I'll just do register user, and I'll pass the user model. Okay, I'll create the method, create method register user in user service. Okay, I'll go to the implementation and I'll implement the method, and in this particular service I'll need the user repository as well. So let me just create the object for that as well. Okay, and I'll just use @autowired. Now in this particular, let me create the user object. User equals to new user, and all the fields from the user model I'll set to the user. So user dot set email, I'll do user model dot set email, user model dot get email, user dot set first name equal to user model dot get first name, user dot set last name, user model dot get last name, user dot set role, and I'll just do user role, okay, for now. But later we can create this particular thing as a dynamic as well, but currently let's make it simple to understand, because we need to understand the security part more. And user dot set password as user model dot get password. Now one thing to note over here is whatever the user dot set password that we are doing over here, that is the plain simple password that we are getting from the user. But when we set to our database, we need to convert that to the encrypted password. So we need to use the password encoder to encrypt the password before saving to the database. So let's do that first. Now for this particular password, we need to create a config. So let me just create a new Java class and I'll just say web security config. And for now, I'll just annotate with @configuration, and I need the password encoder. So what I'll do, I'll just say password encoder. So to use that particular password encoder, we can see that we are not getting the class, so we need to add the Spring Security to our project. So let's go ahead and add the Spring Security. So let's go to the pom.xml file. Let me go to the browser. Within this same project, let me add the security. Okay, and if I go to the explore, I can take this Spring Boot starter security. Okay, so let me add the dependency, and for the testing purpose you can add this as well. So let me add that dependency as well. So if you want to add the test cases for this, you can add these. Cool, right? So now let's get back to the web security config, and here rather than using the configuration, I can directly use enable web security. Okay, let me remove the imports, and here I can use now password encoder. So I'm not getting the class over here, so let me restart the Maven so I can get it. So what I'll do, I'll just revalidate the cache. So sometimes this kind of issue will happen, so you need to invalidate the cache and restart the IntelliJ IDEA. So now you can see that I'm getting, right? So I'll just use it and use password encoder, and I'll just do return new bcrypt password encoder, and I'll just use the strength as 11, and I'll define this as a bean so I can auto wire it. So if I go to my user service IMPL, here I can use it. I can use private password encoder, and I can auto wire it. Okay, and now when we are saving the password over here, before that we'll just use password encoder dot encode. So this password will be encoded over here, and then once everything is set, user repository dot save user, and we will return back the user. Simple, right? So user service implementation is done. Now let's go back to the controller, and here what I'll do, I'll just return success. Okay, so you can see that the one part is done, that whenever user will try to register to the system, the data will be saved to the database and the user will be disabled in the starting. Now we need to send the email to the user, so that with a particular link, so that user can click on that particular link and the user can be activated. So that's the standard process, right? So for that, what we have to do is we have to create the event for it, because that's the other task that you are doing. The particular process that you are doing over here, that should not take the extra time for that. Okay, so what we'll do, we will just separate out the process. We'll create one event, and that particular event will handle to create the particular email and send the email to the user. So that's what we are going to do. But if you want to test out till this particular flow, you will be able to test it out, and the user will be saved to the database with the disabled as a status. So here what we'll do to send an email and to separate out the process from this flow, we will create the event. So let me just create the object of the event. We will be using the application event. So we'll just define private application event publisher and I'll auto wire it. Now once we get the user is saved to the database, we can create the event. So at this particular point I can say publisher dot publish event. Okay, and now here you can see that this particular publish event is taking the application event as the input parameter. So we need to create the event that we want to publish. So let's create the event. So for that, let me just create the event package over here. Okay, within this event package, I'll create the Java class and I'll say this is the registration complete event, which will extends application event. We need to create a matching constructor for the super. Okay, so let me just create it, and here we'll be taking the user object, user, and I'll be also taking one string as the application URL. Cool, right? So here you can see that the event is created. Now I want to have this two particular field as well. So let me just do one thing. I'll just say private user, and I'll just say private string. I'll copy this application URL as well. Now this particular application URL is nothing but a URL that we have to create for a user when we send the email to click on it. Okay, so that's the thing. And from here, this dot user equals to user, and this dot application URL equals to application URL. Okay, now my event is created. Now I can publish this event. So if I go back to the registration controller, I can create the new registration complete event. Okay, and here I need to pass user object first, and then I need to pass the URL. So let me just keep a string for now, but later we will create we will build the URL. Okay, so this particular part is complete. Now we just publish the event. We need to listen that particular event and we have to do something on it. Okay, so let's create the listener for that particular event that we have created, that is the registration complete event. So I'll go to this particular entity package, and within this I'll just create one more package. This will be list in your listener, and within this listener let me just create the Java class, that is registration complete event listener. Okay, and this particular class will implements application listener. Okay, and this particular listener is of which type? That is the registration complete event, and we need to implement the method. So let's do that. Okay, so this is the implementation part. Now at this part, what we'll do, we'll create the verification token for the user. Okay, so whatever the token will create and will attach to the link, so that when a user clicks, the user will redirect back to the application. Okay, with link. So we'll create a link over here, and once the link is created, we can send mail to user. That's the two things that we are going to do over here. So let's get the user now. User equals to, we'll get the user from the event. So we'll do event dot get user. So when we go to the registration complete event, here we will add the getters and setters. Okay, because I just need the getters and setters. So let me go back to the registration over here, and I'll just use the get user, and I also need string token equals to, and the token I'll just create as a uuid dot random uuid dot toString. Now whatever this particular token is, right, that particular token we can save for a particular user, so that whenever a link is hit by the user, that particular token and the token that we have in the database, we can match that particular token and then only we will be verifying the user. Okay, so we need to save this token as well. So for that we will create the entity again for it. So let's go ahead and create the entity for it, and for that particular entity we have to attach the user as well. Okay, so I've done the mistake over here that listener I have added in the event. So let me just drag and drop to the event. Okay, now in the entity let me create one more entity, and I'll say this as a verification token. This will be entity and this will be data as well. Add the ID attribute. Okay, and here I'll define one more thing, that is private string, that is token, and private date expiration time. Okay, when that particular token will be expired. So we will generally give about 10 to 15 minutes of time for a token to expire, and we'll also give for which particular user. So we'll do one-to-one mapping for a user over here. So here we'll just define one-to-one mapping, and we'll define fetch equals to fetch type.eager, and we'll do the join column over here. The name of the join column will be name equals to user ID, nullable false, and the name of the foreign key. Foreign key equals to @foreign key, and the name of the foreign key. I'll just do fk underscore user verify token. Okay, let me just reformat the file. Cool, right? We have added the verification token as the entity as well, which will have ID, token, and expiration time. Now from here we need to create the couple of constructors so we can pass the user and token to this particular entity. So let me just create that. Let's create a constructor verification token where we can just pass the user as well and the token. This dot token equals to token, and this dot user equals to user. And one more field that we have is the expiration time. So how that particular expiration time would be calculated. So for that, let's create the method. This dot expiration time equals to calculate expiration date. And here we need to pass some static values. So suppose let's create one static value over here. Private static final int expiration time. Okay, so I am going with the 10 minutes of time. Okay, expiration time as 10 minutes. So this is something that I'll pass over here, that this is the expiration time. And let me create the method. So I'll use calendar equals to calendar.getInstance, calendar.setTime in millis, and we'll pass the new date dot-getTime. Now with this we will add some time, calendar.add, and we'll add calendar.minute, and we'll just add expiration time, and we'll just use return new date calendar.getTime. Okay, simple thing. You can see that whatever the expiration time that I'm passing over here, I'm adding to the current time and I'm passing the value over here. So it will be around 10 minutes from the system time. So that will be set over here, and I'll create one more constructor over here, public verification token, where it will just take the token. So if I just want to work with the token, okay, I'll just call the super, and this dot token equals to token, and this dot expiration time equals to calculate expiration time, and I'll just pass the expiry time. Simple, right? And here let me just add the noargs constructor. Okay, so this verification token is created. Now let's get back to the event listener. Now at this particular point you can see that I have got the user and I have got the token as well. Now at this point I can save the token and user to the database. So here as well I will need the user service. So let me create the object for it. Private user service, and I'll just auto wire it, and I'll just say user service dot, I'll just create one method that is save verification token for user, where I'll just pass the token and user. Okay, and I'll create the method. Let's go to the implementation over here, and here I can implement the method that is the save verification token for user. Okay, now here what we'll do, we'll just create the object of verification token equals to new verification token, where we'll pass the user and token. And for this particular verification token as well, we need to have a repository, right? Because we have not created the repository for this. So let's go ahead and create the repository. This repository package, let's create the new interface, and we'll just say verification token repository. Okay, this is the interface, and this will extends JPA repository. This JPA repository is of type verification token and of long, and we'll annotate with repository. Cool, right? Now the repository is created. Let's go to the event listener. This is working fine. Now let's go to the user service IMPL. The verification token is created, and I need the object of verification token repository as well. So I'll just do private verification token repository, and I'll auto wire it. Simple, right? And this I can use over here, that verification token repository dot save verification token. Super simple, right? Now my user and token both are saved to the database. Now at this particular point I need to send email to the user. Now what we are doing over here is, to save the time, we are just mimicking that we are sending the email. If you want to actually send the email, I have created a dedicated video on Spring Boot where I am showing you how to send the email from the any of the email client. That is will be in that particular video we are using the Gmail to send the emails, so that you can implement over here. But here we are just mimicking that we are sending the email, and we are printing that email in the console, so we can get the URL and we can use that particular URL to verify. So now let's get back to the registration event listener, and here you can see that create the verification token for the user with link. This particular part is created. We need to create the link now, and we need to send the email. That particular part is remaining. So let's implement that. So here I'm creating the URL, string URL equals to event dot get application URL. So this particular application URL, we have not yet implemented the particular method to create the application URL, but we will implement, and we are hoping, or we are assuming that we will be getting the application URL to the context path. Okay, and then we can add the path from there. So from here I'll just append the path, and here I'll just pass it plus verify registration. So this is some path that we are going to implement. Registration, verify registration, and I'll be passing the token equals to plus token. Simple. You can see that this URL will have the application URL, that will be your context URL, plus, so this is some API that I'll be creating, that is the verify registration, and as the parameter I'm passing the entire token. Okay, let me use the SLF4j over here to print the logger, and I'll just print log.info, and I'll print over here is click the link to verify your account. Okay, and here I'll pass the URL. I think this is pretty simple, that we are passing the verify registration, that one endpoint, this endpoint we are still going to implement, and we are passing the token over here, and we are just mimicking that this is the email. But ideally this is where you will send the email. You can create the send verification email method over here. You can pass the details and you can implement it over here. Okay, so this is the mocking that we are doing over here. Now the application URL. So this application URL we are passing from the registration controller, right, at this particular point. So let's mimic this URL. Let's create the URL. So for creating the URL and to get the context of the URL, you will need the HTTP request. So let me just inject that. I'll just use final HTTP servlet request, and here I'll create one method application URL, and here I'll pass the request, and let me create the method, and from here we can create the URL. Return HTTP plus request dot get server name plus colon plus request dot get server port plus request dot get context path. Okay, so this is a simple method where it's returning the path. Now this particular flow, you can see that it will come over here when we are going to register. It will pass the user model where it will have the first name, last name, email ID, password over here. We are going to pass from the response body, means from the as a part of a JSON, and it will save the user over here. We'll get the user back, and we will create one event where that particular event will send the token to the user in form of an email, and that particular email can be used to verify the user. Okay, that's standard flow that we are going over here. So everything is implemented, I guess. Let's re-verify. Okay, cool. So let's start the server. Okay, your server is started. Now one thing to note over here is when we go to the browser, okay, and when we go to the localhost 8080, and here you can see that we are by default getting a sign-in page, and this particular sign-in page is from the Spring security that we have added the dependency. Okay, and currently there is no user or there is no extra configuration that we have done that Spring security will understand. So what Spring security is doing, that it is giving the password as well. You can see that this is the password that we can use, and the default user is the user to log into the system. That's what we can do over here, but we do not want to use that. We need our custom implementation. So that is something that we are going to implement. But for this particular API, right, currently whatever the API that we are using, that particular API is also protected. So that API we need to bypass. Like when we want to register, it is not necessary to log into the system, right, because we want to create the user. So there will be some whitelisted APIs or whitelisted URLs that we want to bypass, and for rest of them we need to enable it. So that is something that we have to implement. Okay, that is some configuration that we have to do. Currently we won't be able to log in directly or use any of the API directly. So let me add the configuration for that. So we are going to implement a security filter chain over here. Security filter chain, and this will be the bean that will be defining, and this will be taking HTTP security as the input parameter. We'll be injecting HTTP security, and now we can do something on the HTTP. So what we'll do with this HTTP, we will disable the CORS and dot CSRF dot disabled. Okay, so we are just disabling the thing over here, and it requires the exception. So I'll just add in the method signature. So I am telling that there will be some APIs that you need to handle, and this all the APIs I need to permit. Okay, what will be the APIs I'll define over here. So let me just define private static final whitelist URLs, and this is string of array. And which are the URLs? I can define, okay, this is hello. I can define /hello. I can define one more, that is the registration controller /register. Okay, and I'll define over here that whitelist URLs. So this should be permitted all. So any URLs which have this pattern will be whitelisted. Okay, will be permitted. And I'll just do return http.build. So this is a simple security that I have defined over here, that I'm just disabling the CORS and CSRF so I can do post requests and everything for now. And I'm allowing all this particular URLs, whatever I have defined over here. So in the future, whatever the other URLs that we are going to build, that will be protected behind the security that will be defining later. So let's start the server again. And here you can see that the application started. And if I go back, and here you can see that I am able to directly call the hello API, right? So one thing is working fine. Now the same way register one we can use using the postman. So from the postman, let's try to register one user. And before that, if you go to our database, let me refresh all, and within this user registration, you can see that the tables are created, that is the user and the verification token. Okay, currently we see there should not be any data. Okay, there is no data in either of those table. Now let's go back to the IntelliJ IDEA, and this is something register that we have to call, right? So let me open postman. Okay, let me create the new request over here. This will be the post request, and http localhost :8080/register is the URL. Let me reconfirm. We'll go to the registration controller. Register is the URL, and we are going to use the input parameter over here, that is the first name, last name, and everything. So let's define in the body raw binary JSON, and let's define I'll define first name, last name, password, and email. Okay, first name is Shabir, last name is Daudi, password I'll give 12345667, and shabir@gmail.com. Simple, right? So these are the details that I'm passing over here. And if I click on send, you can see that I am getting the response success over here. Okay, and if I go to the database, hit on user, you can see that I'm getting the email, first name, last name, and password. You can see that it's encrypted using the bcrypt. My role is user and enabled is 0, so it's false now. And if I go to the token, you can see that the token is not created, so there is some issue. So let's check. So if you go to the, so you can see that the user entry was inserted over here. Okay, but the verification code was not inserted. The issue I can see over here is this is not a component yet, right? So Spring doesn't know about this yet. So let me just add this as a component. So Spring knows about this, and this will be executed. So let's restart the server. Okay, server is restarted. Now let's go to the MySQL, and let me just delete this. Okay, so no records now. Okay, and let me go back to the postman, and from here let's hit send. Okay, success. If I go back to the MySQL, user is there, verification code is also there, so my event is also working fine. You can see that the token is created, user ID 2, and all the details. Now if I go to the IntelliJ IDEA, here you can see that the event is created and the link is also there, like click the link to verify your account, and this is the link. And we forgot something over here, that is the /, right? So we will add that / over here, and the token is this particular token. So you can see that we are able to create the link, and this is something that you will be sending the user in the email, but we are just mimicking over here. Now we need to handle this verify registration. Like whenever a user is clicking on this particular URL, when there is a verify registration, we need to take this token, and that particular token needs to match with the token that we have within that time frame, right? So if a particular user is doing after 10 minutes, then we need to define that token is expired. And if it's not, if token is valid and within the time frame interval, we should be validated and we should be activating the user. So that's what we are going to do. So let's first correct this URL. After 880 we will add the slash, and then we will implement this verify registration API. So here we'll define this. Okay, and now what we'll do, we'll go to the registration controller. There is one post mapping, right? So we'll create one more. Okay, here let's define public string verify registration, and this is the get mapping, where we will define the slash verify registration, and there will be one token. So I'll just define, there will be a request param token, and the request param name is also token, and I'm defining over here string result equals to user service dot verify. Instead of verify, we'll just say validate verification token, and here we'll pass the token. Okay, and here I'm defining if result dot equals ignore case valid, I'll be passing valid or invalid from the method. So if it's valid, return user verified successfully, else return bad user. Okay, simple thing. Now let's implement this method. Let's create the method in user service, and let's implement the method. This is in the user service implementation class. Now here we need verification token. Verification token equals to verification token repository dot find by token, and I'll just pass the token. Okay, and this particular method we need to implement. So let me just create the method find by token. It will take the token as the input parameter, and it will pass the verification token. Here we got the token. Now if verification token equals to null, then just return invalid token. Now after this, I need to get the user from the verification token, and I need to check the expiration time as well. So let me just do that. I'll just do user equals to verification token dot get user. I'll create the calendar object equals to calendar dot get instance. Now I need to check something over here. If verification token dot get expiration time dot get time minus cal dot get time dot get time is less than equal to 0. So you can see that the time saved in the database minus current time is less than 0. That means the token is expired. So we need to make that happen, that the token is expired. So let me just format the code. Here we need to make sure that the token is deleted from the repository. So I'll define verify token repository dot delete verification token. Okay, and return expired. So now at this particular point we have verified that the token is also valid and it is not expired as well. So we need to do user dot set enabled as true. We are enabling the user and we are saving user repository dot save user back, and we are returning valid. So yeah, you can see that it's very simple, right? We are just checking that whatever the token that we are getting, that token exists in the database or not. If not, it's an invalid token. If so, we are getting the user, and with that particular user we are getting the calendar instance, and we are checking the expiration time. If that particular expiration time exceeds, then we are deleting the token and we are just telling that it is expired. Otherwise, we are enabling the user and we are saving back to the repository. So we'll go back to the registration controller, and you can see that the complete flow is done, right? Now let's restart the application. Okay, application is restarted. Now let's go to the database. Okay, let's delete everything so we can see better. Let's delete, apply. User deleted. Okay, so there are no users and no tokens available. Now let's go to the Postman and let's create this user. So we'll click on send and the user is created. If you go to the database, the user is there and the token is also there. Okay, so what we are going to do over here is we are going to get this URL. Okay, you can see that the URL is there. So copy URL, we'll go to the browser to verify. Let's go to the browser. Let's verify. And you can see that we are getting user verified successfully. Okay, spelling mistake is there. I'll correct it out. Okay, so if you see over here, if you go to the database, earlier you can see that the enabled flag was 0, so it was disabled. Now if I again requery it, you can see that it is verified successfully. So now user is verified. So this is the complete registration flow. You can see that. We can also check some of the failure scenarios where we can just change the token, and if we hit, you can see that we are getting the bad users. So the token is bad, right? So if we wait for 10 minutes, okay, after 10 minutes if the token is expired, then what it will do is it will delete the token itself. Okay, so this way you can implement the complete registration flow with the token implementation, where you are sending the token and that particular token is been verified in the database. Now once this particular complete flow is done, there might be a scenario where you didn't get the email, or there might be some issue in the server where you didn't receive the email. So you might have seen this everywhere, like there will be a resend functionality, right? Resend token or resend OTP, whatever. So for this particular registration process also, we can implement that particular functionality where when we click on that particular button, it will regenerate the verification token and it will send in our email. So that particular token also we can use to verify. So let's go ahead and create the functionality where we can ask for the regeneration of the verification token, and that particular token we will be using. So let's do that. Let's go to the IntelliJ IDEA and let's implement that functionality. So currently you can see that everything we are doing from the REST APIs. This REST APIs you will be using in your UI application. So let's create the method that is public string resend verification token. Okay, I'll annotate with get mapping and I'll just say resend verify token. Okay, you can give any name, and here what I'll be taking is I'll be taking the old token. Okay, whenever there is a request from the UI to the backend for this re-verification token, send that old token as well. So from that particular old token we can verify. So I'll just take the request param, and this is the token string old token, and I also need the HTTP request to generate the URL again. So HTTP servlet request and request. So here what I'm doing, I'm just creating the object of verification token. Verification token equals to user service dot generate new verification token. Okay, and I'm passing the old token over here. So I'll get the new verification token. So let me just create this method Okay, I'll go to the implementation part and I'll implement the method. Now with this particular verification token, old token, what I'll do, I'll create the object of verification token. Verification token equals to verification token repository dot find by token, and I'll be passing the old token over here. Okay, so if I get the token, what I'll do, I will set the new token, verification token dot set token, where I'll pass the UUID dot random UUID dot toString. So I will just set the new token, and with the help of verification repository I can save the token back to the database and can return the token. Okay, so at this point I'll get the token over here in the controller. So let's go to the controller. Here I'll get the token. Here I'm taking the user out of that. User equals to verification token dot get user. Now at this point again we need to send the email, right? Like this is your new verification token, verify this for your particular user. So we can create one method where we will be sending the email. So we can just say resend verification token mail. Simple method I'm creating where I'm passing the user object and I'm passing the application URL with the request, and I can say to the user that verification link sent. Simple, right? So now let's create the method. So this is the method that I'm going to create. So let me add the code over here. Okay, so for this I'll go to the application event listener and I'll get the URL and this logger message. Go over here, let me paste it. URL equals to, instead of this I'll just directly use the application URL. Okay, verify registration blah blah. Okay, I need the token as well over here, right? So let me just pass the token as well. So what I'll do, I'll pass the token as well, verification token, and I'll update the method. Okay, where it's taking the verification token. Here verification token dot get token. Okay, so here you can see that the URL is created, and click on the link to verify your account. And for the loggers, let's add the SLF4J. So resend verification token email, this is implemented. Ideally you will be sending the email, but to save the time we are just printing out in the loggers. So this is a method where you will be sending the verification token again. So this is also a new API, so let me just handle this in the Spring security. So if I go to the web security config, and here we can add. Okay, now I'm adding currently now, but it will be helpful later. Currently I have permitted everything, so currently there won't be any error, but the list we are maintaining will help us later. Okay, so let me just add for the verify registration as well. So now let's build the application again. Okay, application is started, and let's go to the postman and let's change something. Okay, instead of Shabir I'll just say Nikhil Gupta, password 1234, and I'll just say Nikhil at gmail.com, and we'll click on submit to create a new user. Okay, new user is created, success. Okay, users are there. You can see that the verification token is also created, and you can see the token is starting from 2855C53. Okay, so it's from the 2855. Now if you go to the IntelliJ IDEA, you can see that you are getting the link as well where you can verify. Okay, 2855. But now suppose I didn't receive it. Okay, just assume we didn't receive it, so we need to call that again. So what I'll do, I will call the API again. Okay, so let me just go to the registration controller, and you can see that it's the resend verify token. So instead of verify registration, the same URL, let me just copy it. Okay, copy URL, go to the postman, new request, and instead of resend verified token. This is something we need to change instead of verify registration. Okay, so what it will do is it will try to check this particular token. If this particular token exists in the database, okay, that at that time what it will do, it will replace with a new token and we will get a new token. Okay, so let's hit this URL. You can see that we are getting the verification link sent, and if we check the database, the earlier token was 2855. If I hit the query again, you can see that the new token is generated and the token is 41723, something like that, and the same link would be generated here as well. You can see that the link is generated, verify registration token is the new one. And when we copy this URL, go to the postman, new, okay, and we can click on send, and you can see that user verified successfully. Okay, so my complete flow is working, where we are registering the user, we are verifying the token, and if we didn't get the token, we can ask to resend the token as well. That is also completely working fine. Cool, right? Now what we are going to do is we are going to implement the functionality of the reset password, because if we forget the password at the time of login, we need to reset the password, right? That also will be implemented using this particular token flow with the email, and later we will be implementing the change password as well. Now we'll create one method where user can click on reset password and user will get an email with a link, just like the way we have created all this, right? It will be a link where when we click on that particular link, it will be to add the new password, and that particular new password will be saved. Okay, just imagine that you are clicking on the link and you are getting the page, but here we are going with the REST API. So we'll be creating a REST API where we will be getting the new passwords and token and email ID, and based on that we will be saving or we will be updating the password over here. So let's create a method that it will create a link for a user to reset the password. Okay, so let's do that. So we'll create a method over here, public string reset password @post mapping, and I'll say reset password. Here we'll be taking the request body and we'll be taking one object. So let's create one object. Let's go to the model and I'll create a class password model. Let me annotate with data private string email. Okay, currently let me just add this. Later when we need any other details, we will add the details in this password model. Let's go back to the controller. In the request body, we will be taking password model over here, and let's implement the functionality here. Okay, so here what will be, user will be passing the email ID with which they have created the account, and we will validate if that particular email ID is present in our system. Then with that particular email ID, we will be creating a new password token and we will send that token to the user over email. With that token, we will again validate and we will ask them to reset the password. Okay, so let's do that. We'll do user equals to user service dot find user by email, and we'll pass password model dot get email. Okay, let's create the method. Let's implement the method as well, and here we will return user repository dot find by email, and we'll pass the email. Okay, and this particular method that we have to add in the repository. So let's create the method. It will return the user based on the email that we are providing. Okay, now here I'll be getting the user. Okay, and here we'll check if user not equals to null. Now we got that user particular, right? If user is not null, then I can create a new token and save the token for the password reset. So let me just create the token. String token equals to uuid dot random uuid dot toString, and we'll call the user service dot create password reset token for user, where we'll pass the user and token. Simple, right? And let's create the method and we'll implement this method as well. Now for the password reset token as well, we need to create the entity. The similar thing we will do as we had done for the verification token. So let me just create the entity. I'll go to the entity package and create the new password token. I'll just name password reset token. Okay, I'll go to the verification token. I'll copy everything from here, and the password reset token I will add all the details, and I'll change the constructors, and I'll annotate it with entity data and nox constructor. Okay, so let's do that as well. Entity @data and @nox constructor, and we'll change the foreign key as fk user password token. Okay, super simple. We just created the similar thing for the password reset token as we had done for the verification token. Now let's go back to the user service IMPL, and in this method let's create the object of password reset token. Now for this password reset token we need to have the repository. So let's create the repository. For that we'll go to the repository section. Let's create the new Java class. It should be interface password reset token repository, and this extends JPA repository, and this JPA repository is of type password reset token and ID is of type long, and we need to annotate with @repository. Cool, right? Now let's go back to the user service IMPL. We created the password reset token, and now we need to add the password reset repository over here. Private password reset token repository, and we'll auto wire it, and this repository will use to save the data. Password reset token repository dot save password reset token. Simple, right? Now let's go back to the registration controller. At this particular point your password token is set. Now you need a URL. Let's create the URL so that we can hit that URL to reset the token. So I'll just define the URL. Okay, string URL, and for the URL we will create one method password reset token mail, similar to what we did for the recent verification token email, where we'll pass the user object, and for the application URL we will pass the application URL where we need the request. So let's inject the HTTP request as well. Okay, we'll pass the request and we'll pass the token as well. Let's create the method. Let me refactor this method. The name password reset token mail. Okay, now here what I need, the similar thing, I'll just copy this and I'll paste over here. I'll just use the token over here, and here instead of verify registration I'll just say save password. Okay, this is the link that I am creating, and click the link below to reset your password. Cool, right? And this URL we will return from here. Now when you click on this URL you will be redirected to enter your new password, right? New password, and the confirm your new password. So at that particular time we will be needing more details to save the password. So let's create a method to save that particular password. So here when you click on reset, here you will get a link. When you click on the link you will pass more details to save the password. Now this particular save password we will create public string save password. Okay, this is post mapping, and I will give the same thing, save password. Okay, here you can see that it is taking the token as the request parameter. So let's add that @request param token, which is string token, and it will also take the extra data as a JSON format, right? Like your new password and the email ID, whatever it is. So for that, I will just use this particular password model as a request body. So let me just add it below over here, @request body password model. Super simple, right? Now here we need to verify the token and we need to save the details. So first let's verify the token. String result equals to user service dot validate password reset token, and we'll pass the token, and let's create this method. We'll go to the implementation and we'll implement this method, and here it will be similar to what we have done earlier to verify this token, right? So I'll just copy this information from here. I'll paste it, and I need to change some details. Instead of verification token, it would be password reset token, and here I'll refactor the name password reset token, and this find by token we need to create. So let's create this method. If we go to the user, this should be password reset token repository, and this we need to change. We need to implement this. So let me just add the method. Okay, in the password reset token repository. Okay, now we are checking if password reset token equal to null, invalid. We are getting the user from the password reset token. We are getting the calendar instance password reset token dot expiry time and all. And here we need to use the password reset token repository, delete password, expired, and okay, and I don't need these details, so let me just remove that. Simple thing, we are just validating the password reset token. If token is not available in the database, it's an invalid token. If token is expired, then it will be expired, otherwise it's an invalid token. Okay, let's go back to the registration controller, and here we will get the valid now. And here we will check if results dot equals ignore case valid, and I'll negate this sentence. If it's not valid, then I'll just return invalid token, okay, or expired token, whatever. Now at this particular point my token is valid. Okay, so I need to update the password. So for that I'll go to the password model first, and let's add few fields: private string, old password, and private string new password. Okay, these three fields. Now let me implement optional user. Okay, user equals to user service dot get user by password reset token. Whatever the token is, based on that I need the user back, so I can change the password. So here I'll just pass the token, and let's implement this method. Let's go to the implementation and implement this method, and here we will pass return optional dot nullable. Okay, optional dot off nullable. We will do password reset token repository dot find by token. We'll pass the token dot get user. Simple, right? We are getting the user from this token. Now let's go back to the controller. Now here we need to check if user dot is present, do something, else do something. So if user is present, we need to change the password, else invalid token. And here I'll just say password change, not password change, password reset successful. Okay. And here we need to change the password, set the password. So we need to call that method. So here what I'll do, I'll just say user service dot change password. And here I'll just pass user dot get and password. So I'll just do password model dot get new password. Let's implement this method. We'll implement the method, and here we'll just do user dot set password encoder dot encode new password and user repository dot save user. Password is saved now. So now here you can see that we created two APIs to reset the password and then to save the password. So now let's restart our application and let's test this functionality. Return statement is missing. Let's handle that. Password reset token email. Return URL. Let's run it again. And here you can see that your application is started, and you can see that your new table is also created for the password reset token. If you go to the MySQL, let's refresh everything, and here you can see that your password reset token is also created. Okay, cool. Now what I'll do, I will try to reset the password for this particular user, that is Nikhil. Okay, currently you can see that the password is something like this, which is GEMVN, something like this. Okay, so we'll change the password. So what is the URL that we have to create? Let's go back, and to reset the password we need to call the reset password, and in the body we need to pass the email ID. Okay, so we'll do that. Let's go to the Postman. Let's close this get request and let's copy this post request. Reset password, will copy this and paste over here. Go to the body, raw JSON, and we'll copy the email from the database itself. So let's copy the email. Okay, sorry. Okay, so for this particular user, when we hit on send, I should get a URL, and with that particular URL, if I pass more data, that is my password, then I should be able to change the password. Currently there is no reset password token over here. Okay, so if I click on send, you can see that I got the URL, that is save password, and this is the token. And if I check the data, you can see that I have a token available, okay, for my user. Now I need to use this in my new URL. This is also a post request, and in the body save password, I'm getting the token as well, and in the body I must get the token that I'm passing, okay, and I must get the new password as well. So let's do that. So the token I'm providing over here from the parameter itself. For the body, let me go to the binary raw text to JSON, and here let me pass the new password. The new password I am passing is 123. Okay, simple thing. I'm passing the token, new password, and I should be able to save. Let me just check that the new password attribute is correct. New password I'll just copy from here. Okay, now hit on send. You can see that password reset successfully. Okay, and if I go to the database, current password, you can see that it's starting from GEMVN. Okay, this is some password, encrypted password, and let's requery it, and you can see that the password is changed successfully. So your token also was verified and the new password was set successfully. So this way you can do the reset password verification flow in your application. Now let's do the change password flow. So let me go back to the IntelliJ IDEA, go back to the registration controller, and the same way you did for the save password, you will do for the change password, where in the change password we will get more information. What is the email ID? Because earlier we verified the user based on the token that we created. Now we need to verify the user based on the email ID, the logged in user itself. And then we need to get the old password. If we are able to match the old password with a particular user, then only we will update with the new password. That's the logic, right? So let's create one more API, public string change password. Okay, and here I'll do the post mapping and I'll just say change password. And in the input parameter, I'll take the request body itself. The request body is again password model. And we need to find the user by email. So I'll just do user equals to user service dot find user by email, and I'll just pass password model dot get email. Okay, we had already created this find user by email method, so we are using the same. Now we got the user. Now if user is there, then we need to check the old password. So whatever the old password is entered, that particular password should match with the password in the database. So let's check that. If user service dot check if valid old password, and here I'll just pass the user object and password model dot get old password, then do some if condition, if operation. Okay, so if the password is valid, then we can change to the new password, and I'll completely negate this. If so, return invalid old password. If this is all good, then I'll just say save new password functionality will implement, and after that return password change successfully. Okay, now let's implement this check if valid old password. So let me just create the method. Let me implement this method in the user service IMPL, and here we'll just do return password encoder dot matches, and here this particular matches will take the old password, that is the password that we are passing, that is the raw password, and the other thing is user dot get password, the encoded password. It will try to match this, the old password, the password which we are passing, and the password which is already stored in the database. If it matches, then all good, otherwise we need to raise the exception. So let's go back to the registration controller. It will come at this particular point. If password is all good, then fine, otherwise throw invalid old password. Now we will implement this save functionality, and here we will just say user service dot change password, will pass the user and will pass the password model dot get new password to save the password. That's it, right? We are just doing a simple thing over here. Whatever the password model, whatever the email ID that we are getting the user from that email ID. We are checking if the old password is correct or not, and after that we are updating to the new password. So let's restart the application and test this. Now let's go to the Postman. Let's create a new API request. Let me just copy this. It's a post request. Instead of reset password, it's a change password. And let me add the body data as well. We'll pass the email. Old password. And we'll pass the new password as well. The email ID I'll pass as is of Nikhil. The old password we set was I think 123, but let me pass 567. And the password I want to set is 789. Okay, so at this particular point I should get the error, right? Because the old password is not correct that I am sending back. So if I hit on send, there is some error. Okay, so let's see what is the error. I'm getting the null pointer exception. Obviously, right? Because this particular user is not available. We need to handle all these particular exceptions. Okay, currently we have not handled all the exceptions, but when we are implementing perfectly, we should be handling all the exceptions. Currently I'm just showing you the way. So let me just copy the email ID correctly. Okay, and if I hit on send, currently you can see that invalid old password I am getting. Now if I give the correct password, that is 123, I should be able to update the password. You can see that password changed successfully. Now the password is 789. So currently you can see that we have successfully implemented the change password functionality as well. Now there are a lot more functionalities that you can implement within the entire registration flow, change password flow and reset password and everything. These are all the foundations that I have shown over here, but there are more advanced things that you can do, like handling the IP address and locations and everything. If you want to check out the article from the Yugen, I'll just mention the link in the description below. I have taken the lot of reference from that. So if you see this, right, the complete registration flow with the help of Spring Security, I have taken a lot of inspiration from here. So you can check out this entire tutorial. It's very in-depth than what I have implemented in this particular video. So you can check out this complete flow and you can implement in your project according to your requirement. I highly recommend this particular article. It's implemented very well. So you can check out this article. I'll link this in the description below. Now from here we can understand the complete registration flow, registration with the email, with the token, with the reset token, verify token, change password, reset password, and all the functionalities we have implemented. Now we need to implement the login functionality. So whatever the users that we have created, right, in our database, we will create a login functionality to validate a particular user and to enter into our system. So now let's implement the login functionality. It's very important. Okay, so before we implement the login functionality, we need to understand about the auth 2.0. So you might have seen this auth 2 implemented at many places. So everywhere you go, you will be seeing this particular buttons to log in with those particular authentication providers. There will be Okta, Auth0 and many things. Okay, so these are all the authentication providers based on the Auth 2.0 standards. Now before we implement anything, we need to understand about the Auth 2.0. So Auth 2.0, which means open authorization, is a standard designed to allow websites or application to access resources, okay, hosted anywhere on behalf of the user. So it's like very simple. If I give you the analogy, I have my mobile phone, okay, and if you want to use my mobile phone, you have to take permission from me to use that particular phone. That's a simple thing. So that's the analogy that we are going to understand from there. So I have my phone, that means I have my resources, I have my APIs. If you want to access it, you need to take the permission from me to use those APIs or to use my mobile phone. Okay, so that's the standard that has been Auth 2.0. So Auth 2.0 is just the authorization protocol and not the authentication. So it only provides the authorization, like you are allowing someone to use your resources. I am just allowing you to use my phone. Okay, simple things. It's just the authorization that you can access this. But what about the authentication? That authentication comes later when you connect OpenID with it. Okay, so Auth 2.0 and OpenID connects together and you will get the complete authentication and authorization working together. Now the other important part of the Auth 2.0 is it is designed primarily as a means of granting access to a set of resources. Suppose you have a set of resources, like if you take the example of a Twitter has its own API. If you want to access those APIs, you need to request for it, right? You will be requesting Twitter to use it, okay? And the Twitter will give you some extra details about authorization, client ID and all those tokens and everything to use those APIs. So it's just like that. And Auth 2.0 uses access tokens. So we will go in detail about the access tokens and how everything works, but this is a basic idea about it. Now in Auth 2.0, these are the basic jargons that you need to understand, because everywhere this will be the thing that we will be talking about, that is the resource owner, client, authorization server and resource server. Entire Auth 2.0 depends on this and you will be implementing this only. Let's understand resource owner. What is resource owner? A user or system that owns the protected resources and can grant access to them. I just give you the example, right? I have my phone and I am the sole owner of that particular phone because it's my phone, okay? And if you want to use it, I can grant you access and you have to ask for me. So that's the resource owner. Now the client. The client is the system that requires access to the protected resources. You, my friend, you are the client because you want to access my phone, right? So a client will need the access from the resource owner. And here you can see that client must hold the appropriate access token. If you want to access my phone, you need to have my password, right? So that is something that the access token will be given to you. So that's the resource owner and the client. Now the next is the authorization server. So this is the server receives requests from the client for access token and issues them upon the successful authentication and consent by the resource owner. So it's something very simple, right? Authorization server what it will do is it will just give you the token on behalf of the request that you are giving. Okay, authorization server is nothing but to authorize your request. It will just check that are you authorized to use that particular resources that you are trying to use, and once the consent for that is given by the owner, resource owner, then authorization server will allow you to use those particular resource. That's a simple thing. And the resource server, a server that protects users' resources and receives access request from the client. It accepts and validates the access token from the client and returns the appropriate resources to it. So it will just try to handle, or it will have all the resources. So it will try to handle all the resources, and if any of the request comes with the proper authorization, with the proper code, then it will allow the client to use those resources. Otherwise it will decline the request. So these are the terms, these are the main terms that we are going to implement. We will be implementing the authorization server, we are going to implement the resource server, and we are going to implement the client. So whatever the application that we are going to build, the APIs that we are going to build, that will be your client. So with that particular client, we will be implementing the authorization server and the resource server. So everything works together and your request will be authenticated. Now if you go back to the IntelliJ idea, if you see here, this is your Spring Security Client. This is your project where you have the different APIs, right? Whatever we have created. So these are the APIs that is your client, and this particular clients, whenever you are doing any requests, you might need the access from the authorization server or the resource server whenever you want to create any of the things. It's simple as that, right? So we have to create the authorization server, and all this authorization will be handled from your database. Okay, if you go to the database, these are the users that we have, right? Shabir and Nikhil currently. So all your authorization will be validated against this particular users. We will be passing the user details. It will handle these user details, and once the users are validated, we will be allowing the resource to use. And the next thing that we have to understand is the scopes. Scopes are important concept because scopes exactly defines what you are allowed to use. Okay, suppose you are not the admin, so you are just the user, then you have only rights to read the data. If you are admin, you have some rights to modify the data as well. So all these particular things are defined based on the scopes of the application. Okay, scopes for the particular user, and all these particular scopes you will have to give the consent to use those particular scopes. So it's very simple. Like if you are going to any of the websites and there is a button to log in with Google, when you hit on that button log in with Google, you will be redirected back to the Google page and where you will be entering your credentials. Once you enter the credentials, you are authenticated by Google, and after that you will be displayed the scopes. Like these are the permissions that your client is asking, right? To read your name, to read your email ID, to read your profile picture. These are the different scopes they have defined. So it's asking the consent from you that a particular client is asking all these particular details from me. And if you hit allow, then only the consent is accepted and the particular client is allowed to use those resources. It's similar thing. So these are scopes. And if you see this particular flow over here, so this is just the abstract flow. There are different particular variations available based on the different grant types, and the flow will be changed accordingly. So the ideal flow would be like you have the client, your application, your user, that is a resource owner, your authorization server, and your resource server, and this is your service APIs entirely on top of the authorization server and the resource server. Whenever application wants to use anything, application will create the authorization request to the user, to the resource owner, like I want to use this particular resources, and user will grant the access. Like you grant the access when you click on the Gmail, right? After login to the Gmail. So you gave the grant, like, okay, you can use those resources to the client. Now client got the consent, like, okay, I am allowed to use those resources. Then client will send that grant to the authorization server. Okay, I got the request. Okay, I got the permission now. Okay, this is the permission. So what authorization server will do is, okay, it will validate. Okay, you got the request, you got the code. Now take this token. So authorization server is giving token back based on the code that we got as the grant. Okay, so now the token is given back to the client after validation. Now with this particular token, the application or the client will hit the server to get the details. So once that particular token is valid, until that particular token is valid, so resource server will allow those requests. If the token is not valid, resource server will not allow those requests. It's a simple flow. This particular things you need to understand, that is the client, resource owner, resource server, and the authorization server. This is how everything will work together. Now we'll go to the application and we will implement the authorization server, and we will connect our client with the authorization server, and we will also create the resource server. So if there is any resources that we have created behind the authorization server, then user can use those. So let's go to the IntelliJ IDEA. Okay, we have one client available, and this particular client has a controller, and you can see that there is one API get mapping /hello. So this particular request should be allowed only if you are logged in. Now let's implement the authorization server. So we need to create the new authorization server application. So let's do that. So now if you want to understand this flow, you can go to the OAuth playground. Okay, OAuth 2.0 playground, this one. Okay, and from here you can understand that particular flow. So here you can see that there are different flows available. There's a different types of implementation that you can do: authentication code, PXE, implicit, device code, OpenID Connect, and anything. Okay, generally authorization code or the OpenID Connect with PXE would be more implemented. So let's try to understand the simple authorization flow. I'll add the link in the description below so you can check this out. I'll go to the authorization flow. And here you can see that it is asking to register a client first. Okay, client means your API from where you're going to access. Okay, before you can begin the flow, you will need to register a client and create a user. Simple thing. So let's register a client. Okay, in order to use the OAuth API, you will need to first register application. If you go through this, right, if you go through this entire flow, you will get a much more understanding about the OAuth 2 flow. So I'll highly recommend you to go through this particular flow as well, so you will get more understanding. So let's register this client. Okay, and here you can see that you got the client registration data. So it's similar to how you will be registering your application to any of the OAuth 2 providers like Google, GitHub, LinkedIn, or whatever. Like whatever the OAuth 2 providers are there, you have to register your application and you will get the client ID, client secret. Let me just open this in a new window, and these are the client registration. So let me just continue and register this client to the OAuth 2. Okay, and here you can see that this is the first flow: build the authorization URL and redirect the user to the authorization server. And currently this way the authorization URL will be built. So your authorization server.com, whatever the authorization server is, /authorize. So /authorize this. So these are the standard APIs. Okay, these are the standard APIs from the OAuth 2.0. Wherever you will be implementing this will be the standard URLs. If you want to modify, you can modify, but these are the standards. And with this authorize, you will be passing more parameters. That is the response type. What type of response type it is? It's code. So because we have started with the authorization code flow, the response type is code. Okay, if for the different flow, this particular value would be different. And you can see the client ID, and client ID equals to client ID that we got, and the redirect URI. This redirect URI is nothing but once the authentication is done, where you want to redirect back. So that particular URI we need to define. And the scope. So these are the scopes that we talked about earlier, like what should be the scope of the access that you want to grant. So that scope, and this particular state, you can see that this state is the parameter. The client will need to store this to use in the next step. Okay, so this state also will be generated. So these are the standard parameters that will be generated to authorize your request. So let's authorize this request against the auth server, and here we need to add our credentials. So these are our credentials. So let me just copy the username, and this is the password. Okay, once we log in, it will be authorized. And here you can see that now it is asking for the consent. Okay, that do you approve or not. So we will approve. And here you can see that verify state parameter. And here you can see that it is checking the earlier state and the current state. After redirection, the states are same. If it matches, then continue. If it doesn't matches, then what is the flow? So you can check both the flows. So let's continue with the it matches, continue. So you can see that once this matches, the next is the exchange the authorization code. So after that, whatever the code we got, right, we need to hit this token URI to get the token. So here you can see that the grant type equals to authorization code. We are passing the client ID, we are passing the client secret. Okay, whatever the client secret it was, we are passing the redirect URI, and also we are passing the code. Okay, whatever the code we got from the above step. So once we hit on go, against this authorization code and all the details, we will get the token, and that is the token that we have to use. So once we click on go, at the end you can see that we got the token. This is the access token for your resources from your client. So you can see that there is a refresh token. The scope is also defined. What is the scope of this token? It's a barrier type. Okay, when it expires. So all this information is there. So you can try for the another flow as well, and you can check it out how everything is working. So this is a general idea how this auth 2 will work, and similarly we will be implementing in our system. So now let's go to the Spring initializer. Okay, start.spring.io, and let's create the authorization server. So let me just add the group ID com.dailycodebuffer, and the artifact I'll give is authorization server. The package name I'll give auth server. Okay, packaging is jar, Java version is 11, and let's add the dependencies. So I'll add the Lombok dependency, I'll add the GPA dependency as we need to connect to the database, I'll add the MySQL driver, I'll add the security, and I'll add the web dependency. So these are the dependencies that I'm adding in my authorization server. So let's generate the project and add in the IntelliJ IDEA. So I'm just generating the project. Let's open in the Finder, unzip it. Let's copy this. We'll go to Documents, Java Workspace, Spring Security, and I'm adding over here. Okay. Now this should be added to the IntelliJ IDEA. And if I go to my parent, that is Spring Security tutorial, let me add the module auth to authorization server. Okay, here you can see that authorization server is imported. I'll be using the services. Now within this authorization server, okay, we need to add one more dependency, that is the authorization server. So let me just go down over here in the dependency section. Let me add the dependency, that is the Spring Security auth 2 authorization server. The version that we are using is 0.2.2. So this will allow us to create the authorization server. Now for this authorization server, let's go to the Java main resources. Let's change the properties files to YAML and let's change the server port, server.port to 9000. Okay, so I'm just changing the port. And for this, as we are going to use the JPA with the same database, I need to add the configuration details for the same. So let me just go to the Spring Security client. I'll go to the resources application.yaml. Let me copy this detail and let me go to application.yaml and paste this. Simple, right? I'm just using the same MySQL localhost 3306 user registration schema. Username password is root, class name provided, and show SQL is equal to true. So all these details are there. Now for this particular authorization server as well, we need to use this user registration and the user flow, right? So we need to have the user entity, user repository, and the user services that we have defined in the Spring Security client to my authorization server as well. Ideally, if there is any duplicate files that you have to use, so you can separate out all those particular files in a separate project and you can use that particular project's dependency in your pom.xml file. You can go ahead that way also, but currently let's directly use those. So in my Java folder, let me create the packages. I'll create the package entity, service, repository, config. So I need the user entity, so let me just copy this and paste it over here. Then I need the user repository, so let me just copy user repository and paste in the user repository. Now in your auth authorization server, we need to implement the custom user detail service. Now user detail service is the default service provided for the users to interact with the Spring Security to check if the user exists or not. So that particular thing we have to customize it to use our database. So we need to create the custom user detail service for that. So let me just create a class that says custom user details service. Custom user detail service, this is the class in the auth authorization server, and this is the service, and we will implement this as a transactional. And this particular custom user detail service will implement user details service. This user details service, you can see that is part of the Spring Security. Okay, and there is a method that we need to implement, that is the load user by username. So whatever the username is, for me the username would be my email ID, whatever that we are using. So with the help of the user ID that we have, we need to load the user from the database and we need to pass back to the Spring Security. So Spring Security can handle that user. This is very important step, okay? Because without implementing this user detail service, Spring Security will not know about the users that we have in the database. So for this reason only, we had added the user and user repository, entity and repository in our application, copied from the client. So let me just create the object of user repository and I'll auto wire it. Okay, now instead of username, I'll just make it as email so we can understand better. So here let's implement it. We need the user object, that is the what we have added in the entity. Okay, so let me just use this daily code buffer auth server dot entity. This user equals to user repository dot find by email. We'll pass the email. Okay, we got the user. Then we will check if user equals to null, then throw new user not found exception, and you can pass no user found. And after that, if so, and now we need to return the user. That user would be of this one, that is the org.springframework.security.core.user details. So this is the user that we need to return back. Okay, and here this particular user needs few details. So let's pass it user dot get email, then user dot get password. Currently I'm passing everything to true, because if you see this, we need to pass username, password, it's enabled. account non-expired, credentials non-expired, account non-locked. So 1 2 3 4 true. This value I can get from the user itself. So user dot is enabled, rest everything to true. Okay, and the last thing it requires is the authorities. Authorities is nothing in the Spring Security that what all things that you are authorized to use the resources. It's just as the scopes. Okay, so let's implement the method for that as well. So I'll just implement get authorities method, and here in this authorities I'll pass the list dot of user dot get roles, and this get authorities, let me just create this method, and this is a collection that extends granted authority. Now we need to create this granted authorities. So let me just create the list of granted authorities. Authorities equals to new array list, and for each string role in roles. Okay, let me just rename to roles. I will need to add the authorities. So authorities dot add a new simple granted authority, si simple granted authority, and I need to pass the role, then return authorities. Okay, so let me just add the new over here. Cool, right? You can see that I thought that we did a lot of things, but it's simple. We just created the custom user detail service and implemented the user detail service, which is very important part of the Spring Security to load the user based on our database. That's the custom implementation. So we injected the user repository, and this is the load user by username method that we have implemented the method, which is taking the email as the input parameter. We got the user from the database. If user is null, then user is not found, exception we thrown. Else we created the user object from this user that we have from the database. So we passed all these details, email, password, enabled everything. Okay, all these details you can pass from the user. You can add all these details in the database. Okay, and we can handle it. And we got the roles, and based on the roles we created the authorities. Okay, so the user is created. So now this particular user will be part of the Spring Security. So whenever we need a user, we'll get directly from you. So your custom user detail service is done. Now comes the other thing, that we need to implement the configuration. We need to add the configuration for our authorization server. So this implementation would be standard for all the authorization servers. So there is a bunch of code where you will be creating the public keys, private keys, and all those stuffs to handle your authorization server, so your clients can connect to it, and the exchange between the authorization code and the token can be happen smoothly. So it's a bunch of standard codes that I'm going to add over here, and I'll try to explain it. So for that, let me create the configuration file. So in the config directory, config package, I'll create the Java class, and I'll say authorization server config. Okay, so this configuration would be basically standard configuration for your authorization server. I'll just add the configuration, and I'll just add proxy bean methods to false. Now there are a bunch of standard implementation that we have to do. So let's add that. We would be needing the password encoder. So I'm just adding the password encoder over here. So now you can see that the bean is not available. So we need to create the bean for it. So let's create the bean for it. So let me go to the custom user detail service itself, and here let me just create the bean. Okay, I'll just use password encoder. I'll just make it a public method. And return new bcrypt password encoder with strength 11, the same thing that we have added in our client as well, and annotate with bean. No fancy stuff. Okay, so now in the authorization server, the error is gone. Now let's add bunch more things. Now we need to add the security filter chain. Okay, so let me just create the bean of it. So here you can see that we have implementing the security filter over here, and we are injecting the HTTP security. So what we want to do for our security, so it's simple stuff. this particular thing, you can see that the auth to authorization server configuration dot apply default security. So we are applying the default security over here. That means that default auth to authorization functionality. So default / authorize API / token API, all those default APIs are there, right? For the auth to, all those default APIs will be defaultly added to our configuration. So that's what we have done over here for our security filter chain. Okay, if you go to this particular class, you can see that this is the apply default security that we are calling, and these are the bunch of default configuration is being added over here. Okay, you can see that all the RSA keys and JWT encoder and everything is been defaultly added over here, and we are calling that apply default security. So all those particular APIs are available for auth to, all those default APIs will be enabled. And then what we are doing for this HTTP, we are using the form login, and we are customizing this form login for the default. So with the default configuration for auth to, everything will be set up with this line of code. Okay, and we have added the highest precedence for this bean to be used. So if you want to configure any of the APIs for the auth to, then this is the place that you have to configure. But I'm going with the defaults. You should go with the defaults unless there is a specific requirement. Okay, so this is the configuration for that. Now, as we saw earlier, every time the clients were getting registered to the authorization server, so here also we need to register the clients. So client registration also we need to enable over here. We need to add the configuration for it. So let me just add the default basic configuration. I'm just copying this code because this is the standard code. Okay, now there is a lot of things in this method, but don't worry, everything is simple. So here you can see that it is registered client repository. So this is the repository that has been provided for all the clients to get registered. Okay, so if you want your custom implementation, you just have to implement this interface. Okay, it has the couple of methods, that is the save, find by ID, find by client ID. That's it. You just need to implement these methods according to your requirement, according to the database that you are using, or according to any of the things that you are using. If you just implement these three methods to get the particular output or particular return type, that's all good. Okay, so currently I have only one client available. Okay, I am using only one client, that is my Spring Security client. This particular Spring Security client I want to register with my authorization server. So that's why I have just added one client statically over here. Ideally you won't be doing this. These are the static configuration. Okay, if you want to do dynamically, like how we saw earlier, you need to use the JDBC registration client or your custom registration client, where you will be getting all those details, or you will be generating all those details and giving to the user who wants to use your authorization server. I know what I want to use because this is my project, this is my client, and for this client there are details that I am using over here, that I am registering over here, and these details I will give to this client. So this client can connect to the authorization server that I have. Okay, so this is a simple thing. I'm creating the object of registered client with random UUID. Okay, and what I'm giving this details, that is the client ID. I'm passing the client ID as the API client, that is the name of my client. So my Spring Security client, this is the name I'll be giving to this Spring Security client. Then I'm giving the client password, that is the client secret. I am encoding the password with the secret. Then client authentication method, so I'm using the client authentication method as the client secret basic. Okay, so whatever the secret information that I am passing over here, with that particular information I'll be able to authenticate my client. These are the grant types that we are allowing. You can see the authorization code, password, refresh tokens. So these are all we are allowing for the client to access through. Then these are the redirect URLs. I will talk about this redirect URLs later. So these are the URLs of your client. So once the authentication or once the authorization is happened from the authorization server, where you want to redirect back. So I want to redirect back to this particular URLs. Now how I got this particular URLs, that I'll tell you like how we got this. These are the standard format URLs that you can define. Okay, so everything I'll tell you later once we implement this, but consider these are the two URLs, redirect URLs. Then I have defined two scopes. Okay, one scope is the OIDC scopes for your OpenID Connect, because we are authenticating as well, and the other scope is read scope, API.read. and then the client settings I have extra added. So what I'm doing is in the client setting is client settings.builder.require authorization consent. So I am enabling the consent over here that my authorization server, this server needs to give the consent back to the client to allow. Okay, so it will have the page of the consent as well. If I don't add it, there won't be consent, the consent will be directly given. And I'm building this particular object. Okay, and I'm using the in-memory registered client repository. So this particular registered client will be in the in-memory itself of this particular authorization server. There is one more default implementation added, that is the JDBC registered client repository. If you want, you can directly use that as well, and if you want, you can create your custom implementation as well. As far as I know, there will be only these two implementation by default provided by the Spring Auth server, because there are a lot of databases and there are a lot of implementations available. So you can always go ahead and implement according to your requirement. If you want to use Mongo, Redis, whatever, Cassandra, whatever you want to use, you can implement this particular repository. You can extend this, implement this repository according to the database that you are using to register your clients. I have one, so this is direct. So this is a code to register my client. We'll come back for this to redirect URLs later, okay? But rest of the things are clear, that we are giving the authorizations and everything, so how to connect my client to this authorization server. Then now the next thing I required is the public and private key configuration. So let's add the code for that. Okay, here you can see that I've just added this information, but this is nothing but the standard configuration for your public private keys. We just have to create one bean for the JWK source, and we're just creating the RSA key over here. This is the standard. You just need to copy paste it and it will work. You don't have to change anything, okay? Until and unless you have to change the algorithm, like which algorithm that you are using to generate the key. That's it. Rest everything you can directly use it. Now you might be wondering from where I got this code. Got this code from the samples shared by the Spring Security team itself. You go to that repository, Spring Security Auth server, all these particular details are there, so you can directly use from there. This is nothing fancy, just directly use it. You don't have to change anything, you don't have to bother about it, okay? Now the next configuration that you have to do is the provider setting. So provider setting is nothing but the authentication or your authorization provider, auth server provider. So these are the bean configuration for that. So here you can see that I have just defined a bean for the provider settings. Okay, you can see that there are a lot of information, a lot of changes that you can do. We have just defined the issuer. You can change the authorization endpoint, token endpoint, JWK set endpoint. So if you want to configure any of the endpoints over here, you can configure the endpoints. Okay, but by default, the standard endpoints you will get. These are the beans that I have provided. Now you can see that the issuer I have provided is HTTP auth server :9000. So if you see 9000, that is the 9000 port of my auth server itself. If you go to the application.yaml, this is my auth server currently, and I have passed the URL for that. So now this particular auth server URL you can define in your host files. Okay, so what you can do is you can go to the terminal, and if you go to cat/private etc host file, okay, and here you can see that this is the host file that if you want, you can change this host file. And here you can see that by default the local host for 127.0.0.1 would be there, and I added one more entry for the host as the auth server over here. That's the only thing that I have implemented. So this is the configuration that you have to add for your auth server to work with that particular URL. So I hope this is clear now. So the configuration for the authorization server is done. Now we need to do the configuration for the basic Spring Security as well for this. So let's add the default Spring Security configuration. So let me just add one more configuration file, and I'll just say default security config. Now you might be wondering, there are a lot of changes and a lot of complex things here, but don't worry, these are very simple, and this you have to do only once. Once this is done, once this is set up, you're good to go always. So this is the default security config, and we need to enable web security, and here I am just adding the configuration. Simple, okay? If you see here, I'm just adding again the security filter chain, and I'm getting the HTTP as the input parameter. What I'm doing, I'm just changing the authorized request. So I'm just doing that all the request coming here has to be authenticated. Okay, any request has to be authenticated with default form login for the authorization server. That's it. Okay, simple thing. Now a lot of configurations are done for the auth server. Very little things are left. So now we have defined the custom user detail service. Like this is the user detail service that you have to use to validate the user. We define the authorization server config, like how the authorization server should work. We also defined how your basic security should work, like all the requests should be validated. So now one thing is left is your authentication provider, like authentication manager, how you should be managing your authentication. So whatever the user object from the custom user detail service I created right from here, now with this particular details, with this user that I have created, I need to validate the credentials that I'm providing from the input. So whatever the input that I'm providing, that has to be validated against this users, right? Whatever the users that I have mentioned. So I need to define the custom authentication provider as well, so that the users are validated against. So let me just create the configuration for that. So let me just create the service and I'll just say custom authentication provider. I'll annotate this with service, and this custom authentication provider will implement authentication provider. Okay, and we need to implement the method as well, that is the authenticate. Okay, these are the implementations that we have to provide. Now how we can authenticate, we need the custom user details service as well. So whatever we have defined over here, so let me just inject that. Private custom user details service. I'll just auto wire it, and I'll also need the password encoder over here. So let me just auto wire it. Private password encoder. And now this is the authenticate method in which we have to customize it. Okay, so let's do this. So let's get the username password string username equals to, I'll get authentication dot get name string password equals to authentication dot get credentials dot toString. Now user details object we need from the security. User details equals to custom user details service dot load user by username, and here we need to pass email. So email is your username, will get the object of the user details. Let me just make it to user, that is better. Now we need to validate the user. So let me just create the method check password, where you are passing the user and password. Okay, and let's create this method, and this is your raw password. Okay, let's implement this. If, let me rename. Okay, check password. I don't know why I make this much spelling mistakes. Okay, now if password encoder dot matches raw password with user dot get password, return new username password authentication token. Okay, where we need to pass user dot get username, user dot get password, and user dot get authorities. Else return new bad credentials exception. I'll just say bad credentials. Okay, throw. Simple. So here you can see that we are just authenticating, okay, with the authentication manager over here, and we need to add the support as well. So let me add this. Return username password authentication token dot class dot is assignable form authentication. Okay, so this authentication has been handled over here. So you can see that simple thing, authentication is handled. Now this custom authentication provider we need to bind. Okay, so let's do that. So let me go to the default security and let's bind this over here. Let me create the object private custom authentication provider. Okay, I'll auto wire it, and let me create the bean of authentication manager. Public void bind authentication provider, auto wire it, and I'm just injecting authentication manager builder auth, and this authentication manager builder dot what is the authentication provider, that's the custom authentication provider. Okay, so we just bind this custom authentication provider to our authentication manager builder. That's it. You can see it's simple, looks difficult but simple. So now your authorization server is ready. All the configurations are done. It can handle all the requests. Now we have enabled everything. Now we need to register our client. We need to add the configurations in our client to talk to this authorization server. Okay, as every authorization server will give you the details to handle everything in your system, we need to do that. So if you go to this authorization server config, you can see that these are the register client repositories. These are the details that we need to handle. So this is our Spring Security client. Here we need to handle everything in our application.yaml. Currently we have the Spring data source on JPA. Now we need to add for the Spring Security auth. So let's add that. I'll just copy the details and I will explain you everything. If I type, there will be some error in the indentation and we might waste a lot of time. So let me just copy the details. After the DDL auto update, I'm just copying every details over here. Okay, so now you can see that it's part of Spring Security auth 2 and we are adding the client. Now after this client, these are the custom things now we need to handle. Custom is registration. So this is the name of your client. Okay, we are adding the registration client and the name is API client OIDC. Okay, provider is Spring. Now this Spring provider I will get into details. The client ID and secret, that is the API client and secret. This is the same thing that we have defined over here. That is the API client and secret. Okay, API client and secret. That is the API client OIDC. Authorization grant type is authorization code. This authorization code we have enabled. You can see that authorization code we have enabled grant type. Then redirect URI. Now this redirect URI is standard. HTTP, your server name, your port, /login, /auth2, /code and registration ID. Your registration ID is nothing but your API client OIDC. Okay, and the same URI, whatever it is configured over here, the standard format you can see over here. Okay, HTTP 1270.0.1 8080 login auth2 code and API client OIDC. That is the client over here that you have defined. Makes sense, right? Now the scope is OpenID for your authentication, as we have implemented, as we have added the OpenID as well, and the client name API client OIDC. And now the below one you can see it's for the API client authorization code, where the provider details, client ID and the client secret we have mentioned the same. Authorization grant type is authorization code and the redirect URI is 127.0.1/8080/authorize. Once authorized, this is the redirect API it will be redirected to. Okay, and the scope we have defined is API.read. So this is the scope that we are going to define, and the same thing we have defined you can see in the authorization server config. You can see that API.read scope, and the other one was OIDC scope.openid. The same thing we have defined over here, that is the OpenID scope. And the provider, you can see the provider Spring issuer URL, it's http:/auth server:9000. If you come back over here, you can see that we have defined the issuer over here, that is the auth server 9000. So the same configuration we have defined over here, similarly you can define according to the name that you have given over here. So this is the name, according to the name everything you have to provide over here. So if you come, you can see these are the two redirect URL you have mentioned over here, that only you have configured. Okay, and this redirect URL is nothing but the standard format that you have to give based on the client ID or the client name that you are giving, registration ID. So this is the configuration. Now the next thing you need to configure is your web security. So if you go to the config, we have created the web security config. Here we have enabled the web security and we have added the security filter change, where for the HTTP we are disabling this URS and CSRF, and we are adding the authorized HTTP request, and we are permitting all the URLs. This all the URLs we are permitting, but other than that, what all the other URLs we have to be authenticated to go into that. Okay, so let's add that. So I'm adding one more, ant matchers /API anything coming with /API /anything has to be authenticated. Okay, and we need to add the configuration for our auth server as well now. .auth to login we need to add. Now for this to work, we need to add the authorization client as a dependency. So let's add the dependency. So I'll go to the Spring security client and I'll go to the pom.xml file and I'm adding one dependency, and this dependency you can see is for Spring Boot starter auth to client. So this will be my auth to client now. So now if I go back to the web security config, I'll be able to add, let me stop the server and invalidate the cache so everything is refreshing. So we'll give the auth to login and auth to login, and we need to give the login page, which login page to redirect. So we can define auth to .login page, and we need to pass the URL. So the standard URL we need to pass, that is /auth2/authorization/ your registration ID. So whatever the registration ID that you have defined, right? If you go to your application.yaml, that is the API client OIDC. So you will be giving API client OIDC, your login page. .auth to client customizer with defaults. Okay, with default configuration we are enabling everything. That's it. So this is the configuration that we need to add. Now /API, right? So if you go to the hello controller, so let me just add the /API /hello over here. Okay, so this is the API that we are going to call, and it's just returning hello, welcome to daily code buffer. Okay, so let me just start the auth server. So your auth server is started, and let me start the client as well. So I started the client as well. Okay, now you can see that it's connected. Let me just go to the browser. Okay, now let's go to the localhost. Let me just open the debugging tool. I'll go to the networks. Let me just close this. Okay, and let me go to the localhost 8080 /API/hello. For this, my request should be redirected to the authorization server for authentication. Okay, and here you can see that it has been redirected. Okay, now here I need to provide the authentication. Here you can see that it is redirected to the auth server colon 9000/login page, and here you can see that your hello controller was there, right? Your hello API, it was called and it was sent to the API OIDC. This is a URL. You can see that auth2/authorization/API client OIDC, and you can see that the authorize was called with the response type, client API, client ID, so scope information, state information, redirect URI, everything is passed. The same flow that we have seen with the playground, right? That these are the API, these are the endpoints will be called. Okay, and after that it's been called the authorize. So we need to get authorized. So what I'll do, I will add the details. So if I add any details, okay, and if I try to sign in, you can see that no user found. So this is the particular flow that will happening. So it has to be authenticated. Okay, now if I give the correct information, if I go to the MySQL, okay, if I get the Nikhil over here, okay, if I pass nikhil@gmail.com, and the password for that we had kept was 789. Okay, so if I go back to the browser, okay, if I do 789 and if I sign in, you can see that it has been redirected back. Okay, if I go to the /API/hello, you can see that I'm getting the proper response now. Okay, Hello, welcome to Daily Code Buffer. Now if I want to get the logged in user information, that also I can get using the principal. So let me just add that as well. So if I go to the controller, hello controller, and here if I inject the principal object, principal from the java.security, and here I'll just say hello, and I'll just define principal dot get name. Let me restart my client. Okay, my client is restarted. Now let's go to the browser. Let me just open the incognito mode, and I'll just do localhost 8080/API/hello. Okay, you can see that I'm redirected back to the login page. And if I give the proper information, let me just copy the email ID. Okay, and I'll give the password 789, and if I click on sign in, you can see that I'm redirected back. I'm getting this error because I have not defined this particular endpoint, but instead of this, if I go back to API/user, hello, you can see that I'll get the user as well, that nikhil@gmail.com is signed in. Okay, and as I have defined everywhere as 127.0.0.1 instead of localhost, if I hit this URL instead of localhost, okay, let me just close this. Let me just open the incognito again, and if I hit this, I'll get the login page. Let me just give the Nikhil information over here. And if I do 789, then it should redirect to the correct page. You can see that I'm getting the correct page now, right? It's been redirected correctly. So this way you can see that we have implemented the auth2 with OpenID authorization server and the client as well. So both of them can interact with each other, and only the authorized resources are allowed. Now what if you have a resource server as well? So your resource server is there where only the authenticated user can access those authenticated resources. And if you want to access those resources using your client, how to handle that? So let's create the resource server. Let's create one more application, add into our project, and let's go around how to fetch the data from the resource server as well. So let's try to do that. Let me just close this. Let me go to the start.spring.io. I'll just do com.dailycodebuffer, artifact as auth resource server, packaging as jar, java version as 11. Okay, and here what I'll do, I'll just add the web dependency, I'll add the Spring security dependency, and I'll add the auth resource server dependency. Okay, that's it. Let's generate the project and add in IntelliJ IDEA. So let's generate it. Open in Finder, unzip it. Let's copy this. Okay, let's go to IntelliJ IDEA and add as a module in our main project. Let's go to pom.xml file. I'll add the auth resource server and maven reload projects. Here you can see that this is the auth server. Now let's configure the auth resource server as well. So what I'll do, I'll just first change the application.properties to application.yaml, and I'll just do server.port as 8090, and I'll add the configuration for the Spring security as well. So what I'm adding, I'm just adding spring.security.auth2. This is a resource server, JWT, issuer URL is auth server 9000. So this is my issuer URL. So I just configure this as a resource server. Now we need to handle the basic Spring security as well. So let's go ahead and do that. So here with the Java, let me just create the new package, and I'll just say this is a config package. And within this config package, let me just create the Java class, and I'll just say resource server config, and I'll enable the web security. Here we need to create the security filter chain bin. So I'll just define security filter chain, and this is a bean. Now you might have noticed that we have everywhere in all the application we have defined the security filter chain. Okay, and I'll just define the HTTP security. Now we need to configure this as the same way we have configured in our auth server and the client as well. So we'll just define http.mvc matchers. Now all the API request, okay, we are targeting, and it should be authorized request .mvc matchers /API/ all the API request, and here we need to add the exception. Okay, let's add the exception dot access. We need to provide the access, and it should have the access only. So here you can see that we are calling the method that access only has authority API read. So here you can see that we have defined the scope. Okay, so whenever we are defining the scope for the authority, we need to define as scope underscore and whatever the scope it is. So we are just handling the API read now. If there is multiple, we can add the multiple access over here. So this is the API read that we are defining. Dot and auth to resource server, or auth to is the resource server dot JWT. Okay, and we need to return http dot build. Simple. So here you can see that simply we just define the security filter chain where we are authorizing all the requests where scope is API.read. Now let's create the resource or the API for this resource server. Okay, so what I'll do, I'll just create one package, and here I'll just say controller. Inside this controller, let me just create one Java class, and I'll just say user controller. Annotate with REST controller. Okay, and let me create one method, public string of array get users return new string, and here I am defining multiple users. Okay, let me just define Shabir, Nikhil, Shivam, and let me annotate with @get mapping /API /users. Okay, you can see that the simple API that we have created. Now suppose this is the API provider, this is the resource server. Okay, and now in your client you want to call this API, but it has to be authenticated, right? It has to be within this scope, whatever the scope we have defined. If you're passing the scope and it's matching with the scope, then only we should be able to get the details. So we need to configure our client to handle the web client. So we'll be using the web client to call this particular URL and to fetch the data. So we need to configure our web client as well. So let's go ahead and do that. If you go to our Spring Security client, and in the pom.xml file, we need to add the dependency of the reactive Spring, as we are going to use the web client. Now this is nothing but you are calling one of the APIs that is behind the authorization server, that is your resource server. You want to call those resources, you want to utilize those resources. To utilize those resources, your web client has to go around, get authenticated, and should get you the data. That's it, right? It's simple as that. Whatever the API that you are directly calling from the client, and if you want to call another API from the another resource server, it has to be authenticated, it has to be within the scopes that you have mentioned, then only you should get the details. So that's what we are trying to implement. So let's add the dependency for that. So let me go to the file over here within the dependency. After the auth2 client, I am adding two more dependencies, and you can see that it's a Spring Web Flux dependency and Reactive Native dependency. So we can use the web client. So now as we are going to use the web client, we need to configure it as well. So let's go ahead and configure it. We will create the configuration class for that. Now this all things, you can see whatever configuration I'm adding, that is only one-time configuration. So the only challenging thing to understand is that configuration part in the starting. But once you add the configuration, once you get the hang around of it, it's very easy to implement the other things. So as I need to configure the web client, I'll create a new class that says web client configuration. Okay, and I'll annotate with @configuration. Okay, now there is a default configuration. Okay, you can directly add the configuration, so I'll just add the configuration so you can directly utilize it. So here you can see that I've just added the configuration. Let me import all the classes. So okay, I'm sorry, I just added the web client configuration at the wrong place, so let me just delete from here, or let me just Control X from here. Go to the src in Spring Client, in Java config. Here I need to add. Okay, and from the pom.xml file, let me just correct it out if I have done any mistake. No, it's all good. In this pom only I have added. Okay, make sure that if you are working with multiple projects, this type of things happens, this type of issue happens, so make sure that you are adding at the correct place. So you can see that it's just a filter function added, and it's applied that web client will be auth2 client to configure. Okay, auth2 is configured to use, and here you can see that this is the authorization client manager, where it is using the authorization code refresh token and all those things. So this is just a default. You can see it's just a default implementation. You just copy all these details, you just enable the beans web client and auth2 authorization client manager, and you're good to go. You don't have to do anything. Now once this is implemented, we can use web client to call that particular API that we have added in the in our resource server. Okay, so let's do that. So let's go to the controller, let's go to the hello controller, and here we can call that API. So let's do that. So right here I am creating one method, that is public string of users. Okay, and you can see I'm just passing as a get mapping and /API/users, and here we need to inject auth2 authorization client. Okay, and which authorization we need to annotate with registered auth2 authorization client. Okay, so we need to bind it. So which particular, so if you go to the client, okay, if you go to the resources application.yaml, this is the one API client authorization code. This is the one that directly we are binding, that it will be using the API client as the client ID, secret, the authorization code, the URL, the scope, all this information for our authentication for our resource server. Okay, so let's go over here and let's define this, that this is the one that we are going to use. Hope so now it is visible. Now we need to use the web client to call that. So let me just auto wire the web client as well. So I'll just do private web client and I'll auto wire it. Now return this dot web client dot get dot URI. So we need to pass the URI. So what would be the URI? This one, http 127.0.0.1:8090. that is the port number that we have defined in our resource server, and /API/user is what we have defined as the endpoint to get the resources. Okay, and then we'll define dot attributes auth2 authorized client. Okay, so in the attributes that you have to define is server auth2 authorized client exchange filter function. Okay, this is what, if you go to the web client, this is what you have defined, right? So that one we have defined, and let me just do the static import, and here we'll define the client dot retrieve dot body to mono. This is of string array dot class dot block. Okay, so the error I'm getting is because of the attributes. It should be attributes. Okay, it's simple thing. Okay, now this particular method is ready. It is trying to get the data from the resource server that we have defined, and after authorizing, I am getting the data. So now let's start the server. Let's start the auth server first, then let me start the resource server as well. I'm sorry, the resource server only started. Let me start the auth server as well, Spring Client as well. Okay, so here you can see that everything is started. Now if I want to call the hello controller slash API slash users, it will try to call this particular resource server that is behind the authorization server as well. After authenticating with the proper scopes only, I'll get the resources. So let me just go to the browser. Let me open the incognito window. I'll just use this slash API slash hello. Instead of that, I'll just define users. Okay, it should be redirected to the login page as it was intended. Then I'll give the user information and password is 789. And here you can see that it is asking for the consent from the resource server that you should be authenticated. You can see that API client. What is the API client? API client is nothing but your client. If you go to the application.yaml API client, this is your client, right? And what it is asking, you can see that it wants to access your account, that is this one nikhil@gmail.com. The following permissions are requested. What is it scope? Only we have defined API read, so we'll just give the API read consent and submit the consent. And you can see that I'm getting the data over here. So you can see that my resource server is behind the authorization server. Once the consents are there, after that only I'll be able to access those resources. So that's how the complete flow with the auth to an OpenID for authorization server, resource server and the auth client works. So if you want to understand more in depth about everything, I'll add the documentation link in the description below so you can check that out. I'll also link the different articles where I have read about it. I'll link everything in the description below so you can check that out. And there are different flows as well, like we just use the authorization code flow. There are different flows also available, so you can try and implement those flows as well, but the fundamentals are same. Just focus on the fundamentals, just try to understand everything and learn accordingly. Ideally there will be very less chances where you will get to implement all this kind of securities, because nowadays there are a lot of third-party tools available like Okta, Auth0, like Gmail, GitHub and everything, right? So most of the times people will be using that only, and it is suggested to use it because they have done a lot of work on that. The tools are really good, so we can directly, without worrying everything, we can directly get all those security features. And I'm also not a security expert by any means, but this is what I have understood and I've implemented. And this is also not a particular flow that you will be implementing in the production. There are a lot more extra features, there are a lot more extra configurations that you have to do within this as well to make your application more secure. So these are all the details that I wanted to share about the auth server, resource server and client and everything. If you have any doubts, then do let me know in the comment section below. And if you want to learn more about how to package those applications and to deploy to Kubernetes and to learn Kubernetes, then these are the videos, and you can check out these videos to learn more about the Kubernetes and how to deploy these services to the Kubernetes cluster, and also how to automate those deployments as well. So that's all I have to share. If you have any doubts or anything, then as always, do let me know in the comment section below. I'll try to help you out as soon as possible. So I hope you have enjoyed this tutorial. I know it was very long and it was a complex as well, but I have made my best effort to make it as simple as possible. So hope you enjoyed it. And if you like this video, give us a thumbs up and subscribe to the channel for the upcoming awesome videos. If you want, you can join this channel as well and support me. So that's all in this video. I'll see you in the next video. Till then, happy coding. Bye bye.